Waiting for the instructions. Ladies and gentlemen, you are requested to keep your mobile phones on silent mode, please. Thank you. Knowledge grows when it is shared, and research is the engine that propels it forward. A very pleasant morning to everyone. It is our proud privilege to extend a warm welcome and cordial felicitations to our distinguished guests and dignitaries to the Second National Conference on Technological Innovations and Environmental Sustainability 2024. We extend our warm welcome and cordial felicitations to the Honorable Founder President, Amity Education Group, Dr. Ashok K. Chauhan, and Honorable Chancellor and Chairman, Amity University, Madhya Pradesh, Dr. Asim Chauhan. We also extend our heartfelt greetings to all the esteemed dignitaries and vice chancellors from the various campuses of Amity universities who have joined us online. A special welcome to our Honorable Chief Guest, Dr. Ayanada Arunachalam, Director ICAR, Central Agroforestry Research Institute, Jhansi, Uttar Pradesh. We are also privileged to extend our cordial felicitations to Lieutenant General V.K. Sharma, Ati Vishishta Seva Medal, Honorable Pro-Chancellor and Senior Vice President, Ratnan Balved Education Foundation. Professor Dr. R.S. Tomar, Officiating Vice Chancellor and Pro-Vice Chancellor, Amity University, Madhya Pradesh. Professor Dr. M.P. Kaushik, Pro-Vice Chancellor Research, Amity University, Madhya Pradesh. The Registrar, Deans, Directors, Head of Institutions, faculty members, research scholars, and participants who have joined us online. We also extend a warm welcome to all the members of the Amity family who are present with us today. We're gathered here today for the Second National Conference on Technological Innovations and Environmental Sustainability 2024. It is an honor to be gathered here with eminent experts, esteemed faculty, dedicated researchers, and bright students, all united by a shared commitment to sustainable innovation and environmental resilience. Before we commence with the proceedings, we would like to invoke the blessings of the divine. We respectfully invite our esteemed dignitaries to light the lamp, symbolizing the pursuit of knowledge and seek the guidance of Ma Saraswati. Sir, please.
श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती शेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदा जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां
Thank you, esteemed dignitaries, for your participation in this auspicious ceremony. May the light of wisdom guide us through the enlightening discussions and deliberations that await us at this conference. We request Professor Dr. R.S. Tomar, officiating Vice Chancellor, to kindly welcome our honored chief guest, Dr. Ayanada Arunachalam, with a sapling. Sir, please. Thank you, sir. This conference is organized by the Department of Environmental Science, Amity School of Life Science, with support from the institution's Innovation Council. Such collaborative efforts enable us to create a platform for exchanging knowledge and fostering groundbreaking research. The theme of this conference, Technological Innovations and Environmental Sustainability, speaks to the challenges and responsibilities of our times. We live in a world where rapid technological advancement must be balanced with environmental stewardship. Today's conference will delve into the integration of innovative technologies and sustainable practices, exploring solutions that serve both progress and the planet. Now, to formally open this significant event, we are delighted to have with us Professor Dr. Kuldeep Dwivedi, convener of the Second National Conference on Technological Innovations and Environmental Sustainability, head of the Department of Environmental Sciences and Deputy Dean of Academics at Amity University, Madhya Pradesh. Professor Dwivedi's leadership and vision have been pivotal in organizing this conference, which promises to foster valuable dialogue on critical issues in sustainability and innovation. I request sir to kindly deliver the welcome address. Sir, please.
Good morning to all of you. I'm privileged and honored to extend the welcome address of the Second National Conference on Technological Innovation and this is in the series of the conferences that we have envisioned to organize every year, because technological innovations and sustainability, they need to go hand in hand. And since we are a university where we have young minds, we need to foster in them the values as well as the knowledge, so that they have a balanced approach and the technological advancement doesn't become something of a bane to the path of development that we need for a country like India. And in today's evolving world, technological innovations are very critical in addressing the pressing environmental challenges that we are facing. And the issues that we are facing are of the areas like energy. We need solutions, renewable energy solutions like solar power, wind power, to advancement in sustainable transportations and waste management. The role of technology in safeguarding our planet cannot be overstated, and we need not emphasize or restate that today we are living in an era where we need to be very sensitive to the different environmental issues that we are facing. So this conference, it presents a very timely platform to discuss, deliberate, and ideate on such very important topics. The conference will provide invaluable insight into how we can transition from a linear to a circular economy, promote sustainable agriculture, and ensure efficient resource management. And I have the privilege in welcoming our esteemed chief guest, Dr. Ayanada Arunachalam, Director, ICAR Agroforestry Research Institute, Jhansi, Uttar Pradesh. I thank you, sir, for accepting our invitation and gracing this occasion in spite of a very busy schedule And he told me when I invited him that he has a meeting at 1:30 p.m. at his headquarters, and he will be rushing back after this program. But I thank you, sir, for taking all the pain to come over here and share your views, which you will be deliberating to our young scholars, researchers, and faculty members. We have a guest of honor, Sri Shankar Singh ji. Although he's not present here, but he will be arriving. And I also extend a warm welcome to him. Due to some reasons, he is late, and he is the Prantiya Sanyojak of the Paryavaran Gatividhi, New Delhi. So when he comes, we will have his formal welcome. I extend my welcome and gratitude to the Honorable Founder President, Dr. Ashok Singh Chauhan, Honorable Chancellor, Sir, Dr. Asim Chauhan, and Honorable Pro-Chancellor, Sir, Lieutenant General V.K. Sarma, Ati Visesh Seva Medal, for the constant guidance, support, and motivation to organize this event. My gratitude to Honorable Vice Chancellor, Amity University, Madhya Pradesh, Professor Dr. R.S. Tomar, who has guided and motivated us to organize this conference. Your constant guidance and meticulous planning to the smallest of the details has ensured that we work as a team and make Amity a global hub of knowledge and create an ecosystem which is environmentally sustainable, socially just, and inclusive. I welcome all the delegates, participants from different parts of India. We will be having 5 technical sessions and parallel sessions that will be organized on the June platform online. And some of the delegates are present over here physically also. I welcome them because without their participation, this conference wouldn't have been possible. I'm glad to inform you that we received around 70 research papers, which will be released as a souvenir just after this conference, where their research work has been compiled in the form of a souvenir. I welcome all the faculty members, HOIs, HODs, deans, research scholars of Amity University, Madhya Pradesh, who are present over here. My heartfelt welcome to all the students of AUMP who are present here, and I sincerely hope that this conference will offer students and young researchers invaluable insights into the rapidly advancing field of sustainable development and the interdisciplinary nature of science and technology, which are critical to addressing our future challenges. Actually, through all these events, try to inculcate in them how they will be taking up their higher studies, research, and their work ethics. My gratitude to Madhya Pradesh Council of Science and Technology, Bhopal, for supporting this conference. And with these words, I welcome each and every one of you, and I hope that the deliberations of this conference will enrich your knowledge perspective and help you in undertaking research which is sustainable and innovative, and which is in tune with the goals and missions and visions of Amity University, Madhya Pradesh, as well as the Government of India. With these words, I thank you and welcome you again. Thank you.
Thank you, sir, for your welcome address. The conference has received heartfelt messages and warm wishes from esteemed personalities who have sent their words of encouragement and support for this conference. Their inspiring messages reflect the shared commitment to our theme of technological innovation and environmental sustainability. It is my honor to present these messages to you. The first message is from the Honorable Governor of Madhya Pradesh, Shri Mangubhai Patel. Honorable Chief Minister, Madhya Pradesh, Dr. Mohan Yadav. Honorable Founder President, Dr. Ashok K. Chauhan, Amity Education Group. Honorable Chancellor and Chairman, Dr. Asim Chauhan. Honorable Pro-Chancellor, Lieutenant General V.K. Sharma. Officiating Vice Chancellor, Amit University, Madhya Pradesh, Professor Dr. R.S. Tomar. Pro Vice Chancellor Research, Professor Dr. M.P. Kaushik. Thank you, dignitaries. We are delighted to receive your warm wishes and blessings. We're deeply honored to invite Professor Dr. R.S. Tomar, an esteemed academic leader and the officiating Vice Chancellor and Pro Vice Chancellor of Amit University, Madhya Pradesh. Professor Tomar's exemplary leadership and dedication to academic excellence have been instrumental in fostering an environment of innovation, research, and holistic education at the university. His vision and commitment to nurturing future leaders make him an inspiring figure for both faculty and students. To begin this remarkable event, my request our respected chairperson of the conference, Professor Dr. R.S. Tomar, to deliver the address. So please.
Good morning, everyone. Today, chief guest, Dr. Arunachalam, Professor Kuldeep Dwivedi, the Registrar of the University, Director Administration, Director Hostels, HOIs, HODs. Today, this particular conference, though it is second in its series, that is on environmental sustainability, in view of the technological innovations which are taking place all over the globe. As far as technological innovation is concerned, I think India being the developing country, we need them most. And when it comes to technological innovations, then of course, it is at the cost of environmental degradation. But then question comes, if we do not go for development, then how we can go shoulder to shoulder with the countries all around the globe? And how our generations to come can sustain on this earth? So it's the question of the nation. And when the question of nation comes, the nation is first. And that's why we sometimes overlook the environmental degradation because we need development. Being the scientist, being the environmentalist, being the researchers, it's our responsibility to find out the solutions so that the development is must, development should take place. At the same time, our environment should be degraded to a very minimal level. How we can do that, how it can be done, these are all things to be planned through these kinds of deliberations and discussions. This is the purpose of organizing such kind of programs. You all know, environment is sum total of everything around you. If a layman, somebody asks you what is environment, anything which is surrounding you is environment. It may be abiotic or abiotic. You all understand, those who have studies EVS in their first semester or somewhere else in MSc or in other labels, they know this, what is environment. So we have to take care of this thing. When we say biotic, then biotic didn't include only the human beings. The biggest problem of today's development is this, that human being at the top thinks that whatever we shall do for the welfare of us only. Do it. But take care of other biotic components as well. You all know what are those biotic components. Starting from the producer level, if I say the primary producers, you all know that. Then all consumers. So first of all, take care of those producers. The plants, the herbs, which are there on the earth, ocean, everywhere. First of all, we have to conserve them. If we could conserve them, then certainly all consumers can sustain on the earth. So first thing is this is fundamental knowledge everybody should have. And we say that human being is omnivorous. It is also called as the consumer which can eat everything. एक किसी ने कहा था कि इस दुनिया के इंसानों ने पानी में तैरने वाली नाव और आकाश में उड़ने वाले हवाई जहाज को छोड़कर सब कुछ खा लिया. It means the human being can eat anything. And when I say human being, then it's not only we people in India, all around the globe. So as I told you, the technology innovation is important and it should be done. We should come up with new ideas, and these new ideas will certainly add to the environmental system. Find out the problem around you. Problem is a problem for the layman, but it's an opportunity for the scientists and researchers. Identify the problem and work on that. And that's why all our PhD scholars, they know this, that they are assigned a problem when they start their PhD work. It is not called research topic. It is called problem. Means you have to find a solution by the time you complete your PhD degree. And that is the purpose. So when the students of PhD can do this, all others can do this. Because research is not limited to the students of doctorate studies. It is open to all. And that's why all the students of whether BTech or MTech or MSc, they are all open to such kind of short intensive trainings in which you learn some research procedures, some technological things, so that you can develop something and you can come out with some ideas. Come up with some ideas, get them patented, and you will find a career in that. So this is my message to you all for today's this national conference. That yes, technology innovation should be done. At the same time, we should take care of the environment as well. So thank you very much. Thank you all.
Thank you, sir, for your profound remarks. We also accord a warm welcome and cordial felicitations to our esteemed guest, Shri Shiv Shankar Ji, Prantiya Sayojak Paryavaran Sanrakshan Gatividhi, Madhya Bharat. We request Professor Dr. Kuldeep Dwivedi, convener of the conference, to kindly welcome our honored guest with a sapling. Sir, please. We are delighted by the esteemed presence of Mr. Jaideep Singh. Thank you, sir, for being with us. Proceeding further, it is indeed a privilege to introduce our esteemed chief guest, Dr. Ayanadar Arunachalam, Director of ICAR, Central Agroforestry Research Institute, Jhansi, Uttar Pradesh. Dr. Arunachalam is a distinguished scientist and a leading authority in biodiversity, forestry, agroforestry, and environmental management. His academic journey marked by a BSc and MSc from Madurai Kamaraj University, a PhD from Northeastern Hill University, and a DSc from Arunachal University of Studies, demonstrates his commitment to advancing scientific excellence. With over 25 years of impactful service, Dr. Arunachalam has excelled in various pivotal roles, from lecturer and principal scientist to assistant director general, and now director at CAFRI. A prolific researcher, Dr. Arunachalam has led and contributed to over 20 projects, serving as principal investigator, task force coordinator, and project coordinator. His outstanding contributions to forestry and agriculture have been honored with prestigious awards, including the ICFRE Award for Excellence in Forestry, the Dr. M.S. Swaminathan National Award for Hill Agriculture, and Lifetime Achievement Awards. As a fellow of multiple national and international scientific academies and the chief editor of the Indian Journal of Agroforestry, his work continues to shape and inspire the field. We now invite Dr. Ayanadar Arunachalam to kindly deliver his address. Sir, please.
Oh. Good morning, everyone. It's a great pleasure to be rejoining the Amity family on this very splendid occasion of a national conference. I must first confess that I was too late and all of you had to wait. And you were so happy to wait. Happy Children's Day. And you know, children are very sweet. And so the world has decided to celebrate this day as also a global diabetes day. Oh, don't mind. And this is the irony, जिसको हम लोग हिंदी में बोल देते हैं बड़े आराम से विडंबना। हम लोग दो एक्सट्रीम पे हमेशा ही काम करते हैं। एक तरफ हमारे ऑनरेबल वाइस चांसलर, Honorable Vice Chancellor was not echoing, the mic was echoing. Don't worry. He made my speech very easy by making a statement कि हमें डेवलपमेंट तो चाहिए, लेकिन वो ऐसा डेवलपमेंट हम चाहते हैं बिना कुछ किए, मतलब बिना कुछ कुछ करोगे तो कुछ डिग्रेड जरूर करोगे। और माँ भी अपने बच्चे को करती है तो अपने खोप को खराब करके ही करती है। सो इट्स अ ग्रेट पेन दैट कम्स इन द middle of us when we want to deliver certain things. अब as a university student, what are you expected to deliver? And an institution like MET, what is it expected to deliver? इसके संबंध में भी आप लोगों को काफी चीजें जानकारी लेने पड़ेंगे और सोचने पड़ेंगे और अपने जीवन काल में अपने जीवन में उतारना पड़ेगा, तभी हम लोग इस कॉन्फ्रेंस की जो मंशा है विच इज एनवायरमेंटल सस्टेनेबिलिटी। अब पता नहीं इस परिसर में जो बैठे हैं कितने लोग अपने को प्रकृति की भागीदार नहीं मानते हैं, मुझे नहीं मालूम। लेकिन अगर ऐसा कोई सोच रहा हो कि हम प्रकृति की भाग नहीं हैं, वो इस पृथ्वी में रहने लायक है ही नहीं। और इस पृथ्वी में जैसे हमारे ऑनरेबल वाइस चांसलर साहब ने भी बोला कि और भी जीव प्राणी लोग हैं जिनको भी खाना चाहिए, चारा चाहिए, पानी चाहिए, हवा चाहिए। लेकिन हम जितने भी पॉलिसीज इस देश में बनाते हैं, हम अपने सोच के हिसाब से बनाते हैं। नेशनल वाइल्ड लाइफ एक्ट भी बनाया तो हमने जानवर से कुछ नहीं पूछा, ना वाइल्ड एनिमल से पूछा, कुछ नहीं पूछा है। तो ये चीज आप हर एक पॉलिसी को लेके देखे आप समझ पाएंगे कि ये कैसा हुआ है। इसको थोड़ा सा एक अलग लेवल पे डिस्कशन लेने के लिए ही नेशनल साइंस एंड टेक्नोलॉजी पॉलिसी को 2019 में 17 से ही डिस्कशन हो चुका था, 19 में फाइनली हम लोग वी ब्रॉट साइंस टेक्नोलॉजी इनोवेशन पॉलिसी। हमें केवल साइंस तक नहीं रहना है, टेक्नोलॉजी तो डेवलप करना ही है, और वो भी लगातार इनोवेशन के साथ। इस इनोवेशन का मतलब तो हिंदी में बहुत लोग जानते ही होंगे, जो हम लोग 3 इडियट जैसा फिल्म से हम लोग सीखते हैं, जुगाड़। जितना आप जुगाड़ कर सकते हैं करिए, उस टेक्नोलॉजी को जितने सरल से इस्तेमाल कर सकते हैं अपने जीवन काल में वो करिए, उसको हम लोग इनोवेशन कहते हैं। इनोवेशन का मतलब ये नहीं कि बहुत ऊंचा सोच नहीं है, हर एक आदमी इसको कर सकता है। लेकिन एनवायरमेंटल सिस्टम टेक्नोलॉजी का तो हम देखते हैं, समझते हैं, यूज करते हैं अपने जीवन काल में, लेकिन पर्यावरण सुरक्षित है कि नहीं इसका मापदंड क्या है? हम कोई चीज देख के बता नहीं पाएंगे कि यह पर्यावरण सुरक्षित। कई चीज जो अनदेखा हो जाता है इस खामिया में, तो इसीलिए पंच महाभूत की जो हम लोग बड़े पुराना कालों से हम लोग सीखते आ रहे हैं, उनको समझने की जो हमारे ऋषि मुनियों ने अपना जीवन काल गुजार दिया हमें समझा समझा के, उसको बचाइए और पर्यावरण को मॉनिटर कीजिए, निगरानी रखिए उसके ऊपर, अपने वातावरण के ऊपर निगरानी रखिए। ये मत सोचिए कि कोई और आके करेगा, करना तो हमें ही है। अगर कोई और आके करेगा बोल के आप सोचें, अगर उसी सोच के बीचों बीच इस ऑडिटोरियम में एक टाइगर प्रवेश किया है, सिंपल वो अपना चल रहा है, लेकिन कोई आदमी यहाँ बैठा मिलेगा, तो वो स्थिति पैदा ना करें। अगर हम टाइगर को बचाना है तो टाइगर की अपने घर को हमें बचाना है। अगर उसकी घर बच जाएगा तो टाइगर वो सुरक्षित वहीं रहेगा, बाहर नहीं आएगा। तो इसलिए अपने माननीय प्रधानमंत्री जी भी एक अपील किया है इस देशवासियों से कि हर एक आदमी कम से कम अपने जीवन काल में अपने माँ के नाम एक पेड़ जरूर लगाए। हर आदमी अपने माँ को प्यार करते हैं तो उनके नाम पे लगाइए, उनके पिता के नाम पे भी लगाइए, अपने नाम पे भी लगाइए, अपने बच्चों के नाम पे भी लगाइए। सारे को प्रेरित कीजिए कि अपने जीवन काल में एक पेड़ जरूर लगाएं और आने वाले पीढ़ी को कुछ हरा हरा प्रकृति और पृथ्वी दे के जाएं। इसी को कहते हैं सस्टेनेबिलिटी। आप यहाँ कई लोग दिख रहे हैं स्मार्ट, क्योंकि सबके पास हो सकता है स्मार्टफोन हो, लेकिन अपने जीवन में अपने अंदर आत्मा से पूछ लीजिए आप कितना स्मार्ट है। और हर चीज हम चाहते हैं प्रकृति के अनुकूल, हम चाहते हैं खेती नेचुरल हो, पर्यावरण सुरक्षित हो। और जैसे हमें कुछ बढ़िया सा जंगल दिख गया तो हम रुक के फोटो खींचने में लग जाते हैं, उस प्रकृति के बारे में समझने नहीं लगते हैं। और कोरोना काल में कितना क्लीन एनवायरनमेंट इस देश ने देखा, वो चीज कोरोना आकर ही दोबारा हमें सिखाना है, ऐसा नौबत ना है। उसके बिना भी हम लोग अपने जीवन काल में कुछ ऐसा कर सकते हैं, भले अपने बुद्धि से या तकनीकी इनोवेशन से। जरूर प्रकृति को बचाइए। जो प्रकृति के स्वरूप काम करेंगे और को एग्जिस्ट करना चाहिए हमें अन्य जीव प्राणियों के साथ। हमें एकदम ऊपर ना सोचें कि हम ही हैं सब चीज, हम ही सोच पाते हैं। हम इसलिए नहीं भी समझ पाते हैं क्योंकि पौधा हमसे बात करने से भी हमें समझ में नहीं आता है कि प्लांट क्या बात कर रहा है हमसे। अगर टाइगर आके कुछ आपको समझाने के लिए आ रहा है तब भी हम उसको सुनने के लिए तैयार नहीं रहे, क्योंकि हमको उनका भाषा नहीं पता है। लेकिन हम जितने भी जानवर को ट्रेन किए हैं, भले बड़े बड़े शेर को भी ट्रेन किया है, लेकिन वो तो समझ जाता है हमारा भाषा, लेकिन हम उनका भाषा समझने पे नाकाम रहते हैं। तो खामी किसके पास है वो पता चल जाएगा आप अपने अंदर आत्मा से जाके। और एक चीज जरूर याद रखिए जीवन में, जो 3 इडियट फिल्म में बड़ी सरलता से दिखाई देता है, कोलगेट के टूथपेस्ट बाहर निकाल दो, दोबारा उसके डाल के दिखाओ। हम इतने काबिल हैं, मतलब हम कुछ भी नहीं कर सकते जो टेक्नोलॉजी कर सकता है। हम जिस पेन से लिखते हैं वो पेन खुद तैयार नहीं कर सकते। हम जिस पेंसिल इस्तेमाल करते हैं उस पेंसिल को खुद अगर तैयार करके बना के फिर लिखो बोलने से हम नहीं कर सकते। हम इतने स्मार्ट हो चुके हैं और ये 5 इंच का जो स्क्रीन में अपने जीवन को उतार चुके हैं। लेकिन प्रकृति बहुत बड़ा स्क्रीन है, उस पर आप अपने को देखिए और हर एक बार आप जब देखेंगे उसको समझने की कोशिश करेंगे, आपके सामने आईना दिखाई देगा आप क्या है। तो इसीलिए इस टाइप की जो नेशनल कॉन्फ्रेंस जो कराया जाता है, केवल पढ़ाई लिखाई की चीजों की नहीं, उसके हट के भी काफी चीज इस कॉन्फ्रेंस में आपको सुनने को मिलेगा, सीखने को मिलेगा। आप एक दूसरे को जान पाएंगे, दूसरों का सोच सुन पाएंगे और अपने जो भला कैसे हो वो भी आप इस तरह से लेके आप कर पाएंगे। हमारा इस प्रयास पर्यावरण सुरक्षा रखने के लिए काफरी ने एक प्रयास किया है, 2 इनिशिएटिव हम लोग लॉन्च किया है झांसी में। एक अम्मा एक पापा, ये एक्रोनिम है, उसको समझने के लिए आप हमारा वेबसाइट में जा सकते हैं। और आपको कहीं ऐसा लग रहा हो कि मैं जा रहा हूँ थोड़ा सा ऐसे झांसी की तरफ, आप जरूर हमारा कैंपस में आइए, आपको पता चल जाएगा उस कोई भी कैंपस को हरा भरा रखना कैसा है। लॉन तो आजकल हर जगह दिख जाता है, लेकिन घने पेड़ बड़े बड़े उस तरह का समय लगता है, तो वो आप लोगों को देखने को मिलेगा। और झांसी स्मार्ट सिटी को हम लोग विश्वस्तरीय स्तर पर हम लोग रजिस्टर किया है। हम लोग ट्रीज इन सिटीज चैलेंज प्रोग्राम में झांसी को दर्ज किया है और हमारा प्रयास ये है झांसी की पेड़ की पॉपुलेशन को, डेंसिटी को 26% हम बढ़ाएंगे बाय 2026। ये चैलेंज हम लोग 2021 से लेके अभी काम चालू है। नगर निगम और शासन सब मिल करके हम लोग इस काम को कर रहे हैं और 2026 को हम लोग इसको पूरा करने का पूरा प्रयास कर रहे हैं। और इस प्रयास में आप लोग भी कुछ अपना भागीदारी देना चाहते हैं, ग्वालियर शहर को भी उसी स्तर पर लिया जा सकता है आने वाले समय में अमेठी के प्रयास से। बहुत बहुत धन्यवाद हमें समय देने के लिए, हमें यहाँ बुलाने के लिए। और मैं जो भी चीज़ बोला होगा सबको पता होगा, ऐसे नहीं कि मैं कुछ नया चीज़ बोला है, लेकिन आप हर जरूर अपने आत्मा से ही पूछिए कि आप हैं स्मार्ट, हर दिन पूछिए। धन्यवाद।
Thank you, sir, for your inspiring address. We're extremely honored by the presence of our esteemed guest, Shri Shiv Shankar ji, Prantiya Sayojak Paryavaran Sanrakshan Gatividi Madhya Bharat. It is our proud privilege to invite the honorable guest to kindly come to the stage to share his invaluable thoughts with us. Mananiya Shri Shiv Shankar ji.
तो आज हम सभी लोग इस स्थान पर इसलिए इकट्ठा हुए, एकत्रित हुए। हमसे बहुत ज्यादा अंग्रेजी के शब्दों की अपेक्षा ना करें आप लोग। हमसे पहले लोगों ने बोला ही होगा, आप लोग समझदार हैं, समझते ही होंगे, इसलिए मैं नहीं। लोग ध्यान देना, अच्छा लगेगा। आपसे एक करबद्ध आग्रह है कि मैं आपके सामने केवल 30 मिनट के लिए उपस्थित हूं। कुछ करड़ीय बातें करूंगा, कुछ आपसे अपेक्षित बातें करूंगा जो आप कर सकते हैं। ये पूरा विषय हम सबका पर्यावरण के लिए है, इसलिए पर्यावरण से जुड़ा हुआ विषय हम व्यक्तिशः क्या कर सकते हैं, हम अकेले क्या कर सकते हैं, इसी बात की चर्चा करने के लिए मैं आपके सामने प्रस्तुत हुआ हूं। मैं इस सम्मानीय मंच पर बैठे हुए अपने इस प्रतिष्ठान के कुलाधिपति आदरणीय तोमर साहब, हमसे पूर्व जो वक्ता यहाँ पर खड़े थे अरुणाचलम जी, डॉक्टर साहब हैं वो, साथ ही हमारे इसी मंच पे सहयोगी आदरणीय द्विवेदी जी, आप सबका हम ससम्मान सभार भी प्रस्तुत करते हैं। आप सभी विद्यार्थी जन, छात्र जन, यानी मैं दो शब्दों में कहूं तो हमारे छात्र और छात्राएं थोड़ा सा ध्यान को एकत्रित करके कुछ बातों को सीखने का प्रयास करेंगे तो यहां खड़े होने का वास्तव में कुछ फायदा होगा निजी जीवन का। बाकी तो आप तो टीनियर्स हो, आप लोगों की एक अलग शक्ति होती है, अविस्मरणीय क्षण में अविस्मृत शक्ति होती है। आप मोबाइल चलाने के अभ्यस्त लोग हो, आपके सामने आपके अभिभावक भी खड़े हो तो आप मोबाइलों से ही संवाद करते हो। संवाद करना कोई बुरी बात नहीं है, जीवन की सबसे अच्छी पहल है संवाद करना। संवादहीनता जीवन को शून्य कर देती है, इसलिए संवाद करना है तो मैं खड़ा हूं, आप बैठे हैं। हमारे खड़े होने की सिर्फ इतना ही सम्मान कर दीजिए कि आप एक बार सावधान की स्थिति में बैठकर कुछ छोटी मोटी बातें जिसको आप कर सकते हैं उसको सुन लीजिए। ये विषय है, मैं आप लोगों से बताऊं, मेरी जगह पर मेरे बड़े पदाधिकारी आने वाले थे, उनकी अनुपस्थिति में उनकी जगह पर मैं खड़ा होने की धृष्टता किया हूं, इसलिए मैं क्षमा प्रार्थी भी हूं। लेकिन विषय का प्रस्तुतिकरण है, कार्यक्रम है, इस कार्यक्रम में उपस्थित होना, ये सैकड़ों छात्रों के आगामी भविष्य के बारे में पर्यावरण युक्त कुछ बातें करना, ये एक हमारे लिए अवसर भी है। इसलिए मैं आप सभी से संवाद के लिए यहाँ पर उपस्थित हुआ। किताबों में पढ़े ही होंगे, व्यवहार में जाने ही होंगे, विचार से समझे ही होंगे कि पर्यावरण एक वैश्विक समस्या हो चुकी है। यह सृष्टि 9 अरब से चलती है। अध्यात्म की दृष्टि में भारतीय संस्कृति में इसे ब्रह्मांड कहा गया है, और जीवों के अंदर ब्रह्म की कल्पना सनातन परंपरा में है। इसलिए इस ब्रह्मांड को समझना, अपने अंदर के ब्रह्म को समझना, यह हमारे लिए मायने हो जाता है। अब हम ब्रह्म हैं और इस ब्रह्मांड को सुरक्षित रखना है। अब उसको सुरक्षित रखने के लिए क्या है, तो हमारे आजू बाजू में कुछ पर्यावरण के दृश्य दिखाई देते हैं जिसके बिना जीवन की कल्पना शून्य है, संभावना नहीं है। और उसमें छोटी सी बात आती है, हवा, जो दिखती नहीं है, ये वास्तव में अंतर मन से महसूस की जाती है। एहसास होता है कि हवा सर्द है, हवा गर्म है, हवा धीमी है, हवा तेज है। कुछ चीजें हमारी स्पंदनों की होती है, हमारी संवेदनाओं की होती हैं। संवेदनाओं के संप्रेषण से हमारे रिश्ते स्थापित होते हैं। तब कई बार हम कहते हैं, अरे मैं तो तुम्हें फोन लगाने वाला ही था, तुम्हारा फोन आ गया। संवेदनाओं का संप्रेषण एक दूसरे को अटैच करता है, रिश्ते वही बनते हैं। इतने सारे लोग हो, आपस में आप सब एक दूसरे के मित्र नहीं हो, परिचित हो सकते हो, दोस्त हो सकते हो, जानकार हो सकते हो, लेकिन मित्र कुछ ही होंगे, क्योंकि हमारी संवेदनाएं जब उसकी संवेदनाओं से अटैच होती है, यानी संप्रेषित होती है, उससे संबंधित होती है, तो मित्रता स्थापित होती है। ऐसा ही इस ब्रह्मांड में भी पर्यावरण से लेकर 2-3 बातें स्थापित है। प्रकृति मानते हैं हम। भारतीय दर्शन में प्रकृति को हमने मां कहकर संबोधित किया है। भारतीय दर्शन में प्रकृति जो है वो हमें जीवन देती है, समूल। इसमें 3 बातें पर्यावरण के लिए खास हो गई हैं इस समय। एक हमारा पेड़, एक हमारा पानी, एक हमारा ये पॉली बैग, सिंगल यूज पॉलीथीन। ये 3 चीजें समस्याग्रस्त है। एक तो बहुत पहले से है, जो पेड़ जिसकी हम पूजा करते हैं, हमारे पूर्वज अघाए नहीं, जिसकी पूजा करते करते पूर्वज आज भी अगली पीढ़ी में यह परंपरा डाले हैं कि शाम के वक्त पेड़ों को छेड़ा नहीं जाता, क्योंकि पेड़ सुप्त अवस्था में रहते हैं, पेड़ शयन करते हैं, पेड़ सोते हैं। और जगदीश चंद्र बसु ने इसको दुनिया के अंदर स्थापित किया। इसका प्रमाण हमारे साहित्य में स्थापित है। उन्होंने कहा कि जैसा प्राणी है वैसा ही इन वृक्षों में प्राण तत्व है, और वो प्राण तत्व प्राप्त आपसे करता है, और वो जो हमको देता है वो मेरा प्राण तत्व है। ये दोनों बातें हैं। उसे हमने पेड़ कहा है। हो सकता है हमारी संवेदनाएं मूक रही हो, हमारी संवेदनाएं गूंगी हो वृक्षों को लेकर, लेकिन संवाद तो करिए। एक वृक्ष आपसे क्या चाहता है और आप क्या दे सकते हो जिसको प्रकृति ही दे रही है। प्रकृति की देन, 1 मिनट आउट ऑफ सिलेबस मैं बता दूं आपको, प्रकृति की देन इतनी है कि इस धरती पर 84 लाख योनियों का कल्पना की गई है, जिसमें 4 लाख योनि मनुष्य की है। 80 लाख योनियों के लिए कोई विश्वविद्यालय है क्या? जलीय जंतुओं के लिए कोई अस्पताल है क्या? कोई शिक्षालय है क्या? कोई आवास है क्या? कोई देवालय है क्या? नहीं। उनकी सुरक्षा की जिम्मेदारी किसकी है? प्रकृति की। इस पृथ्वी चर पे मनुष्य को छोड़ दीजिए, बाकी प्राणियों के लिए गाय है, बैल है, भैंस है, बकरी है, ऐसे जानवरों का जिसमें रस्सी बांधकर आप अपनी मर्जी से उस पे अपना आयात करते हो, उसके लिए कौन है? उसकी भूख, उसकी प्यास, ये संवाद की चीजें हैं। ये 4 लाख जो मनुष्य की श्रेणी है ना, इन्होंने पर्यावरण यानी प्रकृति के साथ अपनी निजी स्वार्थों के लिए, निजी सुख के लिए छेड़छाड़ किया है, और उसका परिणाम हमारे सामने है। आप तो ग्वालियर में हो साहब, ग्वालियर का तापमान आप सबको पता होगा, पिछले वर्ष का, इस वर्ष का तापमान मालूम होगा आपको। ये सारी चीजें जो परिवर्तित हो रही हैं, उसका आखिरी दोष किसके पास है? हम एक घर में 3 हैं, हमारे पास 6 वाहन हैं, सबकी कार अलग है, सबकी 2 पहिया वाहन अलग है। कितनी आवश्यकता है। इससे उत्सर्जित होने वाली अनावश्यक ऊर्जा आखिर किसके जीवन को क्षैत कर रही है, किसका क्षरण कर रही है। ये थोड़ा सा पढ़े लिखे होने का, देखिए बुद्धि और विवेक दो बातें हैं। मनुष्य और प्राणी सब में बुद्धि समानुकूल है। आप बकरी को बुलाइए, अपने कुत्ता को बुलाइए, अपने जानवर को बुलाइए, आपकी भाषा समझता है, भगाइए बुलाइए समझता है, बुद्धि यहां तक समान है। लेकिन हमारे पास विवेक है, हम विवेकी लोग हैं। हम अपनी सुविधा के लिए कार बनाना जानते हैं, हम अपने पानी को फिल्टर करके आरओ में पीना जानते हैं, हम अपनी आवश्यकताओं के लिए वृक्षों पे कुल्हाड़ी चलाना भी जानते हैं। उस समय हमारी संवेदनाएं शून्य हो जाती हैं। ये सारी चीजें हम अपने स्वार्थ के लिए करते हैं। लेकिन इससे पैदा होने वाली जो नकारात्मक चीजें हैं, जो धुआं है जो उससे निकलता है, 6-6 गाड़ी, एक घर, आदमी 3-3, कल्पना करिए कहां ले जाना चाहते हैं। हम तो विवेकी लोग हैं ना, हमारे पास तो विवेक है, विचार है, ये हमारे अलावा किसी के पास नहीं है। अब विवेक का अर्थ क्या है ये भी समझ लीजिए। विवेक यानी जिसका उपयोग हम अपने लिए श्रेष्ठ कर सकें। जैसे मैं और मेरे बाजू में मेरी गाय खड़ी है, गाय के सामने भी भूसा रखा गया, मेरे सामने रखा गया, गाय खाएगी। गेहूं का पौधा रखा गया गाय के सामने, मेरे सामने, गाय खाएगी। गेहूं का आटा रखा गया, गाय खाएगी। गेहूं रखा गया, गाय खाएगी। रोटी रखा गया, रोटी मैं भी खाऊंगा, गाय भी खाएगी। क्योंकि गेहूं से रोटी तक पहुंचने का सफर जो है वो मनुष्य ने अपने विवेक के आधार पर तैयार किया। यह विवेक का अंतर है। बुद्धि सबके अंदर समान है। इसलिए वृक्षों के प्रति हमारा भाव कैसा, हमारा स्वभाव कैसा, हम अपने सनातन प्रक्रिया में, परंपरा में मरने के बाद भी वृक्षों की लकड़ियों की आवश्यकता हमारे लिए पड़ती है। इस सोच से ये भारत की भावी पीढ़ी में जो मेरे सामने प्रस्तुत है, कम से कम इस विचार से अपने जीवन को लक्षित करते हुए, वृक्षों के प्रति अपनी संवेदनाओं को संवाहित करते हुए, संचरित करते हुए, वृक्षों के संरक्षण और संवर्धन के लिए क्या कर सकते हैं आप विचार करिए। आप स्वायत्त हो, कुछ तो भी बोलने के लिए जेएनयू के विद्यार्थियों की तरह आप स्वतंत्र नहीं हो। कुछ तो भी अच्छा अपने जीवन और भारत की भावी पीढ़ी को करने के लिए आप स्वतंत्र हो। स्वतंत्रता भी कैसी, पॉजिटिव या निगेटिव, सकारात्मक या नकारात्मक। इसलिए वृक्षों के बारे में हमारा सोचना भावी भविष्य के लिए कितना सकारात्मक हो सकता है, आपने विचार करना चाहिए। आपसे कल का भारत का निर्माण होने वाला है, ये राष्ट्र आपसे जाना जाएगा, पहचाना जाएगा। इसलिए ये पर्यावरण का विषय है। तो हमने 3 समस्याएं मानी जिसमें एक वृक्ष है। तो इस वृक्षों के बारे में आप सोचिए, विचार करिए। आपके घरों में छोटे छोटे बढ़िया बढ़िया पौधे लगे होंगे गमलों में, उनसे संवाद करिए। कभी बैठिए अकेले, कभी पूछिए उनसे कि तुम क्या चाहते हो मुझसे। कभी अपने से विचार करिए कि मैंने क्या किया इनके लिए। ये संवाद है, संवादहीनता नहीं, संवाद चाहिए। ये प्रकृति की चीज है, और प्रकृति के साथ ही संवाद होना वास्तव में श्रेष्ठ मानव जीवन की अंतिम समीक्षा है। इसी प्रकार से थोड़ी पानी की बात आती है, जल के बारे में। जल भी एक समस्या है, सबको मालूम है। बड़े बड़े सागर हैं, 7-7 महाद्वीप है इस धरती पर, लेकिन उसका सदुपयोग किसने कितना किया। तो समुद्र के पानी का वास्तविक संरक्षण और संवर्धन करके मानव जीवन के लिए उपलब्ध किसी ने कराया तो एकमात्र देश इजराइल। 90 लाख 98 लाख की जनसंख्या है, उनके पास करने की क्षमता है। हमेशा आप सब विद्यार्थी हैं, इस देश के बारे में विचार करते समय 140 करोड़ ये सामने रखना। ये मनुष्य के उंगलियों पे नहीं गिना जा सकता। इसको किसी ने अपने दृष्टिपात करके, दृष्टिगोचर करके आंख से नहीं देखा होगा। 140 की कल्पना किसी मानव मस्तिष्क में बन जाना संभव नहीं है। इसलिए जो भी आप निर्णय करना, जो भी आप विचार करना, 140 करोड़ कितना होता है इसको सामने रखकर करना। 140 करोड़ लोगों का यह बोझ है, यह भार है, यह वजन है इस भारत भूमि पर। इसलिए जब भी विचार करना, इजराइल की तरह विचार संभव नहीं है। 140 करोड़ को दृष्टिगोचर करते हुए विचार करना। 2% पानी हमारे जीवन के लिए उपलब्ध है, चाहे उसमें आप खेती कर लो, चाहे उसमें आप अपना निजी दिनचर्या का उपयोग कर लो, हमारे पास इतना ही उपलब्ध पानी है। आप सबको भी कुछ विगत वर्षों की खबरें होंगी कि तमिलनाडु में एक गांव जल से निस्तारित हो गया, जल सूख गया, गांव से लोग पलायन कर गए। देखिए, ये ईश्वर के कर्तृत्व, हमारे कर्तृत्व का ईश्वर का ये दिया हुआ प्रतिफल है। अभी उन्होंने कहा कि एक गांव में ये स्थिति है, हम जहां रहते हैं वहां के बारे में सोचिए। जल के बारे में हमारे पूर्वज जो शास्त्र में लिखे, जल ही जीवन है, हर धार्मिक शास्त्रों में होगा, उन्होंने जीवन के रूप में जल को स्वीकार किया। और जल वो कहां रखते थे? तो जल रखते थे धरती के नीचे। 2.5 लाख, 3 लाख, 2 लाख लीटर पानी वो एकत्रित करके रखते थे। आप कब शब्दों में उसे कुआं बावड़ी बोलते हैं। उनकी परिस्थिति चाहे जैसी हो, आप जैसे वो बहुत अच्छी अच्छी किताबें नहीं पढ़े होंगे, आप जैसे उनके परिधान नहीं रहे होंगे, आप जैसे वो साफ सुथरे और स्वस्थ भी नहीं रहे होंगे, लेकिन जल के प्रति उनकी संवेदना कितनी मार्मिक थी, कितनी भावुक थी कि वो जल को कहां रखते थे? तो धरती के नीचे। कितनी उनकी क्वांटिटी होती थी? तो 2.5 लाख लीटर, 3 लाख लीटर, 2 लाख लीटर। कैसे हमारे पूर्वज थे, कितना जल के प्रति वो संवेदनशील थे, जल को लेकर कितने जागरूक थे। उनको मालूम था कि जल ही जीवन है, जल के पास मैं रहूंगा तो जीवन रहेगा, और जीवन के पास जल रहेगा तो जीवन रहेगा। जीवन को उन्होंने इस प्रकार से समझा था। वर्तमान परिप्रेक्ष्य में क्या है? आप में से बहुत सारे लोगों के सर के ऊपर 3000 लीटर की टंकी होगी, 5000 लीटर की टंकी होगी। आप पढ़े लिखे लोग हैं, वर्तमान परिप्रेक्ष्य में है, हमने अपने विकास का मार्ग तय किया है, एक क्रम तय किया है। लेकिन ये 2 पीढ़ी पहले जाइए, ऐसे 50 साल पहले हमारे पूर्वज पानी के प्रति कैसे थे, हम पानी के प्रति कैसे हैं। जल का मायने उनकी दृष्टि में कैसा था, हमारी दृष्टि में कैसा है। इस सच को आप अस्वीकार नहीं कर सकते। और इस जल के लिए आप आश्रित किस पे हो? आपकी निर्भरता कहां है? तो शासकीय योजनाओं पे, सरकार पर हम आश्रित हैं कि सरकार हमको जल देगी। जल तो हमारी व्यक्तिगत आवश्यकता है ना, हमारे जीवन की आवश्यकता है। इसलिए जल के बारे में भी थोड़ा सा अपने लोगों के प्रति सोच कैसी होनी चाहिए। तो आजकल 2-3 उदाहरण मैं देता हूं, आप लोग भी अपने व्यक्तिगत जीवन में उपयोग करना। एक हम लोग शब्द बोलते हैं कटिंग वाटर, कटिंग। आपके यहाँ 4 मित्र मेरे जैसे आए, आप 4 गिलास एक जग रख दीजिए, गिलास भरकर मत दीजिए, क्योंकि मैं 2 घूंट पीऊंगा और 2 घूंट के बाद बाकी पानी फेंक दिया जाता है सिंक में। इसलिए खाली गिलास दीजिए। आपके घर में, आप अपने से परिवार में, मित्रता में, रिश्तेदार में किसी से भी बात हो तो आप कहिए कि देखिए पानी फेंकिए मत, आपको 2 घूंट पीना 2 घूंट लीजिए। गंगा सबके लिए है, केवल मेरे लिए नहीं है। सबका अधिकार है जल पर, केवल मेरा अधिकार नहीं है। इसलिए हमको विचार करना चाहिए। हमारे घर में आरओ लगा है, आरओ का पानी का वेस्ट कहां जाता है? 2/3 पानी उसका खराब होता है, एक हिस्सा पानी हम अपने दैनिक उपयोग में लाते हैं, बाकी पानी कहां जाता है साहब? या तो हमारी सिंक में नली डली है, या तो वो पाइप वेस्ट जा रहा है, या तो उस पानी का कोई घर में संरक्षण नहीं है। हम एक बकेट रख सकते हैं क्या? हम अपने व्यक्तिगत जीवन में उस दिन भर के आरओ से निकले हुए पानी को इकट्ठा करके दैनिक जीवन के उपयोग में ला सकते हैं क्या? हम पी नहीं सकते, हम नहा नहीं सकते, लेकिन बाकी काम में तो पानी आ सकता है। जल तो सबका विषय है, सबके लिए है, इसलिए उसके प्रति भी अपनी जागरूकता होनी चाहिए। चाहे वो पीने का जल हो, चाहे बागवानी का जल हो, जल किसी भी प्रकार का हो, हमारे जीवन का जल है। तीसरी बात हम सबके सामने समस्याग्रस्त है, छोटी सी बात है, 40-45 वर्ष पहले यह हमारे देश में आ गई और उसे आपने कैरी बैग के रूप में स्वीकार कर लिया। देखिए, ये अंग्रेजी के शब्द इतने आकर्षित है कि मायने बदल देते हैं। ये हमारे भांजे को भी नेफ्यू कहते हैं, मेरे बड़े भाई के बच्चे को भी नेफ्यू बोल देते हैं। इनको भतीजे और भांजे में कोई अंतर नहीं है। इसलिए ये कैरी बैग के रूप में जो पॉलीथीन आई ना, ये हमको दिशा भ्रमित कर गई, दिशाहीन कर गई, ये सदिश रहने ही नहीं दी, अदिश कर गई ये पॉलीथीन। ये वास्तव में राक्षसी प्रवृत्ति का एक उत्पादक व्यवस्था है। इसकी उत्पादकता ठीक है, उसमें लेबर लगी है, उसमें मजदूर काम कर रहे हैं, उससे कंपनियां चल रही हैं, कारखाने चल रहे हैं, फायदे हो रहे हैं, आय व्यय का क्रम एक सुचारू रूप से चल रहा है। लेकिन हम सभी लोग उसका नुकसान तो जानते हैं, उसका फायदा तो जानते हैं, उसका वजन भी जानते होंगे, इसलिए उसका नुकसान कितना है। तो नया नया जब डिस्पोजल आया तो हमारे घरों में शुभ कार्यक्रम होते थे, मांगलिक कार्यक्रम होते थे, शादी विवाह, दस्तोन जैसे कार्यक्रम होते थे, उसमें हम ऐसी चीज लेकर आते थे जो नाशवान नहीं है, जो प्रकृति संबद्ध नहीं है, जो व्यवहार संबद्ध नहीं है, उसको हम अपने घर में लेकर आए और उसका नाम दिया डिस्पोजल। डिस्पोजल के गिलास में पानी पीना बचपने में बहुत अच्छा लगता होगा, किसी आप कार्यक्रम में जाते होंगे तो बार बार पीते होंगे, दो दो घूंट करके पीते होंगे, वो गिलास में पीना अच्छा लगता था, डिस्पोजल की कटोरी में, डिस्पोजल की प्लेट में। और वो डिस्पोजल सड़कों पे उड़ता था, वो डिस्पोजल जब सड़क के किनारे नाली चौक करता था, हमारे सीवेज डैमेज कंट्रोल नहीं हो पाते थे। तो इन सारी व्यवस्थाओं में ये हमारे द्वारा फैलाया हुआ प्रदूषण मानवीय जीवन को ही संकटग्रस्त कर गया। और ये मानना चाहिए कि आज समुद्र के अंदर जितने भी जलीय जंतु हैं, मैंने पहले ही कहा कि कोई चिकित्सालय नहीं है, और आपके ग्वालियर में एक गौशाला चलती है, जिस गौशाला के अंदर मैं पिछली बार के प्रवास पे गया था घूमने, तो उस भ्रमण में उन्होंने एक कांच के बॉक्स में इतनी पॉलीथीनें निकाल कर रखी हैं, उनसे पूछने पे बताते हैं कि ये गाय के पेट का ऑपरेशन है, उसमें से पॉलीथीन निकली है। ये जानते हुए भी गाय की पूजा अभी गोपाष्टमी में हम सबके घर के लोगों ने की होगी। गाय हमारे लिए मातृशक्ति है, ऐसा भी हम मानते हैं। गाय हमारे लिए धार्मिक आध्यात्मिक ऊर्जा है, ये भी हम मानते हैं। लेकिन हमारे ही घर की चीजें जो खाद्य सामग्री शेष हो जाती है, हम में से ही बहुत सारे लोग उसको उसी में डालकर बांधकर और सड़क पर फेंक देते हैं। ठीक है, आप नहीं फेंकते, मैं मानता हूं आप निर्दोष हैं, लेकिन आप मना भी तो नहीं करते। अपराध को मूक बधिर होकर सहन करना भी अपराध की श्रेणी में है, ऐसा अपने संविधान के कानून में। अपराध को बर्दाश्त करना, हम समाज को जागरूक भी तो नहीं कर रहे हैं, हम अपने को भी जागरूक नहीं कर रहे हैं। इसलिए जो कैरी बैग जैसी व्यवस्था है, इसके निस्तारण निष्पादन के लिए हम क्या कर सकते हैं, हमारे द्वारा क्या हो सकता है। तो मेरे मित्र, मेरे स्नेही स्वजन, आपसे कुछ भी ना होना तो पहला संकल्प ये हो आपके व्यक्तिगत जीवन में कि हम किसी भी प्रकार के डिस्पोजल का, किसी भी प्रकार के ये सिंगल यूज पॉलीथीन का उपयोग नहीं करेंगे। पहली मनाही आपके जीवन की व्यक्तिगत ऐसी हो। दूसरी, अगर वो आ भी जाती है हमारे घर में, तो उसके लिए हम क्या कर सकते हैं, तो उसको हम कहीं इकट्ठा कर सकते हैं। खाली पानी की बोतल हो सकती है, तेल की बोतल हो सकती है, उसके अंदर हम उसको भरकर ढक्कन लगा के रख सकते हैं। उसको जमीन पर ना आने दें, उसको इस एटमॉस्फेयर में ना आने दें। ये पेड़, पानी और पॉलीथीन को लेकर थोड़ी सी हमारी सतर्कता, थोड़ा सा समाज का लाभ और थोड़े से अपने पर स्वार्थ की बात, ये तीनों चारों चीजों का समन्वय अच्छा हो जाए, इनका युग्म अच्छा बन जाए, तो शायद हम बिन कहे, बिन बताए, बिना किसी को रोको टोके, ये इतने लोग बैठे हैं। एक बार एक विदेशी पर्यटक कलकत्ता के अंदर आया। कलकत्ता अपने देश का बहुत ही पहले के कालखंड में यानी थोड़ा सा अव्यवस्थित शहर माना जाता था। जिस घर में वो विदेशी अतिथि रुकी थी, उन्होंने कहा कि कलकत्ता बहुत ही यानी गंदा शहर है। तो उस घर के मालकिन ने कहा कि क्या कहें, कलकत्ता में 1 करोड़ की आबादी रहती है। तो उस अतिथि ने जवाब दिया कि क्या कलकत्ता के सफाई के लिए 1 करोड़ लोग कम है क्या? इस ग्वालियर में परिवर्तन के लिए बैठे हुए इतने सारे विद्यार्थी जो कल के भारत को अपने मुट्ठियों में बंद करके जिंदा हैं और जीवित रहते हैं, उनके लिए ये ग्वालियर में पेड़, पानी, पॉलीथीन के पराक्रम को लेकर बातों को लेकर किसी प्रकार का संशय है क्या, संदेह है क्या? हम अपने जीवन में व्यक्तिगत रूप से क्या कर सकते हैं, हम अपने परिवार में क्या कर सकते हैं, हम अपने प्रोफेशन जिस ऑफिस में जाते हैं, जैसे इस परिसर में आते हैं, आप सभी लोग इतना ही संकल्प लो ना कि हमारा विश्वविद्यालय का जो परिसर है ये पॉली बैग मुक्त होगा। इतना ही लो। हो सकता है हमारे विद्यालय में कोई टोटी टूप टूप करके छूती हो, 24 घंटे में 11 लीटर पानी गिर जाता है। हमारे घर में ऐसी व्यवस्था तो नहीं है कि हमारे घर की टोटी बूंद बूंद पानी टपकाती हो, हमारी सिंक काली पड़ गई हो। हम ये छोटी बात ही अपने व्यवहार में ले आए। जीने के लिए सीखना और सीख कर जी लेना ये कोई असंभव सी बात नहीं है, लेकिन होता तब है जब हम करते हैं। तो पेड़ बचाए लगाइए, पानी बचाइए, पॉलीथीन हटाइए। ये पर्यावरण से युक्त 3 विषयों पे मैं काम करता हूं। उसी काम के बारे में आपको आंशिक संदेश दिया। आपसे व्यक्तिगत व्यवहार में हो सके तो, आपसे पारिवारिक जीवन में हो सके तो इसके पक्ष में सकारात्मक कर्तृत्व के साथ काम करें तो शायद हम पर्यावरण में सहभागी भी होंगे, सहयोगी भी होंगे। आपने धैर्य के साथ सुना। आप सभी विद्यार्थियों को आनंद, बहुत बहुत साधुवाद। और ये एमआईटी विश्वविद्यालय के आयोजनकर्ताओं ने यहाँ पे मुझे विषय रखने के लिए प्रस्तुत किया, इसलिए इस विश्वविद्यालय को, अपने वीसी साहब को, अन्य स्नेही मित्रों को भी मैं बहुत बहुत साधुवाद देता हूं, आभार भी अभिव्यक्त करता हूं कि आपने इस मंच पर मुझे बुलाया जिसमें मैं उपस्थित होकर अपने अंतर्मन के भावों को आप सबके सामने प्रस्तुत किया। इसलिए आप सभी को फिर से करबद्ध प्रणाम, धन्यवाद।
Thank you, sir, for your words of wisdom. We now request Professor Dr. Kuldeep Dwivedi, convener of the conference and Deputy Dean Academics, Amity University, Madhya Pradesh, to kindly present a token of gratitude to our honored guest, Sri Shiv Shankarji. Thank you, sir, for your valuable presence. Before that, yes, ma'am. It is a matter of immense pleasure to announce that following the enthusiastic response to the conference, the received abstracts have been compiled into a book of abstracts cum souvenir. We kindly request the dignitaries to step forward for the release of the book of abstracts cum souvenir. Sir, please. All the faculty members of environmental sciences are requested to join the dignitaries on the dais. May we request all the dignitaries to kindly release the book of abstracts cum souvenir of the Second National Conference on Technological Innovations and Environmental Sustainability 2024. Following this, I request the dignitaries and the faculty members to kindly release the books published by them in the year 2024. These books have been published by renowned and reputed publishers. The glimpses of the books are presented to you on the screen. Thank you, dignitaries and faculty members. Proceeding further, we now request Professor Dr. R.S. Somar, Officiating Vice Chancellor, Amit University, Madhya Pradesh, to kindly present the token of gratitude to our Honorable Chief Guest, Dr. Anadar Arunachalam, Director, ICAR, Central Agroforestry Research Institute, Jhansi, Uttar Pradesh. Sir, please. Thank you, sir, for your valuable presence. We now request Professor Dr. Kuldeep Dwivedi, convener of the conference, to kindly present the token of gratitude to our honored guest, Shri Shiv Shankarji. Thank you, sir, for your valuable presence. Thank you, everyone, for joining us today. We'll now proceed towards the technical sessions. Thank you once again to all our guests and participants for joining us. Let's embark on this journey towards a sustainable future. We'll now proceed towards the technical sessions online.
You should have come this side. Sir, मैं यहाँ पे scroll करने आई। उनको आना चाहिए था,
হ্যাঁ আচ্ছা আচ্ছা আমি আমি বলছি দেখছি হ্যাঁ আমি তো আপলোড করছি হ্যাঁ ওকে Am I audible to all? Hello?
Yes, sir, you are audible.
Okay. And can you please tell me whether these are scrolled down properly?
No, sir,
Is it scrolling down?
your screen is not visible.
Thank you. Thank you so much.
It's not visible, sir.
Great. Thank you. So shall I start now?
Sir, you have shared something or?
Sir, give me 2 minutes. I'm just going to start. I'm Dr. Swapnil Live from MIT. Give me 2 minutes, sir.
Okay. Thank you.
Sir, good afternoon. This is Dr. Swapnil Live from MIT University.
Good afternoon, sir. Good
Welcome,
afternoon.
sir. Sir,
Can you
sorry,
hear me, sir, properly?
sorry for late. Actually, the
No
program
issue,
was
no issue.
late. So
It's
just
okay.
I'm going to just brief the things and then we'll start with the things.
Okay. No issue.
Dear participants, please confirm me that you have joined the Abdul Mutlib, Abdul, Abhishek Singhal, Alok Jain, Anamika. उसको कनेक्ट कीजिए, उसको तो आप डिस्कनेक्ट कर दिए।
वहाँ जाके कौन सी खुलने वाला
Mr. Manish, I request you please unshare yourself. You have shared yourself. Mr. Manish Kumar Yadav.
कान को सेट कर लिया
Sir, shall we start? Mukhopadhyay sir, shall we start?
Yeah, we can.
Okay. So, dear participants, now we are going to start the technical session 1, for which we are having Professor Dr. Krishnendu Mukhopadhyay as the chairman of the session. Professor Krishnendu Mukhopadhyay, he is a MSc and PhD in the nuclear and analytical chemistry and BA and BEd, sir. Then he is a professor and academic coordinator of Department of Environmental Health Engineering at Sri Ramchandra and Faculty of Public Health, SRI HER, University Porur, Chennai. So first we will start with the Krishnendu sir, the invited talk with the Krishnendu sir, and then after we will have the plenary lecture of Dr. Neelam Pathak. So sir, I request you to start your presentations.
Thank you, sir. Good morning, one and all. It's my privilege to be here among all of you, and special thanks to my co-chair, Dr. Sapnil Rai. Thanks to the organizers for giving me this opportunity to be among you, to share something, whatever I have done, what I know, and what we can do together. So the topic is given here as environmental health risk assessment in sustainable development goals. As you all know, that we are almost we have crossed 60% path of the given length of 2015 to 2030 in terms of the SDG, and we will see that the next generation or the present generation, a lot of works are there to do. And for that, some sorts of overview I have taken over here. I have divided my talk 50% for certain fundamentals, some definitions, some concept, which are very much important to calculate the environmental health risk assessment, as well as I have just tried to find out what specific SDGs are there. Particularly, I have taken 7 out of 17, which are very much important to go forward in terms of environmental health risk assessment. So let's go one by one. These are the contents where the concept on health risk assessment I have taken, common environmental health risk domains, a glimpse
Sir,
of
please share your
sustainable.
PPT. Sorry, sir. Please.
Is it?
You know, is it not shared, sir? It is not shared.
It is not?
No, sir.
That I told earlier also that please check whether it is sharing. They said yes, it is. Okay. Just 1 minute. Then again, I'm closing and starting.
Yes, sir.
They said yes, it is.
No, but right now it is not visible. You are
Okay.
visible, sir.
Okay. I'm sharing again, no issue. Just a minute, sir.
No issues.
It is still not showing that. Whether it's disconnected from there.
Actually, sir, someone in between shared the slide. That's why your slide has been switched off.
Oh,
You
okay.
have to again share the slide, sir.
Okay. So, but it is actually they're asking me to leave the meeting. That's the problem. It is not, you can see my screen also from there. Because that particular screen is not at all visible. Your screen is not visible here. Zoom screen. This. Well,
Sir, on the downside, you will get the share button.
but share button, it will be open when your screen will be visible over here, sir. That is,
My screen?
yeah, now let me check. Uh,
Yes, sir. Now it is going to be shared.
let's.
Yes, sir.
Is
It
it
is coming, sir. Now.
Yes,
not
sir.
coming?
It
But
is visible,
check
sir.
the full
It is
screen,
visible.
whether the full screen is visible or not. Please tell me.
No, not now.
This one.
Now it's a full
Yes, sir.
screen, sir. It's a visible,
Thank
sir.
you.
Done,
Thank
sir.
you. Thank you. Thank you.
Thank you.
So my flow was on how to demonstrate my lecture today in terms of the environmental health risk assessment in sustainable development goals with an overview. So these are the content. Now you can see rolling. You can see now.
Yes, sir.
Yes,
Moving,
sir.
moving.
Yes, sir.
Yes, sir.
Okay.
Moving.
Okay, fine. Then concept on environment health risk assessment, then common environmental health risks domain, then claims of some SDGs, environmental risk parameters to the relevant SDGs. What I said, just like 7, I have picked up from there, and SDGs and their indicators, target and indicators, and some policy relevance. These will be my sort of. So while knowing the exposure assessment or environmental health risk assessment, these are the part which are very much important. We have to understand the source of the contaminants and the pathway for which actually the exposure is getting here. And then the receptor, who are the population, whether we are doing some population study or as a whole the environmental health study. So in which particular domain it is in the public health, occupational health, or environmental health as a whole. So in all the cases, starting from the source to the sink, ultimately in this particular paradigm, the sink is our health. So in this case, you can see here the source coming through certain emissions or some other kind of things also. It is for the air pollution they have mentioned over here. So concentration measurement, and then you will be going for the exposure measurement, where the concentration is one of the important parameters. Then how much dose it is relevant to the individuals, and then we will estimate the health risk through the environmental pathway. So when we talk about the exposure, the path, always we are talking about these things. It is nothing but the integration of the concentration you can see and the exposure factors in terms of the time. So in this case, the two scales we generally divide to assess exposure internally or externally. So this the path is again the same what I have just reflected back. So here the source you can see from the emission through media. It may be micro environment, it may be ambient environment, then some different types of routes. Routes may be inhalation route, ingestion route, dermal route, ocular route, or injection. That is also there. Then some absorbed dose, which will be estimated from there, and then biologically effective dose, and last stage, the health. So in this case, in this paradigm, we have this kind of framework for the exposure assessment framework. What we say, it is like the identification of the receptor. That's who is actually having this kind of exposure, and whether it is selecting the contaminants, exposure point, exposure factors, and biological monitoring. Nowadays, you know that whenever the people is talking about the exposure and health effects, the extremely well proof is the biological monitoring result, because every kind of chemical is having certain fingerprint in the metabolites, like in benzene, you know that TT meconic acid is the metabolite, and through blood or urine sample, you can estimate that. So those are the specificities which are very much required for the environmental health risk assessment also. When you talk about this process of the environmental health risks, it estimates, these are the points, like the hazards estimation has to be there, physical, chemical, biological, psychosocial, all these sorts of hazards are relevant. Specific or the specified human population or ecological system. That's why I was talking about who the people are. Where is my sample size? Who are my samples? Those sorts of things. So who are my subjects? That's the bigger issue. Then a specific set of conditions and for a certain time frame, and the priority which is given for potential human health impact. In this case, the two things are a little bit of confusing to the students, particularly I have seen they are this two term, health impact assessment versus health risk assessment. So you can see that health impact assessment uses quantitative and qualitative measures or descriptions in analysis, while HRA, when you talk about the health risk assessment, modeling to quantify risk. This is very important to know the difference between these two. The other one is the second one, like that HRA would only be establishing the fact once you have the relevant data in hand. Otherwise, even if the strong evidence of the existence of a hazard is there, data is not there, but still you can write that it's a kind of HIA. HIA, that means you can say that health impact assessment is over there because the hazard load or the burden you know, but until and unless you have the quantification, you have the quantified analysis, it is not HRA. The other terms, all you know, I believe, that global burden of disease, when we are talking about that, it's a measures of YLD and YALL, where actually we have the three distinct segments. First of all, the HALIs, health adjusted life years. HALIs are actually divided into two parts: DALIs, the disability adjusted life years, and the other one is the QALY, that quality adjusted life years. So in this case, we are just taking the GBD in the global platform to understand the features and the health outcomes which are just coming through the environment. So in study is a collaboration of over 9,000 researchers from 162 countries and territories, and its data is used to help improve health system and reduce health disparities. So you can see here the 5 important components of environmental health risk assessment, where the risk identification is the first, then assessment, then dose response, then exposure, and ultimately at the end of the management side, it is risk characterization. How are you characterizing this risk individually, collectively, or specifically? So in this case, when you are talking about the common environmental health risks domain, these are the domain generally everybody knows: air quality, water quality, soil quality, noise pollution, radiation, blah, 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 so many things. Yesterday's, I just took this one from yesterday's Times of India report. Yesterday in Delhi, the PM 2.5 concentration was almost closing to the danger level, like 334 against what? In WHO says it should be within 5 microgram per cubic meter, 5. But for us, till from 2021, for the interim period, we are having 15 microgram per cubic meter, right? Against 15, 334 we have. So you can understand the fate of these sorts of pollutions. It is not only in Delhi. This is just a kind of report I have taken just to ensure that we can also get into the exposure assessment over there for the whole population. A lot of institutes are there in Delhi. Lot of NGOs are there. They are all working very nicely. A lot of reports are coming up, but still you can see it is still closing to the highest danger level or most dangerous level in terms of AQI. Other things are noise, soil, as some parameters are there, some kind of health parameters, some statistics are there, as you all know. Particularly for if you just consider two domain only, air and water. In air, 4.229 million deaths that is occurring every year only for the air pollution. This is a WHO report. And on the other hand, for the water, almost 4% of all deaths that are occurring due to water pollution. So these are the main area where our next generation people will work on. The chemical environment, yes, we are surrounded by the chemical sea. As you know that only 118 elements are there in the periodic table, but you know the millions of chemicals are there. And only 900 plus chemicals, what we know in terms of biological exposure indices, only 900 plus among millions of chemicals. That means we're still in dark. So even though we have certain work to do to understand the toxic substances, what are the pesticides which are having direct link to the fatal health effects. Then what are the heavy metals? You all know those things. Industrial chemicals, consumer products, then biological environment, infectious disease, food safety. I'm not elaborating everything because the time is very short, only 20 minutes. So I'm just giving the overview of all those sorts of things. Vector control, animal-borne diseases, microbial contaminations, then occupational environment. It is also a very important area of concern where you can understand the fate of the chemicals through the MSDS. Probably you know the term material safety data sheet, which is the Bible of the chemicals which are all being used in the industries. From there, you can understand the fate of the chemicals, how they are using it, who are the people working over there, and what would be the compliance level there. So in this case also, you can make the exposure assessment, work-related disease you can find from their office, which is the public health office, or their own occupational health office in the industry. Or industrial hygiene sector is also one of the important sectors where only 4 segments are very, very important. You all know probably that is called the AREC, AREC. AREC means anticipation, recognition, evaluation, and control. So you see that anticipation, recognition, evaluation, and control. This AREC segment is the most important segment here in the industrial hygiene part. And then we can come to the point of occupational health services, where the medical surveillance and health services to be continued over there. Now, another part which is also directly related to my topic today is the climate change. A lot of people are talking about these things. Years after years, the people are talking about the climate change. Yes, it is getting changed, but it is not only for the carbon. The matter is related to the physical state of the whole globe too. Our practice is also over there, where we can see the heat stress measurement has become the priority. The pregnant mothers, a lot of health outcomes are coming from pregnant mothers and the children, particularly for the a group of susceptible area. They are having lot of health issues related to the heat stress. Generally, we are measuring it in WBGT. Then extreme weather. Ultimately, you can see now in very few cases, we can see the drizzling of rain. Rather, it is just pouring the rain through the mug, like it is looking like that cloud burst and all other things are having there. Air quality and climate. Air quality, as just I showed you that just for an instance, the Delhi air quality, and now the winter is approaching very fast, and in that case, you will come to know the whole North India and the whole Gangetic terrain will be full of pollution. Then and the climate resilient infrastructure has to be built up, where the built environment is also having a very important role. Where the social and economic environment, in this case, very important parameter is the environmental justice, where the ethics and public law, public health law and the public health ethics are also very, very important parameters to work with, where the health equity for the people, those who are actually substandard in understanding the whole issue, they should come out through our kind of pathway, where we should insist them to come out to do something, particularly the awareness program. Just now I was listening Shankar sir's, what is the name, our Shiva Shankarji. Shiva Shankarji's speech. Yes, this kind of work is very, very important. It's a grassroots level work. It is, our work is not only in the laboratory. That's why I have not taken any of my research work here. No, it is not the intention. Intention is just to make the awareness for the next level of the people, those who will be picking up the points, picking up the parameters which are very much effective to reduce down the overall global burden of disease. That's my main thing. So here other things are waste management part, transportation, agriculture, urban planning, emergency preparedness. These are all the important domains of environmental health risks assessment. So here individually you can go for the individual contaminants from each and every side. In waste management, if you go, you can have, if you just as we are from the medical university, we are very strict in our biomedical waste management rule started in 1998. So we are following all sorts of norms. It should be, if you do these things, obviously you will be in a greener and greener environment. Transportation, agriculture, and all these things. Agriculture, particularly the pesticides, are not the issue. My first PhD candidates long back were, she worked on the the organic phosphate crystallizer probably, and the diabetes. That was the main outcomes from my research area. So organophosphate chemicals, organochlorine chemicals, or carbamate chemical, all are related to certain important diseases. Diabetes, when we are talking today's, incidentally, is the World or the Global Diabetes Day. So, and you see that these are the domain which are coming out, and this is the Children's Day also today, National Children's Day. So in this case, we have to protect our children too, because these are the sustainable group which should be protected by our generation. And through our research, we will find some scope how to make it up. So then this stepwise approach to environmental health risk assessment. This is the part, one side, it is the health assessment part, hazard assessment, where anything which can harm the people and the property is the hazard, as you all know. The other one is the health exposure assessment, where health exposure assessment, in this case, we need the time, at what time, who are the population, what are the different types of variables, all sorts of statistics will come there. And obviously, at the end, when we'll find out some result, it should be statistically validated and epidemiologically established. That should be important part. And in each and of every process, particularly when, because it's a technological advancement, all sorts of technological tools should be calibrated first. The calibration is must. The training of the individual, those who will be handling these sorts of tools, is must. And then standardized operations procedures, as well as, that is SOP, what is you can say, that standardized, like standard operating procedures, or you can have some standard questionnaire. That is also another part. When you will be talking about some public health domain, you need to have the standard questionnaire in hand, validated questionnaire. So altogether, if you just see the frame of the whole issue of public health or environmental health, the health hazard assessment, exposure assessment, risk characterization, and risk management, these are the parameters which needs to be sorted out. Then some of the areas in calculation, generally for the publications we use, I'm not explaining all these things altogether, but the frame is hazard quotient you have, HQ, hazard index you have, HI, and cancer risk, cancer and non-cancer, in both these are specifically when you will be talking about the cancer and non-cancer risk, this uncertainty and variability, these two parameters will come out. So these uncertainty and variability are must. Basically, in this case, you know that whenever you will be talking about uncertainty, your statistics is coming in front, right? And in this case, what are the variables? Based on what particular variable your concentration is getting changed over the time, that should be assessed very much. These are some of the descriptions characterizing the risk and contextual informations over there. So in this case, the cancer risk is established by multiplying the lifetime average daily dose, which can be calculated through the calculations. I have that one also. So in that individual, the CR and HQ estimates for each type of chemical contaminant that can be summed up to form cumulative CR and non-cancer hazard index respectively. This is the form in general. A lot of other domains are there when we'll be talking about the health effect. Then in this case, cancer as well as the non-cancers, these are there. Some of the things probably you will be doing these things in your regular course. All the formula are there. I know Deep is doing something on that also there. So this is very known area for you students. This is the overall kind of air pollution health risk assessment model, where the project set model, air quality modeling, concentration response function, and monetization model. These are all sorts of models are directly related to the health risk assessment area. Because I told you initially that whenever you have the quantitative data in hand, then only you can form the model. And then based on that, you can just estimate the model for the future. So in this case, these are the contexts where our census data is very important. Our air quality data is very important. Baseline incidence rate, the prevalence and incidence, both are important. Then the medical treatment, economic trend. Here, the economics and the social science, these are also doing fantastic job, which are just mingled with the exposure assessment science at today's world, where now this 50% is over, then next 50% is on the glimpse. These are all 17 parameters. You all know the SDGs. How these are summed up with these sorts of 17 parameters. Frankly speaking, all 17 parameters are associated to the environmental exposure risk assessment part. But I have just taken only 7, which are having specific target, which are having specific indicator. So in that case, only 3, like 6, like 11, 12, 13, 14, 15. These are all sorts of things like 3, 6, 11, 12, 13, 14, 15. These are the main area what you can do for exposure assessment and SDG. So when you consider SDG 3, what is it? Good health and well-being, right? Everybody wants to be well. So in this case, the target is reduce illness and death from hazardous chemicals and air, water, and soil pollution. So ultimately, you see that it's a bigger spectrum. Water Act, Soil Act, Air Act, Hazardous Act, all sorts of compliance measures are there in the paper. But we have to utilize the science, how to reduce down these things drastically. That's the thing for us. Indicators, sir, mortality rate, how can it be down in the household level or the ambient pollution level? Then mortality rate attributed to unsafe water sanitation and all was program, and mortality rate attributed to unintentional poisoning. In this case, the risks are in air, water, soil, chemical exposure, and unintentional poisoning. The unintentional poisoning is at home, where you can see the picture. This is actually signifying the risk of a child when the child is unattended. Right. So this is the conditions where we are. In fact, maybe we are not very much near to these kind of sources, but obvious impact is already there. Even some of the physical hazards, what you can't see, but it is around us, like radiation is there. 370 millirem per annually we are actually surrounded by. It should not cross 500. So like those sorts of things are always with us. 6 is the next one, SDG 6, clean water and sanitation. As I told you, the 4% of the whole morbidity and mortality, particularly mortality rate in the world, is based on this, where the who definition for the safe drinking water, always we are talking about the safe drinking water. What is it? It is nothing but it does not represent any significant risk to health over the lifetime of consumption, including different sensitivities that may occur between life stages. So how important this definition from the WHO, we have to maintain these things. If you can control these sorts of contaminants from your daily usages water, I am dead sure 50% of the risk will be there. 50% only. You can reduce down easily. So this indicator is a very important indicator where we can improve the water quality, wastewater management and all, and the proportion of wastewaters and how it is safely used. The other one is the waterborne disease. These are some of the targeted indicators, and water pollution, chemical pollutions. Then next is the SDG 11, sustainable cities and communities, where reduce the adverse per capita environmental impacts of cities. This is very much important. How much you are using per day, per capita, how much load you are just giving to your municipal workers, like 0.119 kg probably it is in India per capita. So this much amount you are just generating. So in this case, how the RRR principle, particularly the recycling part, how can it be deactivated and reactivated? So these sorts of things, the new deactivate means the older technology that should be reactivated with the newer technology, because today's our conference is on technological innovations and advancements also. So in these advancement paths should be cleared. Then what are the risks here? Urban air pollution, waste management, and chemical exposure. So these are some of these areas, cities probably in New Delhi. Very soon you will be seeing this, the picture which is in the right hand side. In the deeper winter. Actually, I worked there in Madhya Pradesh near Orcha, 2008 to 2007 to 2010 in stone crushing unit. A lot of stone crushing units are there. We used to stay there in Jhansi, and we used to go there regularly. For 3 years we did. We have seen the actual scenario of what this kind of pollution is. So the silicosis was the main target for us. And we have published some papers also on that. But the lesson for all of us is that still we are not into the domain of nuclear research for water management, for pollution management. We have a lot of syllabus, but you see the last 10 years graph where we are. If you just see the Delhi, if you see the GBD, you can understand easily the path is not much, except the child health. Child health is very good now. It is deepening in the graph, but in all other cases, it is very much fluctuating. So where the responsible consumption and production is the issue there. So in this case, we have 1.42 billion people in the country. We have lot of things to do. The target to achieve environmentally sound management system. We have done sound management system in 2014 in terms of carbon tetrachloride. And during that 2009 December, it was banned, but still people are using that. Well, we have done the Minamata Convention, particularly I was the national coordinator for WHO on that, and we have just ratified these things recently. Only after my technical lecture there in Geneva, the government actually cleared them out, and that was the success rate. That means we are doing something. So in this case, if we just you see the whole university, number of universities in the country, you people, your next generation, you will be the torchbearer of the new domain. How to take this kind of risk assessment part for making the reduction. What reduction? Pollution reduction. Just reduce it. Everything will be there. A simple measurement of ventilation. Deep was working with me in ventilation part. What we have made, one empirical formula we have formulated for the ventilation index of the household. That's the first time in the world. And we have found that, yes, we can control the household exposure only by changing the configuration of the kitchen itself. So you just make the indoor air velocity a little bit of higher than 0.5 meter per second, you'll be getting the result there. So small segments are there. It is not only the PPE, but structurally, which is already there, embedded with the built environment. And Pradhan Mantri Awas Yojana is related to, where they are giving the money to the people, 1,60,000 in the rural area and 3,20,000 in urban area. If they make this installment only after having the configuration has got changed, and I can say that people will be saved from different types of exposure. So these sorts of work are important now, and where the chemical risk, hazardous waste, pollution, all these things should be included in the syllabus from the school level. Students should understand those things, and through students, actually it will propagate. This awareness campaign will propagate. It is not the matter of some meeting and some conference, some seminar and something like that. It is needed for the higher level of the research and all other. But for the awareness, where Shiv Shankarji was talking about from his Prantiyo Sangjojak Parjavaran Gatividhi. So those things are, I still feel from our laboratory should be in the community. So we have to make these things safe, particularly in the public health. Climate action, yes, climate action is a very important part. All you know that. So we are not only talking about the heat, which is getting very high and high. It should not be more than another 2 degrees. Otherwise, we are all afraid of melting even Everest or Himalaya. So we have to be very much careful. So the substances which are actually impacting the environment, each and every member of our family, it should start from our family. So these sorts of awareness campaign that is regularly needed, and I feel these sorts of seminar or the conference what you have organized here, it's a very apt. This is very, very important. It will percolate through. Then environmental health risk, again the same thing, but based on SDG 13. So you can see some of the common target elements are there, but the pathways are different. The processes of estimating those sorts of things are a little bit different. So this is life below water. What is actually happening? We should also think the marine system, where you know that thousands, not thousands, in lakhs and lakh species are at danger, and that is also directly impacted on the environmental circulation. So when we are talking about the climate change, it's not only, as I told you, it's not only carbon or PM 2.5 or NOx, SOx, COX, etc., or VOC, PAHs, may have heavy metals, but also its own circulation path, right? Whether the El Nino and La Nina are having some certain impact on that. It is there. As you know that this year is the La Nina year, we are getting a lot of rain, but how the rain is distributed? You can see that in Sahara, in the Thar, a lot of rain nowadays, and the area where the rain is needed, it is not there. So these kind of things, unusual natural behavior, that will be stopped only after having our own intervention in the field of public health, in the field of environmental health, in the field of occupational health, through these sorts of activities where marine pollution, chemical contamination, overfishing, these are only one parameters I'm giving you. Through this, you can extend your research like anything. Then life on land, here you can see what is the status of land, the forestry. Fortunately, I heard that at least the forestry which came down up to 19%, now it has gone up more than 22%. But still 11% shortage we have. What it needs to be at least 33% for the green environment, what we say. So in this kind of green forestry is important, building environment is important, and here the land where different types of lands we have, even in India, actually the different types of scale of temperature you can see. Somewhere in Delhi, nearby Delhi, it is almost 0 to 50 degrees centigrade. But in South India, where I am here, it is 20 to 42. So segments are different, but our permissible limits are same. You might have seen that this is the area where we have to work. The permissible limit of each and every individual contaminant should be as per our susceptibility, our environment, and our environmental scenarios, or the seasonal changes. So those sorts of things are due. You can work on that. Here are some of the, again, the target area of health risk. These are some of the policy. I don't want to extend much on that because this all you know, WHO, UNEP, ILO, POPs, like POPs conferences, like DDT was one of the important area of this. Then Basel conferences of hazardous waste. These are some USA. You all know the EPA particularly, we are very much following up. Even the NIOSH, 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 then OSA, then ACGIH. All these things are very, very important to understand the overall features technically as well as textually. So in this case, here Occupational Safety and Health, OSHA, Food Quality Protection Act, National Environmental Policy Act, these are very, very important, which can reduce down the burden of diseases, what I have just told. So these are European and other countries, not much interested now to so. Here the EPA we all are talking about. Some laws are there, probably in the syllabus you have already completed all these things starting from 72. Then afterwards, we adopted Water Act 1974, then 81, 86, 90, 89, 92, like that. And different types of acts you can see, and what acts are awaited, that has to be formulated by you generation. That is my call to you. And here these are some key policy instruments where risk assessment and management, please, I think it is there in your syllabus, those who are studying environmental science, pollution prevention and control, environmental impact assessment, as what I said that there are the basic difference between impact assessment and risk assessment. Initially, I talked about public participation and consultation, education and awareness. These are some of the regulatory agency. Generally, what we are following the EPA, as again, I'm talking to you, but obviously we have to follow the Ministry of Environment, Forest and Climate Change. This, but like one thing, like for the occupational health sector, as you know, like one example for noise, it is 85 decibel, as you all know, the permissible limit. But when you are talking about the CPCB, there are 4 distinct criteria, right? Like industrial cases, 65 to 75. For commercial area, like 55 to 65. For residential area, like 45 to 55. But for sensitive zone like hospital and school, it should be below 45. So you see that these sorts of things we should know. It is for the daily estimate, as per the daily permissible limit, but that was according to TWA, time weighted average. And for the time weighted average, whenever you are putting this thing into the dose response and exposure assessment, you have to transform it into TLV, threshold limit value, which is guided by ACGIH US, what we are following. So these are some of the challenges and opportunities. Most of the things I have already highlighted. No need to repeat it because of the shortage of time. Thank you very much. Thank you very much for this opportunity.
Thank you so much, sir. This was a very informative lecture, and you have covered all the aspects of environment, health, and safety. And we are very grateful to have you in this session as a chairman, and I'm also feeling lucky to be as a co-chair with you.
Thank you very much.
So thank you so much, sir. And participants, those who joined late, I wish to again introduce you about the Professor Krishnendu Mukhopadhyay, sir, who is the chairman of the session. Dr. Mukhopadhyay obtained his PhD degree in nuclear and analytical chemistry from University of Burdwan, West Bengal. And he's serving as his academic journey over 3 decades. He is associated with WHO Collaborative Center for Training Occupational and Environment Health, ICMR Center for Air Quality, Climate and Health. His doctoral research was based on the product and separating S and P radionuclides by LLX methods and were conducted in various lab facilities in BU, SNIP, VEC, Kolkata, and BAX TIFR, Mumbai. After PhD degree, he served as a project scientist in WVPCB, IWMED, and worked on municipal solid waste in West Bengal, India. Afterward, he worked at ROSC ICMR Kolkata in 2 WHO projects on air pollution, arsenic exposure, and health from March 2002 to February 2006. Now, he has been associated to more than 14 national and international projects on environment and occupational health, where IDRC funded stone crushing units, ICMR, CAR funded TAPHE, NIH funded STAR, WHO, UNEP, HGHBM, NIH USA funded HAPIN, HAPIN, US EFI funded Obama Singh Indo-US Knowledge Initiative Program, ICMR Air Toxic Projects, etc. are a few of among them. He has more than 80 publications in journals of repute and at the level of national and international conferences. He has been associated to a WHO consultancy activity for BPH curriculum development on environment, health and climate change for Royal Institute of Health Sciences, Bhutan. He is an approved tutor of the National Examination Board of Occupational Safety and Health, NEBOSH, United Kingdom, and is an approved faculty member of British Occupational Hygiene Society course, UK. He is the academic council of Indira Gandhi National Open University, New Delhi, India, and he has been rendering his service for last 2 decades in the field of industrial hygiene and are engaged in promoting green workplace environment for a number of organized and organized industrial sector of the country. So we are fortunate enough to have the person of this stature with us as a chairman and in this conference. So now moving ahead, we are having Dr. Neelam Pathak. Ma'am, welcome to you. Ma'am have joined the lecture in between. So ma'am, welcome to you. Are you able to unmute? Yes.
Yeah, thank you.
This
Thank
is Dr. Swapnil Rai from MIT University, Gwalior, working as a professor of the Department of Environmental Science.
Thank you.
And sir, ma'am, are you there?
Yeah, I'm here.
Okay. So now next plenary lecture we are having of Dr. Neelam Pathak, ma'am. Before starting, ma'am, give me 1 minute. So we are having the Dr. Neelam Pathak. Dr. Neelam Pathak is currently working as a professor at the Department of Biochemistry at Dr. Ram Manohar Lohia Awadh University, Ayodhya. Earlier, she was working as a professor at the Department of Biosciences, Integral University, Lucknow. She has master degree in biochemistry from NDUAT, Faizabad, and PhD degree in biochemistry from the University of Lucknow. After her doctoral degree, she has worked as a research associate at Plant Gene Expression Lab, NBRI, Lucknow. Thereafter, she has also worked as faculty research associate at University of Maryland, College Park, USA. She has received several fellowships, CSIR, UGC, JRF, SRF during PhD, and CSIR RA Award and Pool Officer Fellowship at post PhD level. She has also been recipient of Young Scientist Fast Track Award from DST, Government of India. Professor Pathak has 17 years of teaching experience in various undergraduate and postgraduate life sciences courses. Moreover, she has 29 years research experience in the field of plant biochemistry and molecular biology. She is the recipient of several research schemes sponsored by various funding agencies. Her research focuses on fruit ripening, medicinal plants, plant biochemistry, and plant growth promoting microorganisms. She has supervised and co-supervised 21 PhDs and 56 MSc biochemistry biotechnology projects. She has co-authored a book on genetic engineering, which is published by Oxford University Press, one of the best seller in the life science category. She has published 95 research papers in international journal of high repute. She has also authored various book chapters. She has presented papers in various international national conferences and received several awards, eminent scientist awards. So with this word, I welcome to you, ma'am, and I request you to start your lecture.
Thank you, Dr. Swapnil.
Yes, ma'am.
Yeah. Am I audible?
Yes, you are audible, ma'am.
Okay. First of all, I would like to thank Honorable Vice Chancellor of MIT University, Professor R.S. Tomar, for providing me this wonderful opportunity to interact with you all in the second National Conference on Technological Innovation and Environmental Sustainability 2024. And I'm also thankful to Professor Kuldeep, the organizer of this conference, Professor Kuldeep Dwivedi, and Dr. Abhishek, and really I'm thankful to the chairperson of the session, Professor Mukhopadhyay, whom I was listening before that, and after his talk, I'm a person of biochemistry and the person of biotechnology. I'm directly not a person of environmental scientist, but I will discuss my view related to, you can say, I'm going to link this thing like environment with the biochemistry, how we can solve the problem of environment with biotechnology or biotechnological tool or innovations in the biotechnology. Because of that, today I selected this like this topic, healing the planet, biotechnology for environmental sustainability.
Excellent.
I'm going to justify my talk in this national conference. As you all know, biotechnology is a collection of technology that use living cells and or biological molecule to solve problems and make useful product. And that this is the one of the, you can say, integrated science which integrate like biochemistry, microbiology, genetics, food science, food technology, and and all the other branches of the engineering also, and to achieve industrial application of the capability of microorganism and cultured tissues or cultured animal tissues as well as plant tissues. In other words, we can also call biotechnology as a life technology, where we apply knowledge about living things for the practical use of the humankind. And it's at its core, this one is an interdisciplinary science, and this is an era of interdisciplinary science that merge life science with the technology, enabling humans to manipulate living organism as a living organism, and that biological system to create product that enhance the quality of life and the health of our planet. Basically, the focus is how to before that, I was listening the talk of the Professor Mukhopadhyay about the environment health risk assessment and SDGs of that. And through biotechnology, we can go green, and we can this is relevant to environmental sustainability, and biotechnology can touch various sectors, like most important the agriculture one, energy, waste management, conservation, and even the health sector also. And by leveraging the power of the biotechnology, we can develop crops that require fewer chemical inputs, a few and transgenic crops are have been developed, and we can create renewable energy from organic matter. We can also fabricate biodegradable material, and even we store degraded ecosystem. And this innovation approach not only paves the way for reducing our environment, but also offer a sustainable alternative to traditional practice. And we can link biotechnology with the environmental sustainability. Like the environment is in danger and its need of that steps must be taken to save it. The environment is changing and our future is under threat. And biotechnology can provide a bright hope, and it can provide a solution for sustainable development, to create a sustainable environment. It can replace the material and process which causes pollution with better biological and sustainable alternative. Living organisms are engineered, which can be used efficiently to recycle and reuse material, which are responsible for causing pollution. We can recycle the material, we can reuse the material, and the release of waste from industrial process can be reduced with the help of various remediation technologies. biotechnology also play a crucial role in the transformation of harmful waste product and contaminates into useful byproduct, which we can use in which has various applications. And thus biotechnology has a broad spectrum effect towards reducing the overall pollution. Okay, we can bridge biotechnology with various with environmental sustainability, and there is an intersection between the biotechnology and environmental sustainability, and future innovation lies over there. Green biotech focus on applying biotechnological technique to develop products and even processes which contributes towards the sustainable environment. Through the lens of green biotech, the natural abilities of organism can be exploited to address environment address the environmental problem. For example, GM crop with the enhanced drought resistance can lead to reduced water utilization in the agriculture. Microorganism engineered to hydrolyze the pollutant. It also promise solution for bioremediation. The promise of biotech in environmental sustainability is not just about mitigating the adverse human activity, but it also reshape our relationship with our planet and with our Mother Earth. And there are various factors in which biotechnology is contributing a lot. Like the first important thing is sustainable agriculture practices, and these are leading to more environmental friendly and efficient production method, like development of climate resilient crops, reduction in chemical use, and increased crop yield. We can just utilize genetic engineering, and or even we can also utilize in green evolution, we utilize the breeding process, and scientists, they have developed various varieties that can withstand extreme weather condition like drought, heat, and this reduces the risk of crop failure and ensures a stable food supply even the climate condition is very harsh. And this will also reduce in the chemical use, and biotechnological advancement have led to the creation of crop which are naturally resistant to pest and disease, and significantly lowering the need of pesticide and fertilizers. And this also decrease the cost for production for the farmers, and it will also lessen the soil and water pollution. And it also increased crop yield. Through genetic modification, we can just increase the crop yield, and moving further, we can also do precision agriculture, which includes sensor technology, drones and satellites, a smart irrigation system, agroecology practices, aquaponics and hydroponics, and latest one is a vertical farming. And next application or innovation of biotechnology is a bioprospecting. This is where this is also known as biodiversity prospecting. It involves a strategy for exploring novel genes, even molecules and microbes desirable for commercialization as well as development. This bioprospecting derives resources and products which can be used in agriculture, bioremediation, even in the cosmetic, and even in the health area, and for personal care. We can derive product by using bioprospecting, we can isolate some of the enzyme which can be used as a biosensor in the nanotechnology, and provide economic benefit and also promote conservation of biological activity. This bioprospecting is very, you can say, it's one of the application is in the pharmaceutical industry, and more than 1/3 of a small molecule drug are either the natural product or compound derived from natural product. Like one of the example is a metformin, the major drug used for the diabetic, and which is developed from natural product present in the Gallia officinalis. Okay, another innovation of biotechnology is a personalized medicine. we can just utilize individual genetic profile to tailor treatment and therapies, improving outcome for the patient with disease like cancer. And the cancer global personalized medicine market is expected to grow. Like it will reach values of more than 3 trillion by 2025. And this can be sustainable part of the healthcare, and we can this can have a significant environment impact, so we need to mitigate it. Like we can use renewable energy, we can reduce the use of uh, like like temperature, and we can also temperature dependent facilities, and we can develop a plan for recycling or repurposing old equipment that can uh, you can say negate the impact on the environment. Okay, like synthetic biology is again one of the important area uh, of uh, biotechnology that we can utilize organism, we can engineer organism to produce materials, medicines and chemical. And the latest one is a CRISPR technology. uh, by using CRISPR technology, we can perform the genome editing, we can create custom organism for a specific task. And this can be utilized for the production of the biofuel, for development of the bio-based material, for sustainable manufacturing, and engineered bacteria that can break down pollutant. And CRISPR-Cas is nowadays it is utilizing in agriculture field. This is a groundbreaking genetic editing technology. The innovation enhances crop resilience, enabling plant to thrive in less than ideal condition, while significantly reducing the need for the chemical pesticide. And through this, crop can resist pest, disease, and extreme weather, paving the way for sustainable farming practices that safeguard the environment and reduce pesticide resilience. We can also use synthetic biology for the environmental conservation, like using genetic engineering, we can protect endangered species and restore ecosystem. By creating synthetic organism or modifying existing one, scientists can address ecological imbalance, promote diversity, and aid in the recovery of degraded habitat. This innovative use of biotechnology not only safeguard our natural heritage, but also enhance the ecosystem. And another field of biotechnology innovation is AI and big data in biotech. AI is being used to analyze vast data sets from genetic sequencing, patient record, and drug trials, uncovering insight that could be impossible for human to find alone. And it enhances precision medicine and analyzing genetic information from 500,000 participants to understand the relationship between genetics, environment, and disease. And like we can also utilize biotechnology in environmental conservation, like challenges like cleaning up soils spills, like the superbug which was developed by the Anand Mohan Chakravarti, and that was developed by the engineered microbes, uh, and genetic engineering is also being explored or exploited as a method to protect endangered species and restore ecosystem. And we can also utilize this for carbon capture and utilization. We can exploit microorganisms for carbon capture and utilization, which represent a pivotal step towards reducing greenhouse gas emission, which is one of the important problem of nowadays. This biotechnological approach utilizes the natural ability of certain microbes to absorb and convert CO2 into useful product like biofuel and chemicals. This not only aids in combating climate change, but also contribute to a circular economy by which can boost our economy also and repurpose carbon emission. And biofuel development, the quest for renewable energy resources has led to significant advancement in biofuel development, particularly through the use of algae and other microorganisms. These biological agents possess the remarkable abilities to convert sunlight, water, and CO2 into biofuel, offering a sustainable, like an eco-friendly alternative to the fossil fuel. Algae biofuel holds a great promise for a green energy future with its high yield and minimal environmental footprint. Bioremediation is another area. This is a technique employ organism to destroy polluted environment, offering a natural solution to environmental cleanup effort through the use of especially selected or genetically modified microorganisms. Pollutant in soil, in water, and air can be hydrolyzed into less harmful substances. And this method of pollution control underscores the power of biotechnology in restoring the health of our ecosystem. Like it is used to reduce the impact of byproduct created from anthropogenic activities such as industrialization and agriculture process. And this can be also utilized in the water purification system. Biological agent is used to purify and recycle water, addressing the critical need for clean water. By exploiting the filtering and detoxifying capability of certain plants and microbes, this system can efficiently remove contaminants, making water safe for consumption and reuse. This sustainable approach to water management demonstrates the role of biotechnology in ensuring access to clean water for all. And another area is biodegradable plastic. We know like the negative effect of the plastic in our environment. Biotechnology has paved the way for biodegradable plastic derived from renewable sources. This eco-friendly alternative are reducing the burden of plastic waste on our ecosystem. As many industry worldwide are developing method to manufacture bioplastic from the waste generated from agriculture and forestry. Bioplastics can be recycled and reused. Even we can also use transgenic plant system for the generation of the bioplastic by engineering PHBA and PHBG in the plants. And this another area is biofertilizer. This is again very old area, but this area is now we can say like a need of hour. And and micro-based biofertilizer are efficient in uptake of nutrient from plant when applied to their rhizosphere region. They are one of the many hopeful way to increase the productivity of crops in an eco-friendly manner. Is a simple biofertilizer can be produced by very simple and cost-effective way. Microorganism can also be engineered, like for example, fixed nitrogen for legumes, this replacing the use of chemical fertilizer and replacing the chemical load on our Mother Earth. And another important area is biofarming. We can use genetically modified plants and animals to produce pharmaceuticals. And this is transforming the drug manufacturing. This approach not only increases production efficiency, but also reduces the environmental impact of drug synthesis. It offers a more sustainable and cost-effective method of producing life-saving medications. Even research is going on for the production of number of variable vaccine. Now you can imagine you can take a banana and you will be immune for some drug. That research are underway, but okay, the process is quite slow, and there are a number of ethical issues. Is the reason of slowing of this process. Biopesticide like biofungicide, bioinsecticide, bionematizide, bioherbicide I use, and as we all know, use of chemical or chemically derived pesticide is a harmful practice to humans as well as environment. Biopesticide are a better alternative, and it consists of microorganisms like bacteria, fungus, and that help in control of pests like certain weeds, insect. One known strain of bacteria is Bacillus thuringiensis. You all know about that, and by the application of biotechnology, the desired gene from this bacteria were transferred into the cotton plant, and thus a genetically modified pest-resistant cotton plant was developed, which is BT cotton. Even in India, we also have a BT cabbage and BT brinjal. Like by utilizing the, we can say of potential of the biotechnology, we can also produce construction material. And normally construction materials are being produced using toxic chemical, and that needs large volume of energy and water. The process involved in manufacture of construction material generate elevated volume of carbon, and thus this carbon emission causes global warming. Researchers and biotech giants across the world are looking for methods that can be used to make sustainable material and microbes that could either repair the damage or help in production of cement tiles. Now, cosmetics. These are derived from either plants or animal sources, where harmful chemicals are also known to be incorporated while making of these cosmetics. The active ingredient derived from plant, however, is small in quantity. With the advancement of biotechnology, scientists across the globe are looking forward to produce compounds that can be used in cosmetic through fermentation process. A biotech company from France has been able to produce phytine, an anti-aging compound that can be used in a skincare product. Research is also going on in this field to identify and isolate microbes that can be able to produce active ingredient used in cosmetics. And like fashion industry, fashion is changing at a greater pace, and the current trend will become obsolete in the coming days. Fast fashion imposes challenges on the environment in terms of sustainability. Then this technology can be helpful by replacing harmful textile waste and recyclable and biodegradable options. Biotechnology will help to produce fabrics and dyes used in textile using microbes. And like related to that, enzyme detergent, like chemical detergent, we all know are harmful for the environment. Enzymatic detergent are biodegradable. They consist of enzymes of microbial origin that can be used to remove difficult stains such as fat and blood. The first enzymatic detergent was made and sold by the biotech giant Novozymes, like in 60s. Like basically, they are based on the proteases and the lipases enzyme. Presently, advanced versions are available in the market. Enzymatic detergent remain effective at lower temperature, as well as thus they can be used to clean medical instrument and equipment. But now the question is how to implement this biotechnological innovation for our sustainability efforts. Integrating biotech solution into environmental sustainability project require a strategic and informed approach. Like these are the steps. First, we need to identify our sustainability goal. Then we need to perform relevant research on relevant biotech innovations. We need to perform the evaluation of the feasibility, develop an implementation plan, and finally monitoring and adjustment. By adopting biotech innovations, it offers a transformative approach to addressing environmental challenges. By following this step, cutting-edge biotechnologies can be effectively integrated into sustainability projects, paving the way for a more sustainable and eco-friendly future. Like policies are also important. We need to identify the effective policies, and those effective policies can accelerate the adoption of biotech innovations by providing the necessary regulatory framework, incentives, and funding mechanism. Like government and international bodies play a crucial role in shaping the policies that affect these research and development and implementation. By prioritizing sustainability and biotech solutions in policy agendas, leaders can ensure that these innovations have the support which is required to move from lab to the field, ultimately making a tangible impact on our environmental future. Like at the end, this is a conclusion. Like biotechnology innovation has it has environmental sustainability, and it can be utilized in various way. Like we can generate biodegradable material from the bacteria, and we can also generate biofuel, and we can also perform genetic engineering and gene editing by CRISPR-Cas for agriculture. We can perform genome editing. We can also capture carbon and utilize it by microorganism for by some microbes. We can also perform genetic engineering for ecosystem restoration, which is one of the important use of synthetic biology for the conservation. And we can detoxify water with plants and microbes that can be utilized in the water purification system. And the most important is we can hydrolyze the pollutant from air, from water, from soil by modifying microbes. And that is one of the bioremediation techniques. And with this, I'm very much thankful to giving me this opportunity, and to the organizers and to the MIT University. Thank you. Thank you all.
I'm grateful to ma'am, to you, ma'am, for sparing your valuable time and
Thank you.
giving the such insightful lecture. to the
And one
gathering.
more thing, today we are celebrating Children's Day.
Yes.
Happy Children's Day to all the participants. And we can celebrate life with the heart of a child. We should be joyful, playful, and we need to build healthy habit daily. Thank you all.
Thank you, ma'am. Thank you so much. Now we are moving to the technical session for lectures. So I request the chairman of the session to allow me to call participants for presenting papers.
Yes, sir. You can proceed, sir. Thank you.
Okay, sir. Thank you so much, sir. Participants, there is a guideline to present the paper. You will have 6 to 7 minutes to present your paper, and remaining 2 to 3 minutes will the question answer will be there. So please confine your presentation within 6 to 7 minutes. Okay. So now in this series, the first paper, CP3, code number CP3. The title is Population Dynamics of Fall Armyworm Sapotera frugipeda, J. Smith, on maize. The author is Abdul Mutlib Dunia and Ranju Kanogia. If you are there, then please you upload your presentation and then give your presentation. Present your paper. Ranju Kanogia, are you there? Ranju Kanogia, are you there? No. Okay. So that's moving ahead. The CP4 by Abhishek Singhal. The effect of green leadership on employees, green work engagement in the IT sector of India. The mediating role of green HRM. Abhishek Singhal and Kapil Sharma. Anyone of you are there? Abhishek Singhal. Dr. Abhishek Singhal, can you present? Please unmute yourself. I think your mic is not connected well. Allow the system computer audio. Dr. Abhishek Singhal. Meanwhile, I am moving to next. Alok Jain. Dr. Alok Jain. I think he is not in the team itself meeting. Yeah. Next is experimental investigation on the performance improvement of solar hybrid cooker. CP6. Anamika.
Hello, sir.
Yes, are you there? Megha.
Yes,
Megha, you are going to present?
Yes, sir.
So please upload your paper. Share your paper. Okay. So please you start from first slide and go to the PowerPoint mode. Megha, you are presenting?
Yes, sir.
Okay. So you start with the topic and you have 6 to 7 minutes. So please.
Good afternoon, everyone. Respected dignitaries and professionals present in the conference, let me introduce myself. I am Anamika Ajayan, currently presenting BTech in Mechanical Engineering from Tikkan College of Engineering. I am here before you to present a project done by me and my co-authors on the topic experimental investigation on performance improvement of solar hybrid cooker. So let me provide a brief introduction about our project work. As we all know, cooking is an essential activity necessary for uh, survival and functionality of daily life. Using renewable energy for cooking provides sustainable environment by reduction of fossil fuels and thereby reduce carbon dioxide emission. So we decided to develop a solar hybrid cooker. The motive behind us is to develop a hybrid solar cooker to overcome the limitation in efficiency of available solar cooker in the market due to dependency on sunlight and longer cooking time. We aim to develop a hybrid solar cooker that effectively uses both thermal and electrical energy for overcoming the existing limitations that help to create efficient and eco-friendly working solution with the aim of commercial availability. So this is our experimental setup. Our experimental setup consists of cooktop unit, storage tank, a pump and a control system. The storage tank used to store heat transfer fluid, and there is a heating coil used as an auxiliary energy sources. Arduino-based control system is used to switch the mode of operation based on the temperature change, and a positive displacement pump is used to maintain the flow in the system. And coming to the resultant discussions, as a part of the study, we conducted a survey on a 4-membered house to calculate the energy requirement for 1 month using LPG cylinder for cooking. And we obtained the heat required as shown. And as a part of study, we come to a topic that the incorporation of nanoparticles with the heat transfer fluid can improve the efficiency of the solar hybrid. So we decided to select a nanoparticle to incorporate with the heat transfer fluid. So we listed some of the nanoparticles and we selected one of them based on the properties such as thermal conductivity, viscosity, specific heat, temperature and force. We use multi-criteria decision making method, and these are the steps we conducted, and we obtained graphene as the most efficient nanoparticle based on the study that we conducted. And then we conducted a characteristic study of nanoparticles selected. So first of all, we prepared a nano fluid by combining the turbinol 55, that is our heat transfer fluid, with graphene, that is the most efficient nanoparticle that obtained. So we use ultrasonification homogenizer to obtain the nanofluid by mixing terminal 55 and graphene. Then we measure the thermal conductivity of the nanoparticle using KD2 Pro thermal property analyzer. We obtain the thermal conductivity of terminal 55 alone is 0.11 watt per meter Kelvin, and the thermal conductivity of the nanofluid is obtained as 0.14. We use 1% of graphene with terminal 55, and we obtain a 3% of increase in thermal conductivity. After that, we measure the viscosity. We use viscometer for this measurement. Then we obtained 79.7 centipoise for viscosity of terminal 55, and the nanofluid is obtained as 109.7. Here, here we observe there is an increase in thermal conductivity and viscosity when we use a nanoparticle with terminal 55, which can improve the efficiency of the heat transfer fluid and thereby improve the efficiency of the solar hybrid cooker. Coming to the conclusion, we decided to use nanoparticle with terminal 55 to improve the efficiency of the solar hybrid cooker. The commercializing hybrid solar cooker can reduce the energy and cost, and thereby improvement of sustainability and ensure reliable performance in diverse conditions can be obtained. So thank you. These are the references.
Very good, Anamika. I hand it over to the chairman for the further process.
Yeah, it's a good presentation. You have given the calculations, particularly that is very important, and incorporation of the nanoparticles in this is a new one. That's good. But what I was expecting, some of the pictorial representations like one you have given, no, that could have, that particular circuit could have been explained in a better way. Otherwise, it's good. It's good.
Okay, sir. Thank you.
I have one question. From where you have got this graphene and other material?
We have energy research lab in our college, so we got it from there.
Okay, because it's a costly one. So
Yes, sir.
working on this is a little bit like so.
Yes, sir.
Okay. I invite to the other members to ask questions. If anyone is having any question regarding to this presentation, you can ask. Anyone? If anybody want to ask any question? I think, sir, we should move for next.
Yeah.
So Anamika, please unshare your this PPT and
Okay, sir.
okay. So next one is Anurag, Dr. Anurag Jyoti. Are you there in the meeting? Okay. So next is Arindam Ghosh. Arindam Ghosh. Arindam Ghosh, you are going to present?
Yes.
Okay,
Yes,
you
sir.
present. You please present.
Yes.
Okay.
Sir,
It is visible.
Good day to. Okay, sir. Thank you. Good day to all of you, all the faculty members, and I'm very much thankful for giving me this opportunity. Sir, is it visible and am I
Yes,
audible?
it is visible.
Okay. So I'm here to present my the paper on assessment of trace element pollution in Indian rivers, its development of pollution index and implications for water quality management. So I'm Arindam Ghosh. I'm currently working as a PhD student in Amity University Department of Environmental Science, Gwalior. So this is a brief about the heavy metals and trace elements. You all know that the heavy metals and trace elements are those that have high atomic weights, and they are very much harmful to human health and environment. So they pose serious health risk, especially the trace elements which are found in the river water. And in turn, they affect the aquatic organisms in the ecosystem. So a high level of exposure can cause neurological disease, developmental abnormalities, organ damage, and cancer. It has been found that in the Indian rivers, the trace element contamination especially the Indian rivers face this type of trace element contamination, and this necessitates systematic evaluation, surveillance, and control measures. So it is very important to develop some pollution indices that can help to identify the pollution source, estimate ecological risk, and prioritize the resource allocation. So just a minute. So the objective of the study is to assess the harmful substance in the Indian rivers and creating a pollution index, which is crucial to mitigate the water quality risk and to develop an evidence-based sustainable water management plan. This study, the main aim was to evaluate the trace element pollution in the Indian rivers so as to create this pollution index to assess the water quality and environmental and associated health impacts so that efficient water management can be addressed. Furthermore, this study analyzed the Indian river basins in a broader scale to measure the pollution level of the trace elements. In turn, which revealed that there are varying levels of pollution in the Ganga, especially in the Ganga and its tributaries, which showed elevated levels. Okay, so this is the methodology. The data was collected basically of the trace elements from the Central Water Commission, the report published of status of trace and toxic metals, as can be seen, and the working formula for determining the trace element pollution index was, as you can see, this one. So this is the graphical summary of the workflow which was done. Like it started from the anthropogenic activities, and this is the flow. Then environmental release of trace and toxic metals, entry into the rivers, collection of storage, all the way down to assessment of pollution levels, pinpointing the regions of concern, and then suggesting the remedial measures. So coming to the results and discussion, this study, as I already mentioned, was to investigate the trace element pollution in Indian rivers, aiming to create a pollution index and assess water quality, and to highlight the impact on ecosystem and environmental, and also the health of human beings. So a brief snapshot is that the trace element pollution index was calculated on the basis of the river sites. The range was found to be 2.79 to 74.82. So we can say the range was very diverse. The pollution levels was very diverse across the Indian rivers. So especially we can see that it was seen that the river Ganga and its tributaries, they showed elevated levels of this trace element pollution, which showed significant pollution. As compared to that, the western and the northeastern rivers, they showed significantly lower TEPI values, which indicated less water pollution. Okay, so continuing with the results, the factors which contributed to pollution basically in the river basin: industrial discharge, mining activities, agricultural runoffs, urban sewage, toxic metals, inadequate solid waste disposal, and so on. So regional disparities, as I already mentioned, like in the Ganga and the tributaries, they showed high levels of pollution, and in northeastern India, and western India, the river showed less pollution load. So the study highlights India's need to efficiently manage the water quality in terms of strategy, including strict pollution control, cleaner production, sustainable agriculture, and expanded wastewater treatment facilities. So we also need policy interventions. So this study helped in addressing the trace element pollution in Indian rivers, and this is very much required because for developing a comprehensive strategy, like including legislative intervention, technological advancement, cooperation, governments, business, and so on. Importance of addressing trace element pollution. It is very important, and the need for the multifaceted intervention is also a need which was highlighted for this study. So next, it's a tabulated trace element pollution index. The observations I'm given. You can see few selected sites TEPI value. Then these are all the things. You can see the site name, the river basin, the TEPI value. So yes, these are the few things. In conclusion, coming to my conclusion, this study provided crucial data on water quality and contamination level. It identified factors contributing to the pollution. It highlighted the environmental and human impacts. It's discussed variation in pollution level across regions, and it stressed the need for aggressive action to combat trace element pollution and improve water quality management practices. So that was my conclusion, and I'm really thankful for giving me this opportunity. Thank you, sir.
So I request the chairman sir to ask questions.
Yeah, it's the presentation is good, but a little bit challenging. You have mentioned in Indian rivers. I think the
Yes, sir.
specific river names should be there. It is very, very difficult. If you are just talking about the Indian rivers, this spectrum is from Kashmir to Kanyakumari, from Gujarat to Arunachal. So ultimately, you just make one particular area, because the concern of the trace elements would be varied according to the local region, right? So this is the one of the important area. Second point is you have made the statement development of pollution index. Yes, this could be a good exercise for the PhD, no doubt on that. But in this case, for developing trace elements, you have to fix those spectrum of the trace elements which are already divided in 14 or 9 spectrum in water in general, right? From the State Pollution Control Board, they are regularly doing this. So you have two things. One, you can have the data of the local area, like if you are talking about the Ganga, from Hardwar to the South Chabis Pargana. So you have a different level of the contamination, right? So from here, if you can make that this area is having a lot of traces, so from there you connect to the source. That would be a very good public health intervention through your project. But the source specific, like in Calcutta, you are getting something which is not there in Farakka, not there in Patna. So what is actually giving these sorts of values there in terms of the trace that can be estimated? That's a good PhD topic that I'm telling you. But once you will be presenting these things, or you are presenting these things in some local forum, you just specify one single river, so that these are the abundant trace elements which are already present in literature. Your challenge is to minimize the pollution through the public health intervention. I think that would be the better approach.
Okay, sir. Thank you so much. Thank you.
So Arindam, thank you. This is not your I think the research work. You have summarized the data. It's a review type of thing. I hope so. Arindam, can you unmute? And please unmute yourself.
Sir. This is I did this as part of my project. Yeah.
As a part of project, it is a review type of
in
thing,
my
right?
masters. In my masters, yes, sir.
So they just taken the general in a like the river qualities and other things, na? Trace elements, pollution in Indian rivers. So what is the meaning of trace element?
Sir, basically it's the difference in concentration. The trace elements are those which are found in very trace amounts. Those are basically the trace elements, and
can you give the example?
I think there are many, like cadmium, zinc, and yes. some heavy metals are also there. So
Okay.
yes.
Okay. So I
So
request
this work
other.
was basically on tracing and yeah.
Okay. I request others to ask any question if they have. Ask the questions if anyone is having. Please, you can raise your hand. You can ask the question. You can unmute yourself. You can ask the question. Anyone? I think no one. Arindam. Thank you. You can like unshare your screen. And now next paper.
Thank you,
paper.
sir.
Okay. Welcome. Next paper is of Arvind Singh Jadon. Orally disintegrating films and mini tablets and innovative doses from for form for a pediatric use. Are you there, Arvind ji? Arvind Singh Jadon? CP9. Now CP10, Asha Singh. SERS nanosensors for accurate detection of environmental pollution in water system. Asha Singh, you are going to present? Are you going to present? Please unmute yourself. Next is Ashok Kumar Srivastava. I think he is not in the meeting. Next is CP12, Ashwin Sasidharan. Performance investigation of a solar hybrid portable atmospheric water generator using adsorption thermoelectric cooling system.
Yes, sir. Am I audible and visible, sir?
Ashwin, you are visible and very good, audible also. You please upload your presentation and remember that you have 7 minutes to present your topic. So more give them emphasis on methodology as well as to the outcome of your study. It's your research work or?
Sir, it's currently we are fourth year mechanical students, so this is our project work, sir.
It's a project work, na? Okay.
Yes, sir.
Very good.
So good afternoon, everyone. So here we are going to do a presentation on our work, like performance investigation of a solar hybrid portable atmospheric water generator using adsorption and thermoelectric cooling system. So the contents, these are the contents we are going to discuss today. Introduction. Water is water. Water is one of the most important thing that humans cannot be survive. Without food, we can survive up to 1 week, but without water, we can barely survive 2 or 3 days. So that's what most important to human, that is water. So according to the studies based on WHO, WWC, and UN, water quality and quantity is currently depleting. Even though 70% of our planet is covered with water, 2.5% is not available as a fresh water. So we have to address this as one of the most important problem. As the studies state that if the current trend going on, at the end of 2050, we say person have the right to have clean and fresh water will be an luxury. So we cannot let that happen. We are all engineers. We have to find a suitable solution. We have to give our people a better place. So we have to generate alternative methods. So that's our motivation of the study. So there are conventional methods like direct condensation, vapor refrigeration cycles, low humidity regions. We can do harvest the atmospheric moisture. So these are all not like commercial or not efficient. Even when we are using vapor refrigeration system, we are using refrigerant. We all know about the harmful effect that will cause to our atmosphere. So that's not also feasible. Remaining all other things that compared to the specific energy we have given and the water output we are getting is very low. So we have to generate an alternative method. That's what our system, atmospheric water generated using adsorption and thermoelectric cooling. We all know study about the adsorption. That's the surface. Surface is holding the water. So we are using certain types of adsorbents like silica gel or MOF for like natural adsorbents. So we are going to see our system, layout of our system. So this is a layout of a system. We can see several components. In a brief, we are going to explain the system to you. So we have seen the air blower. The blower split the air to adsorption chamber and the tech units. First, we have to deal with the tech units. The tech unit consists of several number of Peltier modules. We all know the principle of the Peltier module. When the electric voltage is applied, one side of the Peltier module become hot and the other side become very cold. So we have combined the Peltier module's cold side into a chamber. So when the air is passed to the cold side of the Peltier module, it will reach to a dew point and the water will become condensed and the water is collected. So remaining part of the air is going to the adsorption chamber. So when we are going to say about the adsorption chamber, it needs 2 cycles to complete one experiment. That's the adsorption cycle and a desorption cycle. When during the adsorption cycle, the air from atmosphere is pumped into the adsorption chamber, and using the water pump, a normal water is pumped to the adsorption chamber, because when the adsorbent is absorbing water, it will generate heat, and when there is no way to dissipate the heat, the system's efficiency will be very low. So we have to remove the heat from the chamber. That's why we are circulating the water. And after 12 hours, we are completed with the adsorption cycle. So the next cycle is desorption. So as a part of the desorption cycle, the air inlet will be closed and the system is vacuumed using a vacuum pump, and the hot air is pumped into our adsorption system, like the way we have pumped the cold pump. So we have to need a heating device to heat our adsorption chamber. So here we are using a water from the solar trough collector that was installed in our campus. So the water from about 90 degrees Celsius is pumped in the adsorption chamber, and the heat from the water will be helpful for the desorbing the water that is collected in our adsorbent, and the desorbed water is condensed and is collected. So this is the overview of our system. Next. And so our main objective is to optimize the our system. Like we are for the water production, there are several number of criteria that's depending on the water production. So we have done several times experiment. So we have shortlisted certain criteria that will affect the water production. So here the relative humidity and the ambient temperature is the things we have taken. This will definitely affect the rate of adsorption and how much amount of adsorbent we have to deposit in the adsorption chamber. So we have to optimize a certain value. So we have used a software named Design Expert. So when the number of factors is more than 2 or 3, we cannot use a normal methods like 2D plotting, or we cannot derive from the graph. So it will require another method like response surface methodology. So it will create a contour plot. From that, we can generate our optimized set of conditions. And these are the inputs that you have fed in your Design Expert software, and this is the desirability graph that we have obtained from the software. You can see the desirability one is on the top left of the graph. From the graph, we can interpret that when the relative humidity is approximately 70 degrees, 70%, and the ambient temperature is at approximately 20 degrees Celsius, we can get the maximum yield. So research and discussion of our work is mainly on how the conditions that we have to set in order to get a maximum water yield. So that we have got from our graph, that's relative humidity is 70% and the water is 20 degree and the ambient temperature is 20 degrees Celsius. We can get that maximum water yield. In conclusion, atmospheric water generation is far better and far more effective than the traditional water generation systems. And the factors we have shortlisted, like relative humidity and ambient temperature, by creating the same method, like using several systems, we can generate a maximum water yield. So it's a infant system. We are trying to make it a more commercializing by reducing its cost and giving maximum output. So that's all about our system. And these are the reference and the journals we have referred throughout the process. And thank you for this opportunity, and it's time to ask questions.
Okay, Aswin, sir, I request Chairman sir to ask.
Yeah, Sridharan, you are a good speaker.
Thank you,
You
sir.
have narrated well. You have made a very nice schematic, all this. But only one question, because I'm not from the core field of your study. But the question is, what is new in your study? Number one. And the second one is, how did you make the circuit? Whether you have already done these things or it is downloaded.
Sir, it's an experimental setup in our lab that we have created, and the layout is created by us on the PPT. So we have created it in a PPT in order to make it a little bit more, you know, it will be if we add a complex system diagram, it will be more difficult for the person to understand. So we have used a simple layout diagram.
Okay, okay. Another presentation.
Thank you, sir.
Thank you. Thank you. Please, others.
Okay. Thank you, Ashwin. Now next is CP13, Birinder Thakur. Birinder Thakur. Next is CP14, Vats Kumar Gaurav. Studies on incidence of insect paste of groundnut under eastern Uttar Pradesh conditions. CP14, CP15, technological innovations. No, Kshetra is not there. Now, CP17. So, sir, we have done with this because the others are not there. Only we have 3 presentations in this session.
Yeah.
And we are over with the technical session 1.
Right.
I'm grateful to you, sir. Thank you. Thank you so much.
Thank you very much. Thank you all.
See you again. My camera is not working. That's why I'm not visible.
No
problem. So thank you so much, sir.
So
okay. So technical
thank
one,
you,
sir.
sir.
Sir, you can leave. Then again you will join at that time.
At 4 o'clock or
Yes.
after 4? Is
Sir,
it okay?
Sir, Deep will call you. Deep will call. Yes.
Okay. Thank you.
Okay.
Thank you all. Namaste.
Thank you, sir. Thank you. Namaskar, sir.
Thank you, sir.
Now I handed over this session, next technical section, chaired by Dr. Nava Kumar Mandal and co-chaired by Dr. Abhishek Kumar Bhardwaj. So, Dr. Abhishek Bhardwaj, you take the charge, and please don't close the meeting after this any session. Don't close the meeting, otherwise IT person has left. He is involved in another this program. So this meeting will close off after that. So please don't close.
Hello. Okay, thank you, sir.
Okay.
Yes, sir. For handovering us. So we are going to start next session, the technical session 2. So here our chairman is Professor Dr. Nava Mandal from Environmental Chemistry Laboratory, Department of Environmental Science, the University of Bardhaman, West Bengal. And myself is co-chair here. Myself is Dr. Abhishek Bhardwaj, Department of Environmental Science, Amity University, Gwalior, Madhya Pradesh. So we are waiting to join Dr. Professor Nava Mandal, sir, and the 4th plenary lecture is the Dr. Aditya Singh. He is a Marie Curie Fellow, postdoctoral fellow at the Department of Physics and Institute of Advanced Study at the University of Warwick, UK. So we have to wait a little while to join the dignitaries. Okay, so most welcome, Professor Dr. Nava Mandal, sir. So I think you hear us.
Yeah.
Am I clear
Okay.
to all of you?
So
Hello.
Professor Dr. Nava Mandal sir is the chairman here in our in this session, technical session 2. So the Dr. Nava Mandal is currently hold a position of a professor in environmental science department, the University of Bardhaman. Professor Mandal established resourceful, high-quality environmental chemistry laboratory. He has published his research paper more than 270 in a various international and national repute journals and edited number of books. He awarded, he has various national and international award, and the PhD awarded under his supervision around 19. He is already a fellow of DS Kothari, of a one research scholar. He has different, he received different prestigious funding from the DST, UGC, West Bengal DST, ICR, ICSSR, BRNS, and many more. Professor Mandal has delivered several invited talks and keynote addresses in our national, international conferences of high repute. He had carried various international and national seminar conferences. He served as a coordinator of UGC-sponsored various refresher courses and also secretary member of WB West Bengal DST sponsored Science Congress. Professor Mandal also served editorial board member, editorial advisory committee member of various journals like Scientific Report, International Journal of Applied Nanotechnology, Archive of Environmental Science, and Environmental Toxicology. So it's over to Professor Mandal sir. So kindly give your presentation, please.
Yeah. Thank you. Thank you very much. First of all, I like to express my sincere thanks to Dr. Abhishek Bharadwaj, chairperson of this session, Honorable Vice Chancellor, Professor R.S. Tomor, and the convener of this program, Professor Kuldeep Dwivedi. And I like to express a special thanks to my scholar, Dr. Chakraborty. Dr. Deep Chakraborty is there, and other faculties. Really, it is praiseworthy that they are organizing such a wonderful, seminar. In this particular seminar, I like to share my views regarding nanoscience that actually started in the year of 2014. So it is very rudimentary stage. I just like to say something about this particular science, and I hope that you realize that particular science is a emerging field. And the nomenclature of my title is, my slide is full screen. Yeah, Professor Bharadwaj, is my slide is in full screen?
Yes, sir. Is it visible? It is visible very nicely.
Okay,
you can start, sir.
Okay.
Thank you, sir.
Thank you. Just have a look the title of my presentation. I deliberately, putting this terminology, beauty of nanoscience, a journey from metallic to non-metallic nanoparticles. All over the world, there is a, research on that particular metallic nanoparticle. Okay. But I would like to, communicate to you that what are the problem in metallic nanoparticle. And that's why I shifted to the non-metallic, nanoparticle, which is very much useful for our environment. So as it is a nanoscience, so I would like to consider a famous quote that was given by physicist Richard Feynman. He was not only the great physicist, he was a Nobel laureate. He was a good philosopher. He was a good teacher. He was a good scientist. And at the time of, just realize in 1959, at that time, there is a conference where Professor Richard Feynman, present his lecture, and the title of his lecture was, "There's Plenty of Room at the Bottom." You can't believe that at that time, there is a full of, scientists from material science, from physics background, from chemistry, biologists are gathered there, but nobody, open the mystery behind this particular, philosophical term, like there's plenty of room at the bottom. So he is the pioneer of the nanoscience research at that time. Till today, the scientists have realized that what was the thought of Richard Feynman. At that time, he realized that if he goes down to down to down, we will reach to atomic level where we have a lot of possibilities. We can do many things, many work, irrespective of subject, irrespective of areas. It may be biology, it may be physics, it may be chemistry, it may be medicine, it may be catalyst, industry, whatever it is. This particular science called nanoscience will be applicable. And that's why he has given, there is a plenty of room. At the bottom, means if we go from the bulk to a atomic level, at the bottom level, you will see a large, room where the scientists from all over world can do something for the betterment for the society. So with this, philosophical lecture delivered by Professor Richard Feynman, such a wonderful gathering, American Physical Society, that was an annual meeting in the year 1959. Although it is a, nanoscience, we are telling that we are doing something as per the Richard Feynman thought, philosophy, but we believe that our nature is the greatest nanotechnologist. Our nature is the greatest nanotechnologist. Just have a look, the first picture of my present slide. You see, this is lotus leaf. And when the water fall on the lotus leaf, you can see that the water droplet, it can wash the surface of the lotus leaf. And that is, we call a, auto clean. The concept was borrowed by different paint industry. If you go through the television, you can see that there is a lots of advertisement that the paint like Asian paint, there will be no dust deposition, dust-free paint. What is that? Auto cleaning mechanism. The idea was developed from that. I hope you all have a, has an experience, a direct experience, that what are the feelings when you touch the surface of the lotus leaf. It is just a smooth like that. But in reality, it is not like that. If you look this in a very sophisticated, in a very sophisticated microscope, electron microscope, you can see the surface of the lotus leaf is like this. There is a numerous group, and in this nano size group, it holds the water molecule, and it can break down the water molecule to make the contact angle and higher contact angle, and it can spherical in nature, and that's why it can clean the surface of the lotus leaf. I hope you have a direct experience that nowadays lotus cream is available in the market, where we like to use that cream in the night time. But whatever the idea, that all are borrowed from that mechanism. Okay, you can see in the fourth picture, there is a photograph of spider, the spider net. Until the discovery of carbon nanotube, because Buckminster fullerene chemistry, carbon compound that was discovered in the year of 1985, then in 1991. So up to 1991, that spider net was considered is the hardest material, because it is so strong. It can be compared with its hardness, its strength, as equivalent as the steel, even is greater than steel. And that's why the spider net is used. This is a nanoware that basically used in the jacket, bulletproof jacket synthesis. The scientists are using this material. This is not water soluble, and it can resistance of heat, it can resistance of wind, and that material is a nano. That means we want to present before you some of the example which is already in our nature, that is all are based on nanomaterial. You see gecko, the side of the inner side of that gecko, you can surprised to see that this gecko can roaming over the surface of the wall against the gravity. But what is the beauty behind that? That nano size groups which can hold the surface of the wall, and it can stay on the wall for a long time, and it is against the gravity. Water strider. This is my last picture in this particular slide. The water strider. When water strider running over the water, it does not wet its leg because of nano groups which is present in their leg, and it helps to run over the surface of the water without wetting. So this is also a concept of nano. So our nature is the best nanotechnologist. So very quickly, I like to say something about this history of nanotechnology. That as you see, in 1974, the term nanotechnology was used by Taniguchi. He's a Japanese scientist, uses this nanotechnology term, and subsequently you see 1991 carbon nanotube, Ijima was discovered that, and that means nanoscience gradually developed. If you compare with the size of the earth and the size of football and the size of Buckminster fullerene C60 molecule, you can see that you have an idea that actually I want to say that if you take the human hair, a single human hair diameter, how much? You see, the single human hair diameter is about 60,000 nanometer. about 60,000 nanometer, okay, then you realize that what will be the size of the nanomaterial. Nanomaterial can be synthesized in the laboratory in a very popular two methods are there. One is called top-down, when we convert that bulk material to break down to a smaller one that is in the nano range, called top-down, and bottom-up approach. That means when the particle size, when the size of the particle in a combined joined together to form a cluster, and it is about in the nano range, that is 1 to 100 nanometer in at least in one dimension, we call it is in the nano range of that. So that can be possible with a bottom-up approach also. This entirely nano material can be synthesized by physical, biological, and chemical. But as you know, the physical means there's some energy is needed. Chemical means you need some lots of chemicals which can damage our environment. So biological method is the best, and it's a greener technique and eco-friendly rather. So I like to show you, some of the biological technique. Just have a look. Those are associated with the nanoscience. They will feel some interest in this, lecture. You see, suppose you want to synthesize a silver nanomaterial. Those are, in rudimentary stage, are interested to do work. They can start with the silver nitrate. This is very easily you can synthesize, silver nanomaterial in your laboratory. No need to, hi-fi instrument first. Only spectrophotometer, only one spectrophotometer, UVB spectrophotometer is enough to identify this, but you need other analytical instrument. I'll come to that point later on. See, what you can do, you have to take a salt, soluble salt, suppose silver nitrate you have taken, okay? Then how you can convert that silver ion Ag plus to a silver nanomaterial by using some reducing agent. So if you want to a quick instant result, it will better. You can dissolve silver nitrate in a test tube. One test tube, a pinch of silver, only 1 to 2 crystal is enough to dissolve in water, in a distilled water. And another test tube you have to take, where you can take sodium borohydride. This is a reducing agent. This is available in your laboratory. So you can put 1 drop of sodium borohydride, and you can see instantly you can get the silver nanomaterial. But this is chemical method. Remember, silver is sodium borohydride is it is really corrosive. It is toxic. So not to use this particular component. Better to use some plant extract. How can you prepare plant extract? Very simple. You have to pluck leaves or grass. You can pick up grass or leaf like that, wash it into the distilled water. Then you take into a mortar pestle, just paste it to make an extract. That plant material has a lot of biomolecules. Don't know, or nobody bother first that what are the biomaterials there. First of all, you can make an extract. Then you can put that extract into the silver nitrate solution. Just room temperature, no need any temperature variation. It is in simple room temperature, you will get the silver nanomaterial. So what are the indication? The first indication is that the material will be colorless. First, silver nitrate, silver, group 1 metal, that silver will form a colorless solution. But when it transforms to a nano range, means in nanoparticle and nano form, its color will be, wine red like that. Okay. So this is the first visual color inspection you can do. And then you just go through the, UV spectrophotometer. Just have a look this analytical instrument. This particular seminar is the technological development. This technology is very important here. That after synthesis of that material, first of all, you just go through the UV spectrophotometer, and to scan your material, synthesized material, and your color will be formed like that. You can see that the 5, 7, 10, 15, this is the concentration. You can see the color of 10 and 15. That will be exactly a silver nanomaterial color. And when you scan this with the use of UV spectrophotometer, UV visible spectrophotometer, you will get that this nanomaterial. Remember, this is not a concentration, rather it is the size of the nanomaterial. This is the, suppose the 10 nanometer and 15 nanometer, what will be the color of that? And that when you changes to the 20 nanometer, the color of the nanomaterial will changes. That, remember, the size of the nanometer is very important. With the variation of the size, the color will changes. And that can be scanned with the UV spectrophotometer. Okay. Just have a look. This is, suppose a quantum nanomaterial, quantum dot is producing. Remember that quantum dot is a semiconducting material. Whenever you have take a bulk material, their valence band and conductance band of the bulk material are joined together. Suppose this is valence band and this is conductance band. So these are joined together in the metallic stage. When we have taken a bulk metal, the valence band and conductance band joined together. There, that is why in room temperature, the electron can flow. That means the metal is conducting in a room temperature. But if you convert that metal to a nanoform by some physical, biological, or chemical method, that will be converted to a nanoform, and semiconducting form means it changes its conductance and valence band. That means band gap is increasing. So in a grossly, I have to say that suppose you have a bulk material, there the energy gap, that is called band gap, valence band and conductance band very close to each other. Even most of the cases is overlapping to each other. So there is literally no difference between the valence band and conductance bands. So easily electron can go valence band to conductance band, valence band to conductance band. Okay. But when that particle is changes, that means you can change the size of the particle, say smaller to smaller to smaller. So gradually its size between the valence band and conductance band, with the size will increase. You just have a look this. You can see the size of the red color ball and the green color and blue color. That means gradually the size is decreasing, and the energy level, that means valence band and conductance band, energy level increasing. That means when we are converting the material from a bulk to a nanoform, that literally we are changing the valence band and conductance band in the level of valence band and conductance. That means the band energy is changing. Say, larger the size of the particle, smaller the band, and smaller the size means larger band. That means it is in semiconducting in nature. Okay.
Actually, sir, kindly conclude, sir.
Yeah. So basically, you can take on spectrophotometer only. That will indicate first, size of the material, and accordingly you can synthesize, different, dimensions, say 3D, 2D, 1D, 0D material by using. And it has a beautiful application. The first our research was started in 2014, where we have synthesized silver nanomaterial, and subsequently that nanomaterial was used to control the mosquito larval growth. We have to control, we have to kill the mosquito larva by that nanomaterial. So gradually we have started our work, and this is in the 2015, where we have synthesized nanomaterial by aloe vera leaf extract, because time to time we are using different plant extract, and we try to explore that nanomaterial can be synthesized. Here we have taken zinc oxide nanomaterial and titanium oxide nanomaterial. This is the synthetic nanomaterial. Okay, this is available in your laboratory, and just we are trying to applying that into the plant science, and we see that the different sizes of the zinc oxide and titanium oxide nanomaterial has tremendous effect in the plant body. Subsequently, we have applied this in the industrial field, where the industrial dye, say, paper industry, pulp industry, cotton industry, pharmaceutical industry, the dye can be removed by this nanomaterial. Okay, you can see we synthesize this nanomaterial by Azadirachta indica, that means neem leaf. So in different type, and even we are using that nanomaterial to control the mosquito and that we have done. Even you know that in temple for worship purpose we are using flower. You know that flower can be a beautiful source. That waste flower that can be a beautiful source for nanosynthesis, and that can be applied into the different field. Here we have synthesized that material. Even you can go to the cytotoxicity study of that nanomaterial. When that nanomaterial is applied to check whether any cytological changes is there, you know, there's a lots of works we have conducted in our laboratory. You know, Colocasia escalenta. It is in Bengali called kochu. Colocasia escalenta. That has a beautiful biomolecule which can be synthesized nanomaterial. We explored this material the first. Okay, we have used this material for removal of uranium from underground water. That nanomaterial can be applied in the environmental science, you know, field. That is, this is also silica nanomaterial, which can be used for the removal of the fluoride from underground water. Even in the plant science, you can extract the silica from the rice husks. This is a very simple method. We have isolate and subsequently applied this material. Here also in a plant science, this is very recent, 2023, we have developed that nanomaterial can be helpful for the easy germination of the seed. Okay, so lots of works are there. You know, this is a very interesting work. We use, you know, in chicken slaughterhouse. If you go to the chicken slaughterhouse, you can find that you may be habituated to take that the chicken only, but you may not take the bile juice. But that bile juice is a very beautiful reagent, and that very beautiful agent to synthesize the nanomaterial. We collect that bile to synthesize this nanomaterial and apply it in the field of microbiology to control the microbial growth of that. You know, this is also bile juice of that. Fish bile, you know, we are taking fish, but we are not taking interested to the bile of that, but we isolate that bile to synthesize the nanomaterial. Okay. And I very quickly I will go to this what you see. This is a you know, we use the nanomaterial from the plastic derived nanocarbon. You know, plastic container, say water bottle or, you know, milk packet or whatever it is, you know, oil packet, anything we are, you know, basically wrapped with the, you know, plastic. Now that plastic can be used to synthesize nanomaterial, that is the carbon nanomaterial. That is a non-metallic nanomaterial, and we are success of that. So we have done various non-metal nanomaterial, and subsequently we all, you know, published in the different areas. This is a very collaborative work with the SKBU, Sidhu Kanu Birsa University, and that was develop a medicine, a beautiful application. That is our also a recent work. You know, these are our collaborator, and these are the different funding agency. Definitely, without their help, we can't do anything. And with the help of the financial assistance from the Department of Science and Technology, even, you know, BRNS, all the funding agency extend their cooperation, and with the help of that. So this is our entire group of research. You know, this is our nanoscience group, and green tick is indicated they have already awarded, and those are not ticked at all. They are running, but all the other ticked, you know, Deep Chakraborty here, he's our waste valorization group, although he is working in the indoor pollution. So these are other, you know, publication. With this, I like to thanks to the organizer for giving me this opportunity. Thank you very much. Thank you, Dr. Chakraborty.
Thank you, sir. Thank you for wonderful presentation. Really, it is insightful for us. So now we move to the second lecture. So Dr. Aditi Singh.
Okay. In that case, can I leave? Can I leave?
Yes. No, sir. So, sir, be here, please. You are the chairman actually here, and I am the co-chairman. So,
okay.
Sir. So you should be there, sir. So next one is the Dr. Aditi Singh. Okay. So, okay. So, next plenary talk is going to start of the Dr. Aditya Singh. Dr. Aditya Singh is a Marie Curie postdoctoral fellow, the Department of Physics Institute of the Advanced Study at the University of the Warwick, UK. His work is broadly investigating study optical and electronical properties of the 2D material of the ferroelectric based heterostructure devices. Successfully realize of these nano heterostructure based device will open up new opportunity to design novel architect to encode and process informal data. Crucial next generation quantum technology. Before joining Warwick, Dr. Singh was postdoctoral research of the Freie University, Berlin, Germany. Dr. Singh obtained his PhD from IIT Delhi, and he was a Fulbright Nehru Fellow and University of the Peninsula, USA, and a Raman Sharpak Fellow at IPCMS CNRS, France. So he has published a very reputed publication in ACS, Material Today Communication, and many more. So he's given a invited talk in a national and international reputed conferences. Now we are welcoming to Dr. Aditya Singh to present to give your talk. Please, sir.
Hello. Thanks for the kind introduction. Just it's yeah. Thank you for the kind introduction. I will talk about the Raman spectroscopy of the layered materials, and I assume that my screen is visible to all of you. Hello.
Yes, yes, you are audible.
Okay, thanks. Yeah, I just want
Everything
to confirm, but yeah, okay,
start.
great. So, yeah. So, what are exactly these? I don't know why.
You are audible and your slide is visible here nicely,
but it's not
moving.
Yeah, it's stuck here. I don't know. Just sorry for the inconvenience. Let me.
No issue.
This is weird. Oh yeah. So is it moving now?
Yeah. It's
yes,
moving.
it is moving.
Yeah, sorry. Yeah, I think the system is like a bit slow now. Okay. Yeah. So Raman spectroscopy of 2D materials or layered materials. So what are exactly these layered materials? Like we live in the world of 3 dimension. Like we have height, width, and depth. But if you go like really smaller and smaller dimension, we can have such materials which are layered. Layered in means, so for example, like graphene, it has like this planar structure. So in plane, it has covalent bonding, and out of plane, it has van der Waals bonding, just like a weak bonding. So these materials, you can exfoliate or just clear them. And in Z direction, they have very small interaction. So these materials are called layered. You can have very thin and very large materials. And these materials, their electron gas, they form very exotic properties, like they are semi-metal and the Dirac fermions, which means at particular points in their band structure, the electrons, they are kind of massless. And if the electrons, they are massless, they move with very high speed, and velocity. And if you make transistors out of these materials, those materials will have very high mobility, means very high information processing. So these materials are very promising for the future communication devices, high order quantum computing. And so far, the research is going on how we can study these materials, how we can make these materials in a lab. There are various techniques to study them. And there one class of these layered materials called transition metal dichalcogenides. Traditionally, these materials are used as a lubrication just to like smooth some process in a machinery system. And also these materials has very strong excitonic coupling, which means they emit the light. Depending upon their band structure, means if they are bulk, like thick material, they will not emit the light. But if they are in monolayer, like a single atom layer, they will emit the light. So if we combine these properties of these materials and make devices, it will be like very revolutionary devices for the future. So these bulk 2D materials, as I told, in plane, they have strong covalent bonding, and out of plane, they have weak van der Waals bonding. So you can exfoliate, means you can take these materials layer by layer and make other kinds of materials. Like you just take a Scotch tape, and from the bulk crystal, you just exfoliate them and you can get the single layer of material. Interestingly, this was a process by Andrea Gam and Novoselov, and they got the Nobel Prize of developing and understanding this material. They just took the Scotch tape, usually we use in the lab, and bulk crystals, exfoliated the material and got the single layer of graphene. And they did the fundamental study and got the Nobel Prize in 2010. This is a vast family of materials which has like different kinds of properties. They have semiconductors, superconductors, insulators, high dielectrics. So if we make an artificial structure like WSE2 material as like a light emitting material, graphene as a back electrode, MOS2 again as a semiconducting material, dielectric. So we can make transistors, like futuristic transistors, which will have only two-dimensional materials with very unique properties compared to our classical materials like silicon and germanium. So the fundamental research is going on how we can improve the quality of this material, how we can get higher and higher quality, and understand their behavior, make electronic devices like transistors, junction diodes, and sensors, actuators. So the first part of my talk is about how we can study the basic property of these materials, like fundamental physics, how these materials behave when they are encapsulated or mean covered by different surrounding system. So we use Raman spectroscopy, and in Raman spectroscopy, this spectroscopy tells about the lattice vibration of the crystals, how the crystal is vibrating when then electron and phonon, they interact. So this is Raman spectra of the graphene. When the graphene is not defected, which is meant very nice and clean graphene. So it has two fundamental modes. This is called G mode, and this is 2D mode. However, when the graphene has some defects, it will form a band, which is called D band, because of the defect in the graphene, and a D dash prime band. And these are like a one phonon process. I will not go into detail of this physics. I will just skip this. So, so the motivation was because we are going to make a heterostructure, means like a layer by layer stacking of these materials, which is like a crucial for the transistor fabrication. So we want to understand how this material behave. So in this fundamental paper, it was if we use graphene on a system which has a silicon dioxide, which is classical material, and HBN, hexagon boron nitride, this is also two-dimensional material, very flat. So how the graphene interact with SiO2 and HBN. And we use Raman spectroscopy, and we see that if the graphene is surrounded by the hexagonal boron nitride, it's the peak of 2D mode is very sharp, and while as for SiO2 is very broad. And this is just because of the the very flat nature of the HBN and the graphene both, due to which this has very sharp and clean peak. So if we put two dielectrics of HBN and graphene is in between, still we see very high shift in this 2D mode, which means higher the environment screening, the mode of the 2D, it will shift higher and higher. And these dielectrics, they are very important for the transistor fabrication because they act as a barrier. So like in a transistor, you apply some voltage through a gate or metal, and if you don't put the dielectric, so all the voltage or electrons will just pass through the gate and you will not get a working device. So these materials are just to use to break the channeling of the electron. So here we used this technique is like standard technique of mechanical exfoliation of these materials. And we just put the crystal in between the Scotch tape, and it's like a hit and trial method. You try multiple times and you get the monolayer of the graphene or other 2D materials. We use this transfer station and fabricated this like one system of the material here. Monolayer of graphene, this is like around 0.3 or 4 nanometer thick, and monolayer of the MOSE2 is covered by the hexagonal boron nitride. And in this system, all the materials used, they are two-dimensional materials or layered materials. This process looks very easy, but it is very complicated to fabricate these kinds of structure. As you can see, the dimension is around 10 to 20 micrometer. So you have to be very precise and stack one layer on other just by looking at it, which is very difficult. After fabricating the structure, we wanted to study them. So we use home-built Raman spectroscopy setup, which looks quite complicated here, but here is just a Raman, and we use some filter to filter the light depending upon its power. We use different energy sources also. And to do the low temperature measurement, we use cryostat. So we fabricated a structure just to understand how graphene is behaving in different environment. Environment means how it is encapsulated with different dielectric materials. So in this black arrow, this is the graphene, and WSE2 is this one. And these are the holes on silicon dioxide. So the idea was to fabricate a device, a sample, which has all four regions like a suspended graphene, because these are the holes. If the graphene is on this part, so it will be suspended. So means it will be in air. So air will act as a dielectric here. So in this part, here the graphene is on SiO2 silicons. Here it has a WSE2 and graphene both, and here suspended again. So we did photoluminescence mapping. A photoluminescence tells the emission of the light from the material when you shine with the laser. So these parts, you can just see it's from this part, the mapping, spatial mapping with the how each part of this region emitting the light. So as you can clearly see, this part is emitting more light compared to this part, which is because the graphene is not surrounded by MOSE2, WSE2 is not surrounded by MOSE2. So it's more and more light in this part, and the quenching means suppression of the light because the MOSE2 is interacted with the graphene, which is like a metal here. So it's quenching the light. Further, in Raman mapping, you can also see Raman mapping, this part is collaborate with here, which has all four regions suspended and supported both. And you can see the shift in 2D mode in color. Color is changing. It means depending upon that environment, the graphene has a different interaction with the surrounding, and the 2D mode peak is changing. It's becoming more and more broad. So in a point measurement, like just at one point, if you do measurement like this point, and this point, then as you can see, the G mode of graphene is not shifting, which is like at the constant value, but 2D mode is changing, shifting from this mean value of line, depending upon the surrounding medium. And if we calculate how much is the shifting, which means how much is the interaction of graphene with the dielectrics, and we put the dielectrics in an order of increasing its dielectric constant. So you can see it's increasing monotonically. So we wanted to test these experiments with the different kinds of sample and with different laser source, so that we can generalize it is not just like one sample or one kind of measurement. So we fabricated the other samples also, but in these samples we use different laser source, and we saw that the 2D mode is changing with a different laser source, and their value is different. And this is because of the fundamental behavior of this 2D mode. So if the energy of the laser source is changing, the position of this 2D mode will also change accordingly. And this is the roughly value of 100 centimeter inverse per electron volt of the laser. So with the different laser source like 532, 633, and 785 nanometer, you can easily see here when the graphene was just suspended, which has air as a dielectric, all the three laser measurements at the same value, but as the laser energy is changing, their values is also spreading. Further, to test this more, we fabricated other samples like a WSE2, MOSE2, SiO2 silicon, and graphene, and we make different kinds of heterostructures, means like kind of sandwich, different layers in different combination. And as you can see, G mode is again constant and 2D mode is changing. So this was a universal. Why this is happening? And to clarify this experiment again, to see if it's whether it is something else, we did some measurements and clarified that there is no electron doping or hole doping in the system, or there is no stress or strain in the system. It's just purely because of the dielectric screening of the material. So what was the reason here why this G mode is changing and not, 2D mode is changing, not the G mode? So it turned out that I'm not showing here theoretical results. We did the calculation. The basic part was the 2D mode, which I have shown here, like this G mode, it is very sensitive to, not sensitive to the phonon energy, and also not sensitive to the dielectric screening, because this is one phonon process. And the symmetry of this mode is preserved in the interaction of electron and the phonon of the lattice. However, this 2D mode, which is changing with the laser energy and also the dielectric screening of the different material, this is a two phonon process, means we need two phonons to have this Raman scattering. And here, the light, if we shine the laser, electron goes from here to there, and using the phonon, it will just travel through here to this K valley, and here it will release energy, come back here again, and releases the photon that we measure in a Raman spectroscopy. And the symmetry of this phonon is preserved, means it's screening. So this was the reason that the graphene of the 2D mode here is showing the dielectric nature dependence and not this 2D mode, G mode. Further, in second part, I will show how we can use Raman spectroscopy to enhance the signals in other layered materials. There's another class of materials. They are called hybrid perovskites. They are used in solar cells, and they are very promising. At this point, these materials are just the research stage. We are trying to study how we can make a really high quality these materials, and these materials are very sensitive to the surrounding, means if you expose them to the air, they degrade very fast. So still they are in a research and development stage. So I did the Raman spectroscopy of these materials also. And these materials has a very nice behavior. If you put this material in some kind of cavity means if you put some kind of reflecting mirror, if the material are reflecting mirror, their electron and hole interaction form the exciton, and also if you shine the laser, they make some kind of hybrid particle, which is called the polariton. So usually, if you do Raman spectroscopy of these materials, they are very sensitive to heating, they degrade, their quality just goes bad. You cannot put them in air because of moisture, they degrade, and with the high laser power, they also degrade. So doing Raman spectroscopy of these materials was very difficult. Even if you do Raman spectra with using very low power, their peak will be very broad, and a lot of background information will come, like a PL intensity will contribute to the Raman signal. The Rayleigh scattering will also come. So the signal looks quite complicated. So what I did to do the Raman spectroscopy of this material without damaging the sample. So if you put the sample just on the quartz sample, which will not act as a mirror, laser light will come here, interact with the medium, some part will just go to the substrate, and some will reflect back, and you will have some signal. However, if you put the material on gold, and here the gold is working as a back mirror, and a back mirror, and as you see, mirror are very reflective. So if you incident the laser light here, it will go to the interface of this 2D perovskite and gold and reflect back and go here, which is usual. But this, as this 2D material has a very high dielectric value, it will reflect back from this air to this material interface, and they will just like a back and forth multiple reflection within the material. Because of multiple reflection within the material, it will form a cavity, and these interference of multiple reflection will enhance the electric field in the medium, and this enhanced electric field will give very high value of the Raman signal. And this was true for all these material. So suppose if you do the Raman of these reflectance measurements of this system without the cavity, it means if you just use this system and it has no reflection from the substrate, it will just form a single absorption here. However, if you make the material and put on the gold substrate and then do the measurements, because of this multiple reflection, it will form polaritons. So you see these two extra peak here, these two extra splitting peaks here. These are the polaritons because of the light and matter coupling in the system. So as you can see here, because of the high electric field in the system, the intensity of Raman signal has been increased. So in this graph, if you see, this was without the gold and this is with the gold. So gold is enhancing the Raman signal. And this was true for other kinds of material like RP3, RP2, and RP1. These are the different materials. And this has given a nice results that we can use if even for the weak Raman signal materials, we use the gold substrate and enhance its intensity. Further, this Raman signal was from 50 to 200 centimeter in inverse. If you go higher Raman signals, like from 1200 to 1800 signals, without these reflecting mirrors of gold, if you do the Raman, you see just the background here. It's like here background, and if effectively no peak, so you cannot get any information about the lattice vibration in this range.
Dr.
However, if you
Aditya,
use, yeah,
kindly conclude, please.
Oh, yeah, it's just I think 2 minutes. Yeah, thank you. So here you can see two new peaks emerging during if we use the gold as a reflecting mirror. So this was a result to enhance the Raman signals of these materials. And further, we also got, if you plot as a logarithmic, we got few new peaks which were theoretically possible but not experimentally observed. But in our case, we observed the theoretical details of the samples and theoretically predicted new peaks also. So I conclude here. So in first part of the conclusion of the first part is we can use dielectric materials and use Raman spectroscopy to measure the dielectric streaming at the Kohn anomaly point. And also these 2D materials, they have very high dielectric constant and very effectively they can be dielectric for the transistors. Also, we can use this open cavity system like using the gold to enhance the Raman signals of the system. I acknowledge my PhD supervisor, Professor Rajen Singh, Raman Charpak host, Professor Stephen, and Deep Chariwala, and my former lab members and funding agencies. Yeah, thank you for attention.
Okay, thank you, Dr. Aditya. Really, this is very wonderful work, and this is insightful, and this is very interesting. Although, so I'm very thankful to Dr. Professor Naba Mandal sir to chairing this session, and Dr. Aditya Singh. Thank you very much for a wonderful talk. And now I hand over to the things to the Dr. Malik sir to start a new session. Thank you, sir.
Thanks. Yeah. So I'm just stopping it.
Thank you, Dr. Abhishek, for conducting the session beautifully, and thank you to the plenary lectures and giving the information regarding nanotechnology in a detailed way. Okay, now we will be starting in the next session. It's the next technical session where our chair will be Dr. Vinay Dwivedi. He is done his schooling from Kendriya Vidyalaya 1 and he's done BSc MSc from Bundelkhand University. He will be chairing the session as is in a meeting, so he will be joining. He is there, but he will be joining soon. He has completed his PhD in biotechnology engineering from UP Technical University and has a 22 years of teaching and research experience, published more than 58 research papers in various national and international journals. So I thank Dr. Vinay Dwivedi for being the chair of this session. Now I'll be continuing with the session. We'll be inviting our first plenary lecture for this session is Professor Tarit Raychaudhuri. He is a professor of School of Environmental Studies, Faculty of Interdisciplinary Studies, Law and Management, Jadavpur University, Calcutta. And he is a former Eco Frontier Fellow, Ministry of Environment, Government of Japan, and JSPS Fellow, Ministry of Education, Government of Japan, former scientist, National Environmental Engineering Research Institute, Nehru Marg, Nagpur, Maharashtra. He was, yeah, and he has been in the research and in the research field in the science in Jadavpur University, Kolkata for a long time, and he has been spent 6 years in the National Institute of Health Science, Tokyo, Japan, for postdoctoral research. After that, he will be doing the different academic institutes and performing different types of activities, extensively performed research activities on several groundwater contaminants and toxic pollutants like arsenic contamination issues in West Bengal, India and Bangladesh and other parts of Ganga, Meghna, Brahmaputra plain of India, with special reference to its distribution, magnitude, calamity, adverse health effects on human and domestic livestock, geological source, food chain contamination, with special reference to the staple crops, rice, grain, and remedial measurements. Dr. Raychaudhuri also focused for his research studies on human health risk entering through the several other groundwater contaminants like fluoride, nitrate, uranium that impacts on the environment and the remedial measurements in domestic and community level. So I welcome herewith Professor Tarit Raychaudhuri to deliver his plenary lecture in this session. Sir, you can start now. Yes, sir, it is visible. You can.
Am I audible? Hello? Hello?
Yes, sir.
Audible?
Yes, sir, you are audible. Just bit louder. Just speak a bit louder.
So, very good afternoon to all of you. So, at first, I want to thank to the organizer, particularly Department of Environmental Science, Amity School of Life Science, Amity University, Gwalior, for this, for giving me the opportunity to present our live environmental research. as well as I am thankful to Dr. Ritobroto Maulik and Dr. Deep Chakraborty, who are very much well known to me for the last several years. So my today's students' contribution is going to be groundwater contamination scenario in West Bengal, India, food chain contamination, adverse health effects, and mitigation strategies with special reference to arsenic, fluoride, and nitrate. So let us see, when the first contamination problem was reported from West Bengal, that was during 1983. Only 2 blocks, namely Barasat and Baripur, have been reported as groundwater arsenic contaminated. During that time, the recommended value of arsenic in drinking water was 50 microgram per liter. Nowadays, it becomes decreased to 50 to 10 microgram per liter. So this is the condition of 1983. This is the condition of present groundwater contamination scenario in West Bengal. 148 blocks from 14 districts groundwater is arsenic contaminated. Out of these 14 blocks, 6 blocks are located on the east side of the river Ganga, and 3 other blocks are located on the west part of the river Ganga. Other than these 9 blocks, 5 other blocks, namely Darjeeling, Jalpaiguri, Coach Bihar, North Dinajpur, and South Dinajpur, are located in the northern part of West Bengal. And this is the present groundwater contamination in the entire Ganga Meghna Brahmaputra plain, starting from Allahabad Kanpur tract to Uttarakhand, to Uttar Pradesh, to Bihar, Assam, Jharkhand, West Bengal, Bangladesh, and all the 7 northeastern hilly states groundwater is contaminated with arsenic. Now let us see, even after knowing the groundwater is contaminated with arsenic, fluoride, or some other heavy metals, why we are still withdrawing groundwater? Thing is that groundwater is available throughout the year just by installation of 1 pipe and 1 filter. That means 26 feet groundwater is available throughout the year. Nowadays, due to huge withdrawal of groundwater, water table has been declined. This is going to be another severe problem in major part of our Indian city, India. And just for installation of 1 pipe and 1 filter, it costs only $250 US. So villagers can afford this amount of money for their own tube well. This is one of the very important observation. Arsenic distribution in groundwater. You see, arsenic concentration initially increases up to a certain depth, approximately 40 meters. That means around 140 feet below the ground level. Then decreases with increase of the depth. So that means this is the reason why shallow tube wells, shallow level is mostly contaminated with arsenic compared to the deep aquifer. And this very important observation was published in world-renowned journal Nature during the year 1999. This is another very good information. Arsenic concentrations in many tube wells had been increased 5 to 7 times within a span of 3 to 7 years. That means, suppose today my domestic tube well water is safe with respect to arsenic, that does not mean it will remain safe forever. With time being, maybe arsenic may enter in the same aquifer zone. Let us see the agricultural irrigation practice in West Bengal. To meet the food demands of the increasing population in Bengal Delta, the growing season has been expanded from 1 to 4 or 5 crops per year. Rainwater alone can no longer meet the water demand of such intensive agriculture, since only limited rainfall occurs during the dry season. Another important thing is boro cultivation, which is nothing but summer season cultivation, which requires a huge amount of water for cultivation. That's why groundwater withdrawal is very high for agricultural irrigation purpose. Just to see the rice cultivation practice in West Bengal or other parts of India, just for production of 1 kilogram of rice, 2,000 to 3,000 liters of water is required. Plants never ask this huge amount of water. This is the mismanagement or misuse of agricultural policy, because we used to flood the paddy field during the entire boro cultivation season. And this is the water requirement of paddy plant at different growth phase, starting from vegetative phase to reproductive phase to ripening phase. You see vegetative reproductive phase, water requirement is quite high. It is in this ascending order, and from reproductive to last phase, that is ripening phase, it is in decreasing order. If you consider a particular block, namely Deganga, located in North 24 Parganas districts, if you consider all the shallow tube wells used for agricultural irrigation purpose, 6.4 tons of arsenic was withdrawn and deposited on agricultural land soil. So what will happen? So after arsenic deposition in soil, plants will start to uptake that arsenic, and there is a possibility of spreading of arsenic in different parts of plant parts, and moreover, it will enter in the food chain. This is our extensive study, arsenic contamination scenario in food chain. You see, in most of the parts of West Bengal, arsenic has been entered randomly in vegetables and different types of cereals. And the most dangerous thing is that the arsenic that has been found in food chain, particularly rice grain or other parts of vegetable, that is inorganic arsenic, namely arsenite and arsenate, which is toxic and carcinogenic. Just for your information, there is another part of arsenic is available on earth surface, that is called organic arsenic, namely arsenocholine, arsenobutane, which are mainly available in sea environment. We used to consume huge amount of organic arsenic in our daily life through consumption of shrimp, lobster, crabs, but this organic arsenic is totally non-toxic. Toxic is inorganic arsenic that has been found in groundwater as well as in agricultural food system. This is the HPLC chromatogram, which clearly indicates the presence of arsenite and arsenate in rice grain and arsenite and arsenate in vegetable leaf. And whatever I am presenting to my research, to my talking today, most of the 98% of the things are based on our own published research. So this is one of the cyclic process. You see, rice cultivation during pre and post monsoon, followed by post harvesting, followed by cooking, followed by health risk evaluation. So arsenic is simply going on this way. During pre and post monsoonal cultivation, as per our report, we have found 3 times higher arsenic accumulation in pre-monsoonal cultivation compared to the post-monsoonal cultivation, because post-monsoonal cultivation is mostly dependent on rainwater. Followed by is post-harvesting, I mean the preparation of parboiled rice grain, I mean seed the chowl from from atok chowl or sand rice grain. So during this preparation of parboiled rice grain, the farmers or villagers use their domestic level arsenic contaminated tube well through tube well boiling process, and there is an entry of additional arsenic in the parboiled rice grain compared to the sand rice grain. During the cooking of rice grain, because the rice grain, raw rice grain, we do not consume raw rice grain. What we cook, we consume after its cooking. And during the cooking of rice grain, water is required. And that water arsenic concentration is very much important for its flow from raw rice grain to cooked rice grain. You see, apart from our publications in peer-reviewed international journals, our research is throughout the year covered by well-renowned news media and electronic media throughout the year. This report was published in Hindustan Times. Kolkata's vegetables, rice and flour high on arsenic, says top university. This is the reference of our university, Jadavpur University. Kolkata's bazare arsenic thaba. That means arsenic enters in Kolkata food market. So this is the biggest problem nowadays. The population who are residing even in control zone where there is no mapping of arsenic contamination in groundwater or in surface water, but still arsenic can enter through transportation of agricultural crops and vegetables, why we suffer. And this is the biggest challenge nowadays for the researchers and scientists all over the world, that entry of arsenic in food chain. Just 3 weeks before, we have completed one international conference organized by KIT Bhubaneswar that was called AS 2024 conference. And in that conference, we all the renowned scientists showed the path how to come out from this entry of arsenic in food chain. Let us see one of the example of the school children. The name of the school children is Chokkamadanga Fifth Primary School, located in Boshidat 1 block, North 24 Ganesh district. When is visited first time the school campus, the school has 2 tube wells. One contributed 550 microgram per liter, and another contributed. And this tube well water was used for not only drinking for the school children, but also used for the midday meal preparation. So immediately after checking this arsenic concentration, we thought this entire school children might be at risk due to severe arsenic toxicity. We collected their domestic household tube wells. We collected their different kinds of biomarkers like urine, like hair and nail. For your information, urine is a biomarker of acute toxicity of arsenic, and hair and nail, due to the presence of keratin cells, are the biomarkers of chronic toxicity of arsenic. And we have found huge amount of arsenic deposited not only in their urine, in their hair and nail sample. And this is another biggest problem. If you see all the intakes and extakes, in the left hand side, intakes increase, school tube well contribute to this amount of arsenic. Children's domestic tube well contribute to this amount of arsenic. Domestic rice grain contribute to this amount of arsenic. Midday meal preparation contribute to this amount of arsenic. And this is the urine, hair and nail contains huge amount of arsenic studied from a good number of school children. And the most dangerous thing is we have found urine epithelial cell in micronuclei, which is a clear indication of severe arsenic toxicity. Let us see one of the school located in Kolkata. Kolkata is apparently arsenic contaminated. The southern part of Kolkata district groundwater is arsenic contaminated, but in most of the part groundwater is quite safe. And most interestingly, the local government or Kolkata Metropolitan Development Authority, they used to supply treated Ganges water for drinking purpose. So considering drinking water scenario, Kolkata is far safe compared to the other exposed districts. But you see the danger thing is that the rice grain Kolkata people is consuming, that is contaminated with arsenic, because Kolkata is a district which is not cultivating rice grain. Rice grain cultivated in the surrounding part of Kolkata districts, and it is transported from the surrounding districts of Kolkata to surrounding districts of Kolkata and enters in the Kolkata market. So rice grain is arsenic contaminated. So this is the future danger or current danger in not only Kolkata, many parts of India, considering its transportation from exposed to unexposed areas. You see, this picture clearly indicates, if you consider the cancer risk to arsenic toxicity, considering drinking water, 96% contribution comes from exposed area and 4% in controlled area. But you consider the cancer risk to rice consumption, 55% counts for exposed area, and it is nearby knocking 45% comes in controlled area. Let us see the condition of the domestic livestock, because we used to consume, the human used to consume maximum 3 to 5 liters of water in our daily life. But if you consider domestic livestock, like a cow or buffalo, they used to consume 40 liters of water in their daily life, as well as 5 to 7 kilo of hay in their two different kind of fodders. And if this water is arsenic contaminated or the fodder is arsenic contaminated, well, what will be its impact on their body? You see, we have studied extensively, and this work was published in the journal Environmental Geochemistry and Health. If you consider all the kinds of intake starting from water and different fodders like corn, husk, straw, contains significant amount of arsenic. If you consider the excreta part like cow dung, like cow urine, like cow tail hair, contains significantly amount of arsenic. If you consider the animal byproducts, cow milk, chicken flesh, egg, mutton, chicken liver, and considering all the different kinds of animal byproducts contributed somewhat a very good amount of arsenic. If you consider the sweet item, sweet is a thing which is prepared from milk. So if milk is contaminated with arsenic, there is a possibility of its entry in sweet item. And we have found considerable of arsenic in different parts of sweet item. And most interesting thing is, if you consider the milk, 83% of arsenic is deposited in the casein part of milk, because casein has phosphoserine group which contains functional phosphoric acid groups. Phosphorus and arsenic have a similar, very close affinity to each other, because both arsenic and phosphorus belongs to the same periodic table group. Our published research was covered by the renowned magazine Outlook. You see, Bengal's arsenic challenge grows bigger as the toxin seeps into the food chain, grains, dairy milk. Considering milk, including milk, all kinds of animal byproducts contain considerable amount of arsenic. By 30 states, West Bengal, Gaigata, where arsenic toxicity in livestock is now adding to poison in human bodies. Published by India Today, beware of that majbhat. Majbhat means machli or chowl, or rice or fish. Let us see the arsenic toxicity and adverse health effects. Considerable of arsenic has been found in different types of human body tissues like hair, nail, and urine sample. And most interestingly, considering the HPLC chromatograph of urine sample, we have found high amount of methylated arsenic, because if you consume arsenic through drinking water, it will immediately methylated and converted to different methylated species, namely dimethyl arsenic acid and monomethyl arsenic acid. And this picture clearly indicates DMA and MMA contribute approximately 90% of total content of arsenic. Considering different kinds of arsenical skin lesions, all kinds of arsenical related health risks, health issues have been found in the affected population. And millions in Ganga Meghna Brahmaputra train exposed to arsenic contaminated water. This report was published by the renowned news media The Hindu, and this is the pictures of different kinds of severe chronic arsenical skin lesions. So now let us see the nutritional status and arsenic toxicity. There is a very good relation between healthy nutrition and arsenic toxicity. People with healthy nutrition suffer less from arsenic toxicity compared to undernourished people. But the problem is 80% of the population of West Bengal and Bangladesh, and most of the children would not suffer from arsenic toxicity. They could get better nutrition. Child malnutrition is disturbingly high in India, Nepal, Bangladesh, and Afghanistan. Around 2/3 of Asian maternal deaths took place in India and Pakistan. So if this entire generation, if this entire population would get healthy nutrition never means, I am not mentioning chicken, mutton, and other things, only good, healthy, green vegetables. If this entire generation could get healthy nutrition, they could fight against the arsenic toxicity. This is another very good research observation. Selenium and zinc, the two important micronutrients in human body, and they are antitoxic to arsenic. In our observation, we have found their lesser amount of presence in different water and foodstuffs compared to the recommended value of selenium and zinc. So how they will fight against the arsenic toxicity? This is very important, right? Exposure to arsenic in drinking water during early childhood or in utero has pronounced pulmonary effects, greatly increasing subsequent mortality in young adults from both malignant and non-malignant lung cancer. And the robust impact of a mother's arsenic consumption on fetal gene expression, as evidenced by transcript levels in newborn cord blood. Let us see the fluoride contamination scenario of India. If you consider the magnitude and calamity of arsenic, fluoride contamination scenario is much higher. It has been reported that most of the Indian state groundwater is fluoride contaminated. Overall, 62 million people in 19 states in India, including 14 million children, are fluoride affected. And fluoride is not carcinogenic, but it is toxic after its entry in human body above its recommended value that is fixed by the World Health Organization or Bureau of Indian Standard in drinking water. It has been recommended 1.5 milligram per liter. So fluoride is a toxic substance. After it is entering in human body, it can start to attack the calcium where it is present. And in general, calcium is present in teeth and in bone. That's why dental fluorosis like this and skeletal fluorosis like this is very common in the case of acute fluoride toxicity. This is the present groundwater arsenic contamination scenario in West Bengal, groundwater fluoride contamination scenario in West Bengal, and this is completely based on our own research studies. This is the present scenario of Rajput Sonapur municipality located just beside Kolkata district. This municipality has 35 wards. Out of these 35 wards, we have found 14 wards with fluoride contamination above its recommended value of drinking water, and out of 35 wards, 26 wards we have found groundwater arsenic contamination above its recommended value. So this is a topic of research interest. Both arsenic and fluoride is found in the same geographical region. This is the fluoride contamination scenario of Baripur block. It is also nearby located in Kolkata district. I will take just 5 to 6 minutes more.
Yes, sir. Yes, sir. Okay.
This Baripur block is located surrounding Kolkata district. The Baripur has 5 gram panchayats. We have found fluoride contamination in groundwater above its recommended value. And most interesting thing is this research was published in the renowned Elsevier journal Science of the Total Environment. And we have found in general from the other observation, we have found fluoride, that is calcium fluoride, CaF2 is responsible in most of the cases of fluoride leaching from mineral to groundwater. But in this case, we have found muscovite, which is a pure silica, pure quartz particle that is responsible for fluoride leaching from mineral to groundwater. And muscovite, that is a pure silica SiO2 related big chain compound in which fluoride is entrapped in the crystal lattice. And through this research observation, we have proved that muscovite is responsible via fluoride leaching from source to aquifer. You see the newspaper reading published in Anandabazar Patrika, both arsenic and fluoride are just knocking the door of Kolkata, or it has been entered already inside the city. Let us see the nitrate contamination scenario in West Bengal. If you consider Nadia district, we have identified 4 different blocks of Nadia where we have found more than its recommended value considering nitrate contamination scenario, and it is recommended at 45 milligram per liter. If you see the Bardwan district, 6 different blocks have been identified where it crosses the recommended value of nitrate in drinking water, that is 45 milligram per liter. And the interesting chemistry of nitrate is nitrate after entering in human body system, it is reduced to nitrite, NO3 minus to NO2 minus. And this after its conversion to nitrite, it converts ferrous Fe plus to present in hemoglobin to ferric. So this ferrous plus to hemoglobin complex activity is totally disturbed and it will be converted to Fe plus 3 hemocyanin or metheoglobin. So hemoglobin, blood hemoglobin function will be totally destroyed, and there is it will prevent the transportation of oxygen in the blood system, and children are very much sensitive to this nitrate contamination. That's why it is called blue baby syndrome, because the color of converted metheoglobin is blue. Let us see the research report published in different news media, published in the Bengali news media. এই সময় 4 different blocks in Nadia district is in nitrate contamination problem. Published in Bartaman Patrika, the chemicals we are used as fertilizers in the agricultural field are leaching behind nitrate. Considering the arsenic contamination, fluoride contamination scenario, all came through natural sources, but this natural contamination is the totally anthropogenic source. The fertilizers, mainly nitrogen containing fertilizers like ammonia, urea we used, and the unused fertilizers that remain on the agricultural field soil, that with time being with rainwater, it leaches and enters to the underground system and contaminate the underground aquifer. Published in the Outlook journal, Groundwater Nitrate, New Concern for Arsenic Hit Bengal. Let us see the mitigation strategy. West Bengal is a state, has 2000 millimeter annual rainfall, big oxbow lakes, rivers, ponds, other streams, etc. But what is its use? This is my question. What the scientists we are telling for last 30 years, we need to harvest the rainwater harvesting system. We need to protect the surface water body system. Other than that, we are still continuing withdrawing the groundwater without maintaining any scientific protocol, and that's why we are suffer worst at this moment. Let us see the several arsenic removal plants. The work of arsenic removal plants is to remove arsenic from contaminated raw water and to supply the treated safe arsenic water, safe arsenic contaminated water. But instead of providing, instead of supplement of safe arsenic contaminated water, due to tremendous lackness of regular maintenance, the treated water is even arsenic contaminated. You see this point, successful run of the plants needs proper awareness, literacy, infrastructure, economic strength, skilled manpower, contemporary technologies, and people's willingness to pay use. Sustainability of a developed technology only works when a combination is made between technocrats, policymakers, and villagers with proper village level participation. So there is no communication. This is my question. This is my worriness. This is no communication between a researcher, between a scientist, between the policymakers, between the villagers, and between the local government. So this is the thing why we are suffering adversely worse nowadays. And this research was published in the very renowned Elsevier Journal of Hazardous Materials. So after working in my case 30 years in this particular contamination field, considering arsenic, fluoride, nitrate, and other heavy metals, this is the best option how to mitigate. Use surface water after its proper treatment. You see the water surface resources in West Bengal, East Kolkata Wetland, Roshikville, Kochbihar, Sundarban, Ahironville, Murshidabad. But where is this used? Rainwater harvesting technology system, different technologies. On the day of World Environment Day, we used to tell big words, ye karna hai, o karna hai, rainwater we need to harvest. But what is the use? There is no management, no system, nothing throughout. Awareness is very important to fight against the arsenic toxicity. One international conference was organized by Sulabh International Organization, and that was the venue was in Sonar Bangla Hotel, Kolkata. You see, this is late Professor K.J. Nath. He was the chairman of Arsenic Task Force. He is the proprietor of Sulabh International. Late Dr. Bindeshwar Dubey. He is Dr. S.P. Sinarai, chairman Fluoride Task Force Committee, along with myself. So this awareness is very important, and whatever people came to know, not only in Bengal or Kolkata or other part of West Bengal, absolutely in other parts of Ganga Meghna Brahmaputra plain about arsenic contamination scenario. This is due to our extensive research and contribution in news media, electronic media, or national or international journals. To protect the arsenic, there are several techniques available to arrest arsenic in soil plant system, intermediate pond, use of different kinds of organic amendments, and several other things. Especially several microorganisms are able to volatilize arsenic. So we need to adopt these kind of alternative technologies to arrest arsenic in soil plant system. You see organics, different organic amendments like farmyard manure, vermicompost, they are able to arrest arsenic in soil plant system. If you see this cultivation, one is rice cultivated in flooded condition, another is aerobic condition. You see the rice cultivated under aerobic condition contributed much lesser arsenic compared to the flooded condition. This is the best SRI technology: less water, less seed, fewer plants per unit area, less chemical fertilizers, more organic manure, less pesticides. This is called rice intensification at a glance. This is a recent research publication from our unit. Sustainable water management in rice cultivation reduces arsenic contamination, increases productivity, microbial molecular response, and profitability. Instead of doing flooded condition in the paddy field, if we use alternate dry wet cultivation practice, it can reduce arsenic contamination in plant soil rice system considerably. Several novel research published was from our unit, like if you use potassium humate as a priming agent, if you use sulfate as an inorganic amendment, they have the power to reduce arsenic considerably in soil plant system, and finally able to reduce its entry in crop and vegetable system. So all this research was published. This research was published in Ecotoxicology and Environmental Safety based on potassium humate as an priming agent. This was published in Environmental Pollution. Now, if you consider the entire water resource all over the world, you see groundwater contributes only 1.05%. Even after knowing groundwater contributes 1.05% for each and everything, drinking, cooking, household, and other domestic purposes, even agricultural irrigation, we are dependent on groundwater. It's time to tax groundwater use, published in the Hindu 2019. It's time to tax groundwater use. But who cares? Nowadays, another dangerous thing is water business. Without maintaining any kind of protocol in exposed areas, arsenic chloride, nitrate, people, some businessmen are doing business with taking water out and pouring it in 20-liter jerrycan. Price is 20 rupees, and this is a very common business. No government, no municipality, no management system, nothing is maintained. If we are not careful, we have to be experienced very soon, like this kind of tremendous water scarcity, what had been experienced by few of the renowned cities of southern India, like Bangalore or Chennai. Slowly, the effect of water crisis will be more severe in developing countries than many atomic explosions. Bhishma, on his deathbed, he asked for some water for drinking purpose. Arjuna was present there. He was ready to take out water from underground. Bhishma immediately denied and told him, this is not for drinking purpose. This underground water is for natural balance. Do we forget the lessons we learned from our own epics, Ramayana, Mahabharata, Gita, Veda? Water, the elixir of life, keep it out of politics. So this is my entire research unit. So whatever I am presenting here, whatever my present status, my present name, world level scientist, this everything comes considering the contribution of my students, starting from master level, starting from PhD level, starting from postdoctoral level. So I am really lucky that I got a very research unit which is surrounding always with me. So thank you for your attention. I'm sorry, maybe I have taken some additional time, but
Thank you so much, sir.
Thank you, sir, for your excellent speech and excellent information. I hope that participants have got many information and knowledge about arsenic groundwater contamination in a detailed way. So I'll be very much thankful to Professor Chaudhary. I hope many things have come up, and future studies will be also helping in this groundwater reality, what is happening in the water sector, and especially in the arsenic.
Okay, sir, thank you. And sir, you can be there in this session because we'll be going with the next plenary speaker. So let me introduce next speaker is Dr. Arunlal Srivastava. Dr. Arunlal Srivastava is working as Associate Professor at Chitkara University School of Engineering and Technology, Chitkara University, Himachal Pradesh. He got the PhD from IIT BHU, Varanasi in water treatment. He has done postdoctoral research in National Chung Sing University, Taiwan. He is currently involved in the teaching of environmental science, environmental engineering, disaster management, and design thinking to the undergraduate engineering students. His research interests include water quality surveillance, climate change, water treatment, river ecosystem, soil health maintenance, engineering education, phytoremediation, and waste management. He has published several more than 100 research papers in various research journals, Elsevier, Springer, IWA, Taylor and Francis, and also has published several books as editor and co-editor like Springer, Nova, IGI Global, and Willy. Additionally, he is also one of the series editors of Elsevier and Nova publication on energy sustainability and e-waste management, respectively. He has received the prestigious Teachers Associateship for Research Excellence (TARE Fellowship, followed by research grant from Science and Engineering Research Board (SARB), Government of India in 2022. He has also been recognized among the 2% worldwide scientists of Earth and Environmental Sciences jointly by Stanford University and Elsevier in the year 2023 and 2024. So I welcome Dr. Anulal for his speech. Kindly, sir.
Thank you,
can
sir. Thank you. Thank you so much through the organizers for inviting me, for giving this chance to share little bit whatever I know. So, shall I share my screen, sir?
Yes, Dr. Srivastava, you can share.
Is it visible, sir?
So visible.
Yes, sir, visible.
Visible.
Okay. It is moving, sir?
Yes, moving. You can start.
Okay, thank you so much. So thanks again to the organizers for inviting me to share my thoughts about the sustainable and innovative aspects for the waste management. So how much time do I have, sir?
That try to finish in 10-12 minutes.
Okay, thank you. So as we are so much aware about the types and waste, so different definitions as per the perspectives of different researchers, sources, impacts, and I will also discuss a little bit about the Indian scenario and waste management practices along with some success stories. So what is basically waste? This is unwanted materials and which can be referred as unusable materials, means the materials which are of not having any kind of use, any kind of further use, that can be referred as waste material. So this is the type of waste material. So on the basis of matters, we can divide into three types: solid, liquid, and other air type of waste materials. And the basis of degradability, we know that they are biodegradable and non-biodegradable. On the basis of environmental impacts, they may be hazardous or non-hazardous. On the basis of their source, household, industrial, and etc. So these are the some sources, as we all know, and the major sources of the waste materials are mining, forestry, agriculture, then household, that is municipal solid waste, construction and demolition waste, and some sludge which is coming out from the wastewater treatment facilities. So this is the statistics as per the CPCB, Central Pollution Control Board, regarding the e-waste generation. We can see in the 17-18 it was 7 lakh tons, and in 2022 it has been increased up to the 16 lakh tons. So this tells about the problems, magnitude of problems of various types of waste. So as per the University of Michigan, these are the composition of waste materials, in which we can see the food waste papers are having mostly their role are more, their composition are mostly present in the various types of waste. So means they are biodegradable in nature, and we can derive some value-added products from using these biodegradable wastes. So what are the impacts of waste materials? Basically, they all are responsible for all kind of environmental pollution, including air, water, soil, and they are also directly and indirectly creating human health impacts. So this is what these are the some problems. As we can see in some research papers, it has been reported that dioxins, greenhouse gases, heavy metals, BOD, COD, there are so many toxic and radioactive materials are also coming out from the waste materials, along with some pathogenic organisms. So these are some toxic metals which have been found in various types of municipal solid waste when they have burned out. These are some human health diseases reported, which are directly or indirectly related with the waste mismanagement of the waste materials, including headache, nervous system damage, particulate matters like ozone is responsible for the secondary kind of diseases, respiratory problems. Even some of the particulate matters have been reported to create the problems to the heart as well. So if we talk about the plastic, everybody is talking about the plastic. So plastic is relatively very dangerous for the health of human beings, and it may cause several types of problems inside the human body. So in total, we can see there are some economic impacts, environmental impacts, as well as health impacts to the, if we talk about, especially about the human beings. So these are the 5 municipal solid waste generators in terms of different countries. And if we talk about the India, as per the estimate of 2016, India is generating around 277 million tons of the waste materials. By 2030, it will reach up to around 387. By 2050, it will touch 543 million tons of the waste. So followed by the USA, China, Brazil, India. These are the 5 most solid waste generating countries of the world. So we can understand the problems. So if we talk about, especially about the India, there are 7.2 million tons of the hazardous waste, only hazardous waste. Then 1 square kilometer of additional landfill area is required every year. And if we talk about the money, 1600 crores rupees is required for the treatment and disposal of these waste materials. So in addition to this, industry is also responsible to discharge 150 million tons of the high volume of low hazardous waste. Along with, apart from these 2 hazardous and industrial waste, there are so many types of waste are being generated from the various sources, and we covered earlier. So these are the general definition of the hazardous waste. If any of these property characteristics is present with any material, that can be referred as hazardous in nature, which may be ignitable, may be inflammable, reactive, or corrosive. So the plastic waste, this picture can tell us very well what is the magnitude of this problem. We can see these are the countries which are using the plastics. We can see India at the 5th place, but at the 1st place US is there. So we have to stop, we have to reduce at least the use of single plastics. These are the name of countries which are very famous for the mismanagement of plastic waste, and India is on the top. So we can see the USA was using more, but in this list, I think it is not present over there. So we have to think on this. So as per the statistics, 8 million tons of plastic waste are entering to the oceans every year, which is very alarming. Because there are, if we talk about the ecosystem, ocean ecosystem is the most biologically productive ecosystem, and so many, maybe millions of people are dependent on the oceanic resources to get their food and livelihood purpose. So we can assume the level of this problem, and we have to think to reduce the use of the plastic so that we can save this ecosystem. So what are the problems? Basically, the lack of awareness, education, voluntary participation of the society, and collection of the waste, segregation of the waste, technological interventions, institutional and regulatory frameworks, absence of mandatory standards for waste reductions, market actions for waste reductions. These are some common problems which we need to address so that by incorporating all the stakeholders, those who are directly or indirectly related to the solid waste management or solid waste generations. So then only we will be able to decrease the level of problem. So in India, if we talk about the primarily by the city municipality, different municipal corporation is responsible, and local rack pickers like Kabadiwala and other things, they are other people which are responsible to collect the waste. So what is waste management? So in general, the prevention, reuse, recycling, recovery, disposal, it looks like a inverted pyramid. But we can say that prevention is better than cure. So we have to adopt the preventive steps so that the waste generation can be reduced at the source of the generation of these waste materials. Then we can promote the reuse, recycling, recovery, and finally, if the final residues can be sent out to the landfills for the disposals. So recycling is one of the best process. What are the benefits? Maybe reduce the environmental degradations, making money out of waste, save energy into the waste handling and product manufacture. It is a process of collection, transportation, segregation, and treatment, and environmental friendly disposals. So this is again the pictorial view of that process. So steps for the municipal solid waste management, door-to-door collection, public dustbin, etc. can be installed at the various places. Segregation at the source, maybe municipal levels. But if it is at the source, it would be nice. Transport separate vehicles for the different types of waste materials. We have to adopt the concept of 5R: recycling, reduce, reuse, recovery, refuge. Composting is one of the best process for the biodegradable waste materials. And waste to energy. We can derive some, we can produce energy by using waste materials like the process, refuse derived fuel, biomethanation, incineration, and final residues can be sent out to the disposals. This is the colors for the different dust which can be used for the segregation of biomedical waste. Then the integrated solid waste management steps can be also be adopted. So it says waste reduction should be at source, reuse, recycling should be promoted, and processing of waste can be achieved through the RDF and composting, etc. Transformation of waste through the incineration for the volume reduction, final disposal to the landfills. This is the steps which we have already covered almost. Difference between dump and a landfill. Dump is an open hole where everybody can come and throw their waste here and there. But landfill is a carefully designed by the environmental engineers where we have to put our waste by the skilled workers so that it may not create problem to the environment as well as society. So this is what we say sanitary landfill. So this is the cross section of sanitary landfill sites, in which we can see that there are different chambers in which we have to follow the sequential filling of the various waste materials, and there is a leachate preventive systems as well. And after the covering of all the chambers, we can plant some trees over there. We can have some plantations so that it will not create any problem to the environment. So the advantage of sanitary landfill: low cost, absorb massive amounts of solid waste, replanting, we can replant, reforestation can be done over there, access to the methane which can be collected and can be used as a source of energy. Some leakage of air pollutant gases like methane, carbon is not properly managed, then the gases can cause the greenhouse effect. These are some case studies of the plastic waste management. Utilization of plastic waste in road construction in Bengaluru, in Hyderabad. So we can get more information by searching these things. So these are some processes where the plastics are being used. This is another examples where the PET plastic bottles have been used for making apparels, milk pouches. Single-use plastic can be used, barsati film, plastic open sacks. So different plastic materials have been converted into the value-added products so that it can not be very harmful for the environment and it can be reusable. These are some success stories. So benefits of the waste management, it protects human health, environment, everybody knows. It also saves money, creates jobs, and supports the economical development. It also conserves the natural resources and saves energy by reducing the demand for the new materials. Mitigating climate change by reducing greenhouse gas emissions. It also promotes the social welfare and equity by improving the quality of life. This is the government of India's initiatives to manage the solid waste. Different rules and acts have been passed by the Parliament of India so that different types of waste can be managed very well. But what are the challenges? As per the United Nations, occupational safety, those who are working in the field, their safety is having great concern. Lack of proper environmental guidelines, somewhere proper guidelines are not available. If available, they are not understandable. The manufacturers should get some motivation so that they can develop more environment friendly products. Active public participation, which is one of the most important part, because once the public participation is ensured, and the rest of the things can be achieved very well. So this is a story of Satyamev Jayate, part 4. Those who are interested, they can see, because we do not have enough time. This is one of the best example how to manage the waste materials which are created by our homes and other neighboring partners. So sustainability, we know that sustainability requires, it talks about the people, planet, and profit. So we should always take care of the society, environment, and economics equally. This is what we say sustainability. Sustainable development, we should also take care of the needs of our future generations without compromising the present generations. So this is the resource allocation between society, economy, and environment. So it should be livable between, because if we talk about the society, the environment is also important. We cannot say all the resources should go for the economical development only. We need to invest some resources, some efforts, some money for the sake of environment and society as well. So sustainable development goals given by United Nations in 2015 and may be achieved by the 2030 as target has already been given. So these are the 17 sustainable development goals we can see. These are the 10 SDGs which can be achieved if we are managing our waste very well. So these are the SDGs partially or completely can be achieved. So these are the national missions of India. We can see there are so many sustainable habitat related with the waste management indirectly. Water mission, if we need clean water, again we need to manage our waste. So directly or indirectly, all are related with the waste management. This is the, if we talk about the resources, northern hemisphere countries are using more resources as compared to the southern hemisphere. So what we can do, we can raise this kind of the problems to the at the international forum so that resources allocation can be equitable. So this is a great story of great environmentalist Greta Thunberg. Everybody must be knowing about it. She at the age of, she started a strike at the schools at the age of 15 years and got a chance to give a speech in the United Nations and the ask to the future, ask to the leaders of the world, how dare you to spoil our future because of the climate change, because climate change has become a big problem, which is also indirectly related to the waste management. So these are the environmental segments. Everybody knows lithosphere, atmosphere, hydrosphere, biosphere. But what are the importance of these spheres? Perhaps we have forgot. We have to revive those. So food we are getting from the lithosphere, hydrosphere, water we are getting from the hydrosphere, oxygen we are getting from the atmosphere. Importance, without food we can survive months, without water we can survive maybe weeks, but without oxygen we cannot survive more than 5 minutes. So it is always less than 5 minutes. So we need to understand the value of environment and its ecological balance.
Sir, kindly conclude, please.
Yes, sir, please, sir. 2 minutes. So these are the some way forwards: public awareness, management of single-use plastics, best policy development, identification of key stakeholders and other things. So changes in behavior, tree plantation, public awareness, and social accountability can solve all the environmental problems. We have to understand it. So as per the Emmanuel Macron, President of France, by polluting the oceans, not mitigating CO2 emissions and destroying our biodiversity, we are killing our planet. Let us face it. There is no planet B. We have to understand it very well as early as possible. These are the some literature which I have published, books on the waste management, different e-waste, agriculture waste. These are the some research papers related to the waste management. These are the acknowledgements. I am always thankful to my Chitkara University, my mentors, my research collaborators, PhD scholars and fellow researchers for supporting me so that I could achieve this little whatever I have done. So adopting the strategy to reduce the waste and join the effort to make the earth smile again. Thank you so much. Save environment, save humanity.
Thank you very much, sir, for your nice talk. We have come to understand many factors regarding the management, of waste management and other things. So I hope that people will be getting benefited, especially the researchers, for future opportunities, and that will help in the career growth also. So, okay, so we have come to the end of the technical session, and now we will be starting the valedictory session. And I request the people to be here and to be in the valedictory session. As we will be starting the valedictory session, I will be handing over to Dr. Nidhi Shukla to conduct the valedictory session. Just give us a minute, you will be starting.
Sir, wait, we are calling for the student to not join here.
Good evening to everyone and welcome to the valedictory session of. So just a second.
Okay, start.
Okay. Good evening to everyone and welcome to the valedictory session of second National Conference on Technological Innovations and Environmental Sustainability. It has been an insightful journey with thought-provoking presentations and discussions on innovative technologies for environmental sustainability. We thank each one of you for your active participation, which has made this conference a grand success. To start this session, I would like to invite our esteemed guest of honor, Professor Dr. Krishnendu Mukhopadhyay, Professor. He is Professor in Department of Environmental Health Engineering, Faculty of Public Health at Sri Ramchandra Institute of Higher Education and Research in Chennai. Professor Mukhopadhyay is also affiliated with WHO Collaborating Center for Training in Occupational and Environmental Health and the ICMR Center for Air Quality, Climate and Health. Sir, we are honored to have you here. Please share your address with us. Over to you, sir.
Thank you, madam. Ladies and gentlemen, esteemed guests, distinguished speakers, and fellow delegates. Today is a very important day, as we were talking about. It's a Children's Day, National Children's Day, as well as the Diabetes Day, International Global Diabetes Day. Very important day for me also to be here among all the eminent speakers, very good scientists, very good university, very good administrators. I would like to take a moment to reflect on the incredible sessions we had today, including the luminous inaugural session of the second National Conference on Technological Innovation and Environmental Sustainability, NCTIES 2024. This gathering has been a glorious moment for me and has been discussed a lot in the part of collaborative research, innovation, and technological advancements. First and foremost, I would like to express my deepest gratitude to the Honorable Chancellor and Pro-Chancellor of Amity University, Vice Chancellor, Dr. R.S. Tomar. For him, actually, he had also made very good presentation, the oral presentation, and it was so inspiring. Some remarks also he has made for the students and for the entire community. His leadership and approach that reflected into today's conference has been outstanding. I was also thrilled to hear from Session's chief guest, Dr. Ayandar Arunachalam, sir, Director, ICAR CAFRI, Jhansi, Uttar Pradesh, and the guest of honor, Sri Shiv Sankarji. They spent and they elaborated nicely the objectives of this particular conference, and which is getting good momentum in future in the hands of the next generations. I would like to mention, special mention, particularly to the HOD, Professor Dr. Kuldeep Dwivedi, convener, second NCTIS 2024. And he is the, I think, HOD of the EVS, Amity University, Madhya Pradesh, Gwalior. And he is very fortunate to have a very nice team working with him, with all the faculty members and the student communities engaged to make this particular program success. Thus, conference was composed of 4 technical sessions, so many eminent speakers. As I was talking to, I can, if the time spares, I can take the name of all the members because they are really great people to me and my knowledge. Here, Professor Sapnil Rai, who was the co-chair also in my first session. The plenary lecture speaker was the Professor Neelam Pathak, madam. She also contributed very nice lecture on particularly some of the new topics I learned from him. That is the climate resilient crop, some vertical farming system, and I also got a new terminology with respect to generally what we say particulate matter, and she said the personalized medicine. So this is a very good area I had. On the other hand, for valedictory, actually, I missed some of the lectures from Professor Navakumar Mandal. I had some other assignment in the office I had to do. But Professor Mandal is very well known to me, and he's an eminent scientist of the country also. Abhishek Kumar Bharadwaj, Dr. Abhishek Kumar was co-chairing the session 2. Other plenary lectures, my heartfelt acknowledgement and respect to the Navakumar Mandal sir and Dr. Aditya Singh. The other technical session, the last one, where it was chaired by Dr. Binay Dwivedi and co-chaired by Dr. Ritabrata Malik. The plenary lecturers were Tadip Rai Chaudhary, sir. I missed your presentation, sir, unfortunately, but I could attend Dr. Arun Lal Srivastava, the last presenter. So with these sorts of things, I have seen that another parallel session was there, where actually I missed it, the parallel session, which was composed of another 2 lectures chaired by Dr. Pankaj Kumar Misra, co-chaired by Dr. Nidhi Sukla, and the plenary lecture was given by Dr. Vijay Tripathi and Dr. Hemant Nothal Patti. The other thing is the students' contribution. I was witnessing the students' presentations. A few I had a chance to go through. Very nice approach, particularly they need a little bit of guidance to make their presentations in safe, make their work in safe, and that will be a very nice work in future for the Amit University as well as for our academic community, and as well as research community. The conference to our young scientists and students, remember that your curiosity, creativity, and perseverance will shape the future of science. Embrace the challenges and opportunities ahead, and know that your contributions will make a lasting impact. So in these closing remarks, I can take a line, a quote from Gita, where Karmanne Vadika Rasti Ma Phalesi Padachanam. So in that case, you have a right to perform your prescribed duty, but you are not entitled to the fruits of action. Thank you once again for your participation, engagement, and commitment to advancing scientific knowledge. Let us continue to strive for excellence, push boundaries, and transform the world of science. So please join me applauding our speakers, organizers, and fellow delegates for making this forum an unforgettable experience.
Thank you very much, sir. Thank you, Professor Mukhopadhyay, sir, for your inspiring words and for sharing your invaluable insights with us. Next, I would like to invite Professor Dr. Swapnil Rai, sir. He is a professor in Department of Environmental Science at Amity School of Life Sciences, Amity University, Madhya Pradesh, to deliver the concluding remarks. Sir, over to you.
Nidhi, give me 1 minute. I have my camera
Okay,
is
sir.
not working. So I am starting my phone so that I will be visible to that.
Okay, sir.
Am I visible? हाँ वही कर रहा हूँ. Okay. So good afternoon to one and all present in the meeting. First of all, I am thankful to all the guests or all the speakers who gave their lectures and all the participants who participated in the conference and presented their paper. As we come to the end of this inspiring gathering, I am honored to offer a concluding remarks on behalf of the organizing committee of the second national conference on technological innovation and technology innovations and environmental sustainability 2024. The whole day today, we delved into the groundbreaking discussions, witnessed insightful presentations, which leads to the valuable networking. The conference has not only showcased the new ideas, but also reinforced our collaborative commitment to the sustainable future and for the sustainable environment. The presentations and the panel covered a wide spectrum from cutting-edge green technologies and renewable energy to advancement to the strategies for reducing carbon footprints and enhancing environmental resilience. It is encouraging to see such a convergence of ideas that prioritize both technological progress and ecological preservations, providing that the two can go hand in hand. One of the key takeaways from this conference has been the emphasis on collaborative actions. Innovative thrives when we work together, and sustainability efforts become more powerful and effective when we share across sectors, disciplines, and borders. We have seen examples of this in this joint initiative, partnership, and the research efforts presented here, all of which inspire hope for a sustainable future. Let us leave here with the renewed motivation to push the boundaries of what is possible. The knowledge and the insight gained during this conference should serve as a catalyst for ongoing research, policy development, and technological advancement. As we return to our respective fields, I encourage each of you to continue fostering a culture of innovation and sustainability. For the conference, we have received more than 100 abstracts, and most of the contributors of the abstract have presented their paper, research work, which shows the success of this conference. Our guest speakers of the inaugural session, Dr. A. Anuranchalam, Director CAFRI, and Sri Shiv Shankar ji, and the plenary speakers of 4 technical sessions, Professor K. Mukhopadhyay from SRI HER University, Chennai, Dr. Neelam Pathak from Ram Manohar Lohia, Awadh University, Faizabad, Dr. Nava K. Mandal, Bardhaman University, Kolkata, Dr. Aditya Singh of University of Warwick, UK, Dr. Tarik Roy Chaudhary Jadhav from the Jadhav University, Kolkata, Dr. Arun Lal Srivastava from Chitkara University, Himachal Pradesh, Dr. Pankaj Mishra from Amity Gwalior, Dr. Hemant Nuthapallapti from Shimano University from Japan. They have covered the wide aspects of the environmental issues, and with the possible solutions, which definitely our participants have taken the takeaways. They will take the takeaways and they will work upon. Finally, I would like to express our deepest gratitude to our keynote speakers, presenters, sponsors, and of course all participants for your invaluable contribution. Your dedication and passion are what makes events like this possible. We look forward to seeing you at a future gathering as we continue our journey toward a cleaner, greener, and more sustainable world. Thank you so much, and thank you to all. Dr. Nidhi, over to you.
Yes, sir. Thank you so much, sir, for your concluding remarks. Now, I would like to hear from our participants. I invite anyone who would like to share their feedback and experiences from this conference. Please feel free to unmute or raise your hand if you would like to share anything regarding this conference. Please, we need the participant feedback.
Yeah, any participant?
Okay,
would
yes,
like to
Arindam.
give-
Arindam is there, sir. Arindam is going to
yeah.
share something.
Yes, please.
It has been a very nice and informative session, and I would like to thank all the faculty members, and I truly benefited from this session. And yes, it was very enjoyable, very nice session. Thank you.
Thank you. Thank you.
Thank you very much, Arindam. Another participant who is going to share anything? Mangalam?
Hello.
Yes, yes. Please.
Mohini would like
Yes,
to speak.
Mohini.
Yes, please continue.
Yes, sir. I did not get my turn to present my poster still. I'm
Poster.
waiting from.
Pardon? Yes.
Yes, sir. I registered, sir. Abstract भी
yeah.
submit किया था मैंने.
Sir, there is.
Poster presentation था मेरा.
Which session you were, Mohini?
Sir, C25 number था sir मेरा. I'm still waiting.
Mohini.
I think a parallel session is still going on, no?
Yes, parallel session is still going on.
Because of the paucity of time and the number of papers that we had, since we had to conclude this conference validity function, so we had a parallel link generated, and the parallel session, I suppose, is still going on. Who is conducting that, Nidhi?
Dr. Abhishek sir is there, and he is basically.
And kindly share the link to Mohini so that she is able to present.
It is already shared, sir. It is already shared.
Mohini, kindly log in with the alternative link that we have provided.
Okay, sir.
You will definitely get an opportunity to present, because participants' presentation is of utmost
Okay, sir. Okay.
necessity in such deliberations.
Okay, sir. Thank you, sir.
Yeah. Okay. Thanks for let us know about the problem that you have faced, and we will definitely provide you the opportunity. Anyone participant who would like to give his feedback on any aspect, because your feedback will help us improve in future, and that is very important. Anyone?
Sir,
Yeah.
Yes, Mangalam, please.
So it was great national conference on environmental over sustainability. I've learned so much from every lecture, even though some have presented from research scholar and some teacher also, that I have learned various some studies from there that I will incorporate in my research and will achieve all the objective in a sustainable and in eco-friendly way. So it was really grateful to me to attend this lecture. Thank you.
Any other participant who wants to share their feedback or view? You can raise your hand. We are waiting for the response. Yes.
किताब थी.
I think we are having the feedback right now. So now we are moving.
No, you can ask the audience, anyone else, if.
Okay, okay, sir. Okay, sir.
Yeah.
Not only from the research scholars, we can also hear the feedback from the participants.
Yeah, participants and
If
even faculty members.
even faculty members can also give their feedback. Kindly raise your hand. We can just unmute you.
There is a message in the chat box. Madhurima Joradar. She is saying that some link, she's facing some problem in the link. Can you look into it? Malik?
Yes, sir.
Malik, please
Yes,
see
sir.
the chat box.
So she is asking for that another link. We'll discuss. We'll talk to her.
We are having the WhatsApp group and we have already shared the link. Both the link are shared there.
I think you can share it, reshare it.
Yes, sir. No problem at all.
Right. Okay, I think, yes. Yeah, the link has already been shared.
Yes,
It is
sir.
in the chat box. I can see that. The participants are requested to use that link to log into the parallel session that is still going on.
It is shared already, sir.
Yeah. She has acknowledged that. That's good. That's good. Okay, I think we can move to our next agenda.
Okay, sir. So thank you to all our participants for your feedback. It is heartening to hear your positive responses and reflections. Now we are moving on to much anticipated declaration. Just a second, just wait for a while. We are having.
Mukupoda sir, namaskar.
Namaskar, sir. Nice to see you, sir. Nice to see you.
Sir, really it is very heartening that you have devoted so much of your valuable time to us.
No problem, sir. No problem. I managed
We
it.
are
Sir.
highly obliged for that. Although I could not be in all the session, and particularly I really regret to have missed your session. There was a meeting called by the Honorable Vice Chancellor, so I had to
it happens,
go over there. Right.
Yeah.
But your benevolence, your love and affection for us, it's a great motivating factor for us.
Thank you, sir. Thank you. Namaskar. Thank you.
Okay, sir. I think we have to move now because we are
Now-
about to finish the parallel session as well. So now move on to the much
Okay,
anticipated.
that means only that participant was left for the presentation.
Yes, sir.
Okay, that's fine.
Declaration of the best paper presentations. I invite Dr. Deep Chakravarti, sir, Assistant Professor in Department of Environmental Science at MIT School of Life Sciences, to announce the winners. Sir, please, over to you.
Thank you, Dr. Nidhi, for your kind words. And throughout the day, we have heard so many scientific discussions and so many scientific innovations, future researcher, future scientist. So I am very happy to announce the best of 3 presentations, though all the other presentations are very good in nature, and they are, I hope they will do better in future, and they will do good research for our India itself. And based of 3 presentation, I have to declare with my heavy heart, but all the presentation is very good. So I'm announcing the third position. Third position for the best oral presentation is Anamika Ajayan. Anamika Ajayan, for the experimental investigation on the performance improvement of solar hybrid cooker. And she's from, she's a UG scholar, APJ Abdul Kalam Technological University, Kerala, India. So congratulations, Anamika.
Yeah, Anamika, if you are there, kindly open your camera, and if you can say a few words, that will be very good. Anamika, are you there?
Yes, sir, I'm there.
Okay, okay.
First of all, I'm very glad to be part of this much reputed national conference, and I'm having a first time experience of presenting a conference paper. So I'm just very glad that I am at the right place, and starting was very nice. So I am very much thankful. Thank you all the dignitaries for this wonderful opportunity, and thank you.
So you scored a century on the first debut itself. You got the third prize. That's equal to a century.
Thank you, sir. Thank you so much for your valuable words, sir.
Congratulations, and you will be receiving the certificate of appreciation on your mail ID within 1 or 2 days. Okay.
Thank you, sir. Thank you so much.
Okay.
Okay, Anamika, please stay with us.
Yeah, please. We can
so-
have a group photograph.
Yes.
And it's very, I regret because of my own personal reasons also. I wanted some of the dignitaries to be present here physically, particularly Mukhopadhyay sir. But due to certain constraints, the sessions had to be organized online. But I will try to have another conference, and that it is coming up. We have already proposed it in the month of March. International conference, and then I think I will not have to keep the our team will not have to keep the option of online. We will have it offline. Okay, next.
Message
we are going-
3 बजे.
So we are going for the announcing our second best oral presentation, and it goes to Mangalam Soni for the phytoremediation, its application to prevent post-toxic effect due to hydrocarbon spillage. And he is from Amity Institute of Biotechnology, Amity University, Madhya Pradesh, and also Department of Environmental Science, Amity University, Madhya Pradesh. So congratulations, Mangalam.
Thank you, sir.
You can open your camera,
yes,
Mangalam.
Yes, sir.
Yeah, congratulations.
Thank you, sir.
Okay. So our best of best oral presentation, that is the first position, goes to Ashwin Shashidharan, and for the performance investigations of a solar hybrid portable atmospheric water generator using adsorption thermoelectric cooling system. And he is from Energy Research Lab, Department of Mechanical Engineering, TKM College of Engineering, Kerala, India. So congratulations, Ashwin, to you.
Ashwin, you are there? Is there?
Ashwin, are you there?
I think he's not there.
Okay, anyway.
Hmm?
We will send him the certificate of appreciation on his mail ID. Okay?
Yes.
Right.
So that's it. And for the I request all the participants to just switch on your camera so that we can have a group photograph.
Yeah, please. Participants, faculty members, whoever are present in this meeting, they can switch on their camera, right?
And after that, we will go to vote of thanks to Dr. We'll go Dr. Ritabrata Malik, and first of all, we'll take a group photograph.
Vinay sir, if you are there, kindly open your camera.
Okay, started presentation.
Okay. Okay, I think you can have this.
Okay.
Yeah,
So
please open. Taken?
yes, sir. I think it is good.
Okay. Thank you.
Okay. Over to you, Dr. Nidhi.
Congratulations to all the awardees. Your hard work and contributions are truly commendable. To formally conclude this session, I now invite Dr. Rutabrata Malik, Organizing Secretary of NCTIES 2024, to deliver the vote of thanks. Dr. Malik, over to you.
Thank you, Dr. Nidhi. It has been a great day for this conference. I'm still starting with inaugural session till the concluding session with several presentations, plenary speakers, chief guest of honor. We have learned many things. So I would like to thank our Chief Patron, Dr. Ashok Chauhan, Honorable Founder, President, Patron, Dr. Ashim Chauhan, Honorable Chancellor, Chairman, Amity University, Madhya Pradesh, co-patron, Honorable Lieutenant General V.K. Sharma, AVSM, Pro-Chancellor, Amity University, Madhya Pradesh, Chairperson, Professor Dr. R.S. Tomar, Vice Chancellor, officiating Amity University, Madhya Pradesh, Co-Chairperson, Professor M.P. Kaushik, Pro-Vice Chancellor, and Dean Research, Amity University, Madhya Pradesh, our convener of the conference, Professor Kuldeep Dwivedi, also the head of the Department, Environmental Science, and as per the organizing committee is concerned, Professor Sapnil Rai, the Professor in the Department of Environmental Science, Dr. Abhishek Kumar Bharadwaj, Dr. Nidhi Shukla, Dr. Deep Chakrabarti. And along with that, other members who have been contributed significantly during the conference for many, in many aspects, like from Mr. Mangalam Soni, then Ms. Sonal Singh, Ashish Sharma, Hariom Tegi, Devendra Kumar, Sapna Sharma, Chitra Kumar, Kuldeep Soni, Prem Kumar Tripathi, Birendra Thakur, Vinay Vikram, Vikrant Singh, Merajuddin, Arindam Ghosh. So everybody has contributed significantly for the successful completion of organizing this conference. Right, starting with the inaugural session, I would like to thank our chief guest, Dr. Arunachalam, for contributing a great, significant speech and giving a thorough knowledge about different parts, different things at present day, how the environment should be conserved, and what our responsibility in conservation at present day scenario. And also, he has given some knowledge about the future generation, how to conserve water and other aspects. Then we have our guest of honor, Sri Shiv Shankar ji. He has given also some aspects of daily life, how in daily life we can sustain environment, how we can conserve environment, how we can go for the conservation of forest and trees, and how we can go for sustainable development. After that, in the technical session, we have Professor Krishnendu Mukhopadhyay. We will be thanking him as chairing the session and the first technical session, also delivering the first plenary lecture. And he has been given a detailed description regarding the public health engineering is concerned and given his topic. Then, as per the second plenary lecture is concerned in the technical session, Professor Dr. Neelam Pathak, as the head of the Department of Biochemistry, she has given his thorough knowledge about the different types of environmental parameters and other things where we had the participants have gathered different knowledge. After that, in the technical session 2, we had chaired Professor Navakumar Mandal. He has given his ideas on the nanotechnology and different types of experimental analysis where the environmental sustainability and different environmental parameters were considered. Then we have the plenary lecture by Dr. Adit Singh. He is from the Marie Curie Postdoctoral Fellow. He has also given his idea on the Raman effect and given thorough knowledge on that. After that, we have the plenary lecture by Professor Tarit Rai Chaudhary. Dr. Tarit Rai Chaudhary is from Jadavpur University Environmental Studies Department, who has given his knowledge and different database based on the arsenic contamination, groundwater contamination, impact on health, public health, and also the environment, where the participants have gathered different thorough knowledge about the arsenic contamination and groundwater pollution. After that, the plenary lecture 6 was given by Dr. Arunlal Srivastava. He has given his ideas on water contamination, water management, and also on the solid management, solid waste management, and given different database, different present day scenario, and the future perspectives. And on the last technical session, we have then Dr. Hemant Nutapalli, who has from Raman Center of Medical and Biological Applicants. He has given his knowledge on this topic and given some environmental aspects. So I would like to thank at the end all the participants participating from different parts of India. We have received more than 70 participants, their abstracts regarding the in participation with this, right from different institutes, research laboratories, research institute, different colleges, institutes, universities, not only the research scholars, but also even faculties as environmental science and other departments also has participated in this technological advancement and environmental sustainability, making this conference a grand success. I would also like to congratulate the participants who have been awarded the first, second, and third as the winner of the presentation. And we hope that in future also we will be getting the participation from different parts of the world, not only from India, from outside also like this. And there will be much more innovative ideas to come, and we can proceed with this as far the environmental sustainability is concerned. I thank everyone as a team member of our university and from the outsiders also for participation in this conference. Thank you very much for your contribution.
Thank you. Thank you.
Thank you, Dr. Malik, for your words of appreciation. With this, we conclude the second National Conference on Technological Innovations and Environmental Sustainability. A sincere thank you to all our distinguished speakers, participants, and the organizing team for making this event a success. We hope to see you again next year. Until then, take care and goodbye.
Thank you. Thank you all.
Thank you, sir. Thank you. Thank you to all the participants. Thanks.
Arvind ji, sir,
Thank you.
shall we close the meeting? Kuldeep sir?
Yeah, please.
Okay, Arvind ji, please close the meeting.
Sir, first wala close कीजिए, second wala